All right, guys. So this is a Google Cloud for Data Science class. So welcome. We'll go through quick intros in a second, real quick. But I want to set the expectations what this class is about. Um, Basically, we are going to introduce you guys to Google Cloud, but more towards the data science perspective, right? So, what are the prereqs for this class? Basically, interest in data science. Um, you don't need to be a data scientist, but any interest in data analytics, data science is what we're looking for. And also some basic Python knowledge is great. If you don't know Python, again, do not worry. It's such an easy language. I will give you guys some resources to so you guys can learn as we go along. And this is a very interactive class. So please ask question anytime. Either you can type in the chat window. I'll keep an eye open for that, or you can speak up as well. Okay. So here's the agenda. So this is a 2-day class. I'll kind of try to squeeze in as much as we can in 2 days, today and tomorrow. So today we're going to look at compute engine, storing data, and also visualizations. And tomorrow we'll get to queries with BigQuery, and also I want to show Spark as well, right? So the one you're looking, excuse me, the one you're looking at is a 4-day agenda. But we will sort of squeeze some of them. And of course, we're not going to cover all of them. So I'll try to cover maybe sort of about 3.5 days in the next 2 days. Okay. Yeah. All right. So again, if you've been in our class, you guys know I like to teach fundamentals and concepts, because once we understand this, then the APIs will make a lot of sense. And also, classes are highly interactive. Please ask questions anytime. And I had people in this class who said, they may have read a book, watched a couple of videos, but they never really got down to doing hands-on. And this class is a hands-on class. We definitely want you guys to do as many labs as you can to get the most out of this class. So quick introductions, and I do want to get to know a little bit more. So basically, my background, let's see, I have this one. So my name is Vijay Mani. I'm going to be teaching this class today and tomorrow. I am actually a founder of Elephant Scale. Elephant Scale is a company. We do training and consulting in basically AI, big data, and cloud. We actually started around 2013 when with basically Hadoop. I don't know if because is anybody here uses Hadoop or Spark. That's kind of how we got started. But these days we do plenty of big data and also a lot of data science and cloud instructions as well. A couple of books. We just published one, a course with O'Reilly for the video series, and my contact details are here as well. Right, so that's me. I'd love to know a little bit about you guys as well. So if you guys quickly tell me kind of your background a little bit, like what do you work on as you're an admin, developer, data scientist, and some of the technologies you're familiar with. And if you use Google Cloud before, or maybe any other cloud, maybe you used Amazon Cloud, right, or Azure Cloud. I kind of want to get your cloud familiarity as well. So what I'd like to do is maybe sort of go in the order. You guys show up on the Zoom window, right? So if you're not ready, I'll come back to you. Don't worry. So maybe Anil, do we have you? Would you mind giving a quick background? Yeah.
Hello, can you hear me?
Yes, go ahead, please.
Yeah, my name is Anil Nair, and I'm in the oil industry. I'm a data management software developer, software solution architect kind of position. That is my background. I have spent a lot of years in Java and .NET. Starting December, I was pulled into an Azure cloud project. This is the first time I'm working with the cloud, so unfamiliar with a lot of things. I'm still figuring out, but I have a project going on, so I'm learning as I do development. Familiarity with Python. In the current project, I'm using it, so like two, I can say. Familiarity with the Google Cloud, zero. Something non-technical
Good.
about you. Yeah, I mean, I'm new to cloud,
Gotcha.
so
No, no. I mean, that's why you are here.
yeah,
That's perfect. Yeah, yeah.
yeah. Something non-technical about you, and I don't come from a computer background. I come from a geology background. Picked up software engineering long time back. Um, yeah,
Gotcha.
uh,
Gotcha.
yeah,
Very good.
yeah.
Okay.
That's
Okay.
all.
Thank you, Anil. That's very, very helpful. And one thing you will notice is some of you may have worked on different clouds. A lot of the concepts are very similar, right? I would say 80, 90% of the functionality, if you use one
Yeah,
cloud, you can very easily map to another cloud. I mean, I'm sure they will have different terminology. They will call it a different name. The API is different, but it's very similar implementation functionality, right? And that's why, I always say like once you know one cloud, you pretty much know everything else. There's maybe like a 20% delta you need to learn to sort of the cloud specifics. But yeah, right? Yeah, that's very good. Thank you, Arnel. Um,
thank you.
let's see, Chris, do we have you? Christopher
Hey,
Pitts. Yeah.
how you guys this morning?
Hey, good morning. I can hear you. Yes, go on.
My name's Chris. My background is I am a software engineer, but I also run an education technology startup.
Oh,
Um,
cool.
yeah. So some of the technology I'm familiar with, Java, Python. Those are the primary two that I deal with most. I also build candy factories as well. So it's pretty.
Right.
So as far as my familiarity with Python, I would say it's about a 1 or 2. Google
Hmm.
Cloud at about a 2. And something non-technical about me is that I have lived in 3 different countries in the past 4 years:
Nice. Which countries?
Canada, Holland, and the U.S.
Right on. Very nice. Very nice. Always want to go to Holland. It's on my to-do list.
Yeah, we love it.
Yeah, yeah. Thank you, Chris. Let's see. Elias, do we have you?
Hello,
Yes.
this is Elias Chavarria. So I'm a software engineer working at Cisco for what we call the service provider business unit.
Hmm.
We sell big equipment to internet service providers. Think of Comcast and the likes. I'm familiar with C, a little bit of Java, a little bit of Python. So I'll put my Python in a scale of 2.
Hmm.
Google Cloud, 0. And something not technical about myself, I'm originally from Panama. My wife is Russian, and I have a 1.5-year-old.
Gotcha, gotcha. So yeah, so I hope you're getting enough sleep.
A little bit.
So
We are all working from home.
gotcha, exactly. Yeah, especially with yeah, everyone's working from home. Yeah, exactly. Yeah, yeah.
Yep.
Thank you, Elias. Thank you very much. Giant, let me know if you're here.
Yeah, can you
Yes,
hear me?
yes, please go ahead.
Hi everyone. Good morning. My name is Jayant Nair. My background is I'm also in oil and gas. I am a petroleum engineer by degree, but I'm also an amateur data scientist. I enjoy doing data science problems and I'm learning it. So I take online courses. And the reason I'm here actually is because for one of the projects that I was doing, I decided to use Google Colab and use Google Cloud to do it, but I
Hmm.
ran into a lot of issues and ended up abandoning that effort and ran everything on my local machine.
Yeah.
Fortunately, I had a GPU. But when I saw that there was a course which taught me how to use Google Cloud, I thought I might as well sign up because I had a lot of trouble the first time around.
Right,
Um,
right.
Technologies I'm familiar with. I do a lot of coding. For over the past 2 years, I've done a lot of coding in Python. So I would say I'm about a 3 on Python. In grad school, did a lot of MATLAB and Visual Basic coding.
Yep,
So
yep.
there's that. Familiarity with Google Cloud, I want to say like a 1 because I've used Google Colab before,
Hmm.
but I'm still not aware of how to, transfer data, start buckets, and I had a lot of trouble doing that.
Right, right. It's kind of funny, like you mentioned this because I had another data scientist with the same thing. It's just like sort of the basic building blocks, right? Well,
Right.
that kind of, this basic setup. Once you're familiar with this, it makes things so much easier. Yeah,
Right.
yeah.
Yeah.
Go ahead. Yeah, go.
Yeah.
Yeah.
I actually did take another course where where it was involved in AWS,
Hmm.
but that was a long time ago, and it was only for a day. So
Gotcha.
that, yeah. Something non-technical about me. I have two cats. That's what it.
Right on. Yeah, we have just the one, and yeah, I can tell you that's yeah, it's a bit of an undertaking. Yeah, more
I
than
know.
I planned.
Yes.
So yeah, very good, very good. Thank you,
All right.
John. Yeah.
Yep.
Hey, John, are you with us?
Yes, I'm here.
Go ahead, John. Yeah, I can hear you. Please.
Yeah, I'm John Chiolis. Let's see, my background. Yeah, that's kind of looks like the career path that's on there. Developer, systems person, manager. I'm currently a manager in a management consulting company based here in Houston. Our focus area is oil and gas and energy.
I see.
I just rolled off of projects for like 2.5 years with ExxonMobil, and I find myself with a lot of time, so I'm doing training on various products and technologies, and so even though I'm a manager, I still am a working manager like a lot of other people, very technical, get my hands dirty with the data. I have a bit background in data management, business intelligence, analytics. I've worked in a couple of different verticals. I've been in oil and gas for, I don't know, 14, 15, maybe longer, 17 years or something.
Ah,
I don't know.
gotcha.
So
Okay.
yeah, technologies I'm familiar with. You know, C, C++, Python, was kind of the flavor of the time kind of thing. Pick it up. A lot of SQL, PL SQL, T SQL, relational databases, that kind of thing. Python, I would say maybe 1.5. I'm kind of going through a class with that now.
Yep.
Google Cloud, I would say 1 at the most, because the only exposure I really had to it was the collab with the elephant scale machine learning class that was about a month and a half
Right.
ago, right?
Yep.
Yeah. And something non-technical about me. Let's see, you got pictures up there of people hiking and riding bike. I've done I love to go travel and backpacking. I've done a lot of backpacking. Probably been to every national park west of the Mississippi in the lower 48,
Nice.
and some
Okay.
places in Latin America too. So yeah, so I'm looking forward to the class and like to hear more about everybody else. Thank you.
Very good. Thank you, John. Thank you.
Thanks.
Let's see. Kanan, is it Kanan, right? I believe. Yeah.
Yeah,
Yes.
hi Suji, hi everyone.
Hey, go ahead.
Um, so, yeah, my name is Kanna Nair. Um, my background, I'm a team lead working for Adobe. Um, so, I have been into big data for last 4 5 years.
Nice.
Use most of the technologies that we use are Storm, Spark, HBase, Kafka,
Mm-hmm.
Elasticsearch.
Okay, more on the streaming side of things. Yeah.
Yeah.
Gotcha.
So I've been working with Java most of my times. Now with Spark, been writing some Scala code as well. With Python, I would say 1. I can manage things just because of the familiarity with other languages, but I haven't had a chance to really have to do anything in Python as much. We work with data science teams, but and integrate with them, but we don't really code on data science.
Gotcha.
Then familiarity with Google Cloud. I'm totally new to Google Cloud. We use AWS mostly.
Okay.
Azure also is there, but our team does not work as much on that. But I have done some certification in Azure as well. So
Good.
I have some familiarity there. Non-technical, nothing much, but yeah, we are expecting a baby in the next 10 days. So anxious times. That's all.
Oh, wow. Okay. Okay. So
Yeah,
any day now, huh? Okay. Interesting.
yeah,
Okay.
yeah, yeah.
Gotcha. Gotcha. All right.
All
Very
right.
good.
Yeah.
And since you're familiar with the Amazon, I mean, Amazon Cloud, what you'll find is you'll find a lot of similarities, right? How Google has done it. So as a company, Elephant Scale, we run on AWS. That's our infrastructure. We started using it pretty much from the early days on. And I remember we would have access to people who are developing it, like actual developers in Amazon.
Yeah.
And when we have issues, rather than opening tickets, we'll just email them. We'll say, hey, I'm trying to do this, it's not working. And and they will fix it, and they say, okay, now it's fixed. Reload and try again. That's how early we started. So back then they only had like 3 or 4 services. Now when I go to Amazon, page is like they're like 100 plus services. Right?
Right.
So some of them I'm like, I don't even know what this means, right? Anyway, I don't
Yeah.
want to read the doc. Anyway, so yeah, but so what I'm saying is, once you sort of understand one cloud concepts, they pretty well translate, like I would say, like 80% of the time to the other cloud. Yeah. So yeah, so as we go through, you will find yourself doing a little compare and contrast with Amazon and Azure, and you'll see. I mean, functionality wise, they are very similar, right? Yeah. Yeah.
Great. Thank you.
Good. Good. Great. Thank you, Conan. So Mike, how are you doing? Yeah.
Hi, yeah, my name is Mike Moreno, and yeah, so I'm based out here in California. I'm in marketing, so I'm a senior marketing manager, but worked at Cloudera, oddly enough, and studied computer science, so I have a good technical understanding of big data. From an overall technology, I'm familiar with all these technologies obviously from a marketing communication perspective and to some varying degrees. With Python, I'm a 1. I took an online class probably 2+ years ago. It's pretty intuitive. I knew Java pretty well because I studied computer science. Google Cloud, I'm also a 1. Just know the basics of what the different products are, but haven't used them. And then something non-technical, in 2014, I surfed in 4 different countries, and I was still a beginner surfer. I think that was pretty cool, pretty interesting.
That is pretty amazing.
Yeah.
Cool. Very cool, Mike. Thank you. And I'm noticing a lot of you are either getting started with Python. I have some resources for you guys, and I will show you guys once we're all done with the intros. Yeah, yeah. But this is good. Thanks, Mike. Yeah. Omar.
This is Omar.
Hey.
Yes. Go ahead.
So I've been with computer field for a very long time. Originally started with IBM, and then went to data warehousing. So I worked for about 16 years in data warehousing on IBM and also on Microsoft, and then later on Amazon. So AWS, like Redshift. But my background is mostly structured data. So now things have changed. So I want to get more toward the data science side. And so my right now skill on Python is maybe a 2. I haven't used Google. I used AWS. And my non-technical is I'm into hiking. 2 of my sons are Eagle Scouts. And my eldest son is now a medical doctor fighting COVID.
Wow. All right. Yeah, I know. So, I mean, this COVID has changed everything, right? Yeah.
My God.
Yeah. Very impressive. Thank you, Omar. And I know Eagle Scouts, I mean, that means you can spend a lot of time outdoors, I would imagine.
Yes, we did.
So,
we did.
Thanks, Omar. Yes, very good. Ram, are you with us? Yeah, please go ahead. Oh, I think you're still in mute, Ram. Otherwise, I'll come back to you. Oh, there we go. Okay, yeah.
Hi, my name is Ram Kotipatrani. I'm working as a Tableau developer since like 4 years onwards, and my technologies are Tableau and as a BI architect and Power BI and Tableau. and also using the SQL or Snowflake. Coming to the Python, I'm a beginner in the Python programming, but I have learned a little bit of data analysis using Python for automation purpose.
Gotcha.
Yeah, and Google Cloud is completely new. So non-technical right now, just watching the current affairs of international relationships.
Right.
Right.
Gotcha. Very good.
Right.
Thank you, Rob. Thank you very much.
Thank you.
Let's say Ramesh.
Good morning, all. So my background, first things first, Omar, I think it's your son fighting COVID. Kudos to him. Convey my best wishes and ask him to be safe.
Yep.
Yeah.
Yeah. Thank you. My background, I'm an engineer and currently lead a team of engineers. And my primary focus area is building data networking switches. Started life at Nortel and startups. So.
Oh yeah, I remember Nortel.
Oh, okay. So my familiarity with Python is, I would say, 1.5 to 2. And Google Cloud, same. I have some familiarity with AWS, but Google Cloud is, I played around with few things. That's one of the motivation for me to be in this course, to learn more about Google Cloud constructs and services. And non-technical thing about you. Okay, my favorite ice cream. Okay, the hobby, I'll talk about it. Anything, any flavor of ice cream is good for me. So recently I started to dabble with analog circuitry, primarily for the audio equipments. So just making my speakers and just playing around.
Interesting.
That's it.
Interesting. Cool. Okay. Yes, that's a neat hobby. Yep. Very good. Very good. Thank you, Ramesh. So thank you, guys. And the reason I sort of, just do this is you also get to see who else in the class. And one thing I just did is I set up a doc for you guys. If you want to sort of network with others, you can just just put in your details here, right? Here's my here's the link. It's actually in the class, right? The class doc right here. So if you click on the attendee doc, networking and QA, yeah, feel free to use that. In the past classes, a lot of people connect using this doc because that's part of the reason, right? It's like you want to actually network with somebody, and I heard a couple of you in the oil and gas industry, so just put your name and your email, or some contact people can contact you with, right? So I always encourage that because networking these days is very, very important, as you guys know. Okay. All right, guys. So that's that.
So yeah, I have a question.
Sure.
This class materials, I registered that link using the code, that code, but that page is not opening. So,
right. So actually, it's going to send you by email, right? So check your email, please.
Okay.
So it's going to send you by email. So it should send you like how many we have, so that should be about 8 documents. So what it does is each module it'll email you separately, right?
Oh, like that? Okay.
Yeah. Check your email. If they're missing, let me know. I'll resend them again.
Okay, fine. Thank you.
Okay, guys. I think we're done with logistics. Any other questions?
I got a quick question for you.
Please go ahead. Yeah.
Yeah. So when I go out to Microsoft's site, Azure, I'm really blown away by the amount of resources they have out there for training. I mean, it's sort of mind-boggling, really. Yep. And they've done a really good job of packaging it together. Of course, it's Microsoft, and the marketing piece of it. But it's just when I've tried to go out and look at the similar thing for Google, I don't get the same. The depth of the documentation. So could you say something a little bit about that?
It's true. Yeah. I mean, that's a good observation. So here's the thing, right? So as you guys know, Google is very good at the whole data center cloud technology because that's what they use internally. But when they made it public, it was more like they kind of built for themselves. You know what I'm saying, right? Google is Google Cloud technology. You will find a lot of the time is basically built by engineers for engineers. So sometimes, they assume everybody should know this, and they don't really have like, some of the documents and things like, you would expect. Microsoft has always been very good about onboarding developers. And I say this as a, not as a big user or a big fan of Microsoft. I always admired how much time and effort they spend on their developer network, like materials, tutorials, everything, right? Yeah.
Mhm.
So yeah, so that discrepancy you will always find that Microsoft has always been very good about kind of, developer docs, tutorials, and all this stuff. Google Cloud is, it's all there. You just need to kind of, poke around a little bit. I'll show you guys some of the, some of the docs they have. And also they're kind of, in Google Cloud, a lot of the stuff is in the GitHub, right? So if you go to GitHub and search Google Cloud, right, they have a huge GitHub repo. So they kind of, have the approach like, code is documentation, right? If you want to see this, just look at the code. Whether you agree or not, okay, that's a different story. Yeah, that's kind of the approach. And I'll give you some links as we go along. But yeah, overall your explanation is pretty accurate.
Great,
So,
thank you.
yeah. All right, guys, one thing very quickly, and we're going to get started. Again, so the reason I did this intro is just so, you also see who else is in the class and their background, right? And that's kind of, I always, find them interesting. All right, so you guys went through the checklist already. So it's, again, we are always keying from the this class notes, right? So checklist for the class, I want to quickly walk you guys through this. So here's a bunch of some of the Python resources. And I notice, a lot of you are from a different background and you're, learning Python. Same here, right? I'm more of a Java developer. It's kind of funny, like the whole thing was like, I was like a C developer. Then they told me, no, C is kind of old, learn C++. So, okay, sure, we learned that. And then they said, no, now it's just Java, right? So we learned that too. So now it's Python, right? So, so what's the next one? We'll see. There's something called Julia. I don't know if anyone heard about this one. So the languages are always evolving. So most of you come from different backgrounds. And one thing I would say about Python is very easy to learn, and it's a very good skill to have. So despite you, I always do like a, 1 to 4 scale. Doesn't matter. Most of you said you are like 1, 2. Even that is a very good skill to have. So I would highly recommend. So look through these resources, right? Some, they are free and they are pretty good. And kind of, Python is I always look at, my Python is always work in progress, right? So yeah, so kind of, just keep it hands on. That's it. All right, guys. What else? I think that's pretty much it. Any other questions before we get started, guys? All right. So let's get going. So the book I'm recommending here is so here's some links for the tutorials, and also, like I said, remember I said most of the Google examples are on GitHub, right? But again, in a GitHub, you kind of have to know what you're looking for, right? So again, it takes a bit of a clicking around to find what you're looking for. And this is a good book. This is actually done by one of the Google Cloud engineers, so it goes in pretty good detail on some of the features, right? So, all right, guys. So logistics. You guys, my contact is it's all in the doc right here, and slides are coming to you guys by email, and I'm going to distribute the labs when we get into it. And then, we are all going to work on Google Cloud. So there's nothing to set up on your laptop. All right, so. Okay, guys, so let's get started. Any other questions?
Excuse me, the email that we got, the labs, is from 5 to 9. We did not get 1 to 4.
Oh, right here. Interesting. I will, did you guys get, so 1 is missing, and I'll re-add 1. There was a mistake in it. I'll fix it and redo 1. But you should have gotten like 2, 3, 5, 6, 7, 8, 9. Did
I
you guys
got
all
5,
get that?
5 to 9.
Is that same for everybody else? Okay, let me resend it to you during a break. Let me know. I'll work with you. Yeah. So, and there are a couple missing. I'll show you guys how to get those. Yep. All right, guys. So let me kind of get going here. All right. So let's talk about Google Cloud Intro real quick. I did some of this during our preview class, but I want to zip through this real quick. So if you're very new to Google Cloud, it should give you a good background, right? So first of all, why are we going to cloud? Seems like a very basic question, but let's think about this for a second, all right? Think about how we did data science or data analytics. Most of us did it on our laptops because data was small, so you could fit the data in your laptop, and we could do pretty good analytics. And even today, a lot of people do this, and because your data is small enough that your laptop can handle, this is fine, right? However, as the data is getting bigger and bigger, right, laptops cannot scale. So what we have to do is we need to sort of find a way to scale data. So here's a kind of, what I'm saying is here's a, data scientist maybe working on a laptop, and I want to deploy my code on a large scale. So in a large scale, what you see is you see the data is also distributed. So these boxes are machines, right? Think of like distributed machines. So your data is also distributed, and also when you run your algorithms, your computation is also distributed, right? Because then this is the way to scale now, right? Scaling, this is called scaling horizontally, meaning running on as many machines as possible in parallel. But imagine if you don't have cloud access, then you have to build this infrastructure on your own. And a couple of you said you're using Spark. And if you have like a Spark cluster internally, you probably have a team of DevOps built and managing Spark and Hadoop cluster internally. And not everybody want to do this because this is a serious undertaking. And this is where actually cloud vendors really come in and they say, you know what, let us worry about the infrastructure. Don't worry about, standing up machines, maintaining machines, babysitting machines. They will take care of all this. Just worry about your data and code. And actually, that's a pretty good way to do computing, because in a lot of the companies they just want to run the analytics, right? They don't want to worry about infrastructure. So this is where the cloud comes in. And also, another problem we see is, let's say I'm a data scientist. Let's say I'm writing on a simple new algorithm on a small data on my laptop. Now I want to try this algorithm on a large scale. Usually data scientists, they rely on data engineers to deploy the code because they don't understand the infrastructure. They're kind of working on their laptop and they will say, here's my code. Can you deploy this on, on a large scale and test the code? So usually it involves multiple teams. And a lot of the time, data engineers have to re-implement the algorithms because, for example, let's say my data scientists use Python, but my infrastructure is running on, say, Java, Scala. So you cannot deploy Python code on Java, right? So at least not easily. So a lot of the time, data engineers will rewrite the code or algorithm in Java. And then as you can see, when you re-implement something, bugs come in, it takes time and all that. So this whole problem, how do you go from a laptop to the cluster? It's a non-trivial problem to solve. And this is actually called deployment gap. As in, so it's working on my laptop. Now, how do I deploy on my production? Right? So some of the issues was because the traditional setting, if you're doing everything in-house, let's say you have a cluster, right, working, right? And you have a DevOps team actually supporting the cluster. And then data engineers are really building pipelines, so ETL pipelines on top of the cluster. And as a data scientist, then they are using this infrastructure. So you have basically three teams of people, right? Data scientists, they rely on data engineers in turn rely on DevOps to keep the cluster running. So, and this is what we, how a lot of the internal infrastructure is done, because especially if you're not using cloud, you're kind of doing everything on your own, right? Somebody to build and manage the clusters, another build infrastructure on top of the cluster, and the data science team basically analyze the data on, is stored in the cluster, right? So it's going to kind of includes a bunch of different teams. So in the cloud, so the idea is kind of, basically automating all these infrastructure tasks so you can focus on your data, right? That's the idea. So the sort of the wish list is basically like, I always say we should treat infrastructure like hot water, right? Kind of like, imagine, it's like at home, right? We just open the tap, hot water comes out, and when we're done, we close the tap, and that's it. And we only pay for what we use. Like, we don't think about this, right? It's always there. That's how infrastructure should be, right? Always on demand. pay for what we use, right? And just don't even think about maintenance and everything else is done by the cloud vendors. So this is a trend right now. We are seeing a lot of companies kind of realizing, hey, this cloud can really sort of, how do you say, not just, it may not save you a lot of money, but it will actually enable you to do, move very quickly, right? So here's the idea, right? So all the cloud vendors, they're kind of providing basically what we call AI as a service or data science as a service, meaning they will take care of the infrastructure. We worry about our data and algorithm. That's it, right? And I think that's a pretty good it's a pretty good development. And pretty much all major cloud vendors have some version of this. And we are going to look at Google Cloud. All right, so let's talk about Google Cloud real quick. Any questions so far? So one of the question I have is, what about data engineers? Is a market for data engineers? How's it doing? So the term data engineers, right? I'll show you guys right here. Is right. So the term data engineers didn't exist 10 years ago, right? So this only started coming about when sort of the Hadoop, Spark, all the infrastructure start coming about. Now I see a new category. It's called machine learning engineers, right? Or AI engineers. So what this means is a lot of the data engineers are now kind of getting either kind of learning new skills and becoming machine learning engineers. So what it means is we take the machine learning algorithms, right, and then deploy on scale. So kind of all your engineering skills, or how to manage applications, how to run run code. Now you're running a different workload, machine learning, right? So somebody just told me the other day, because he's actually a manager trying to recruit, build his data engineering team. He said now machine learning engineers are much more in demand than even data scientists. As in they're hard to find and they demand more salary, right? So so this is like a new category of job, job description, just maybe in the I would say last 2-3 years came about. And because a lot of the data scientists, they don't know sort of the operational way of how to take my algorithm and code run it at scale, right? So that's where the machine learning engineers come into play. Yeah. So it's kind of an evolution. And I honestly think a lot of data engineers would be a perfect candidate for machine learning engineers because they know already 80% of the knowledge. They just need to do a little bit of machine learning, and that'll make them pretty attractive to employers. So anyway, that's pretty good question, right? So and please ask question anytime. You can type in the chat window for me, or speak up anytime. Yeah. Good, guys. Very good. So let's talk about Google Cloud. So just with any other cloud, right? Basically, all the infrastructure is taken care of. You get pretty much unlimited scale and only pay for what you use. And they take care of all the monitoring and everything. So just in case something goes wrong, you can go back and take a look. And ease of use, again, this can be sometimes subjective, but it is a pretty easy to use cloud platform, right? So we're going to look at all of these features and how we use them. So again, this is sort of the Gartner, right? If you keep an eye on this. Basically, the idea is you kind of want to be in this quadrant, right? That's the idea. And you can see all the major cloud vendors are here. So one thing that will surprise you, see AWS and Microsoft, they're a little ahead, right? Because Google, even though they have pretty good knowledge of cloud, they've been a little slow to make it public. Public as in publicly available, right? But if you're in this quadrant, that means you're a leader and a visionary, right? Basically, so. So Google Cloud, like every other cloud service, has tons of services. Here's a few I sort of and the way to sort of segment them. The way I look at them is sort of in 3 categories: compute, storage, dealing with big data, and services. So compute is basically, it's like you need some compute power. Like for example, you are developing a web application and just want to deploy your application on a scalable fashion, right? So you need a bunch of compute machines to run your web code, right? And they have something called compute engine that powers everything. And if you have containers like Docker, Kubernetes, they have the container engine. So all of these kind of fall into the compute silo. And then storage, right? Here's the, here, basically the most popular one is cloud storage. This is where the Google bucket, they call them buckets, right? But maybe you don't want to store in a bucket. You want to store in a database. And there are a bunch of databases too. Those are called Cloud SQL. And if you're looking for NoSQL database like Cassandra or HBase, Google SQL is called Bigtable. Actually, if you know a little history, Google Bigtable came first, and HBase is an open source implementation of Google Bigtable, right? So anyway, so that's kind of the story. So a lot of these open source ones, Hadoop, HBase, these are all open source implementations of Google technologies. So that's sort of the storage tier. And then if you have big data, this tag is specifically built for big data, like BigQuery is basically how to do SQL query for large amount of data. So think of like if you're familiar with Hadoop, think like Hive, right? So this is basically Hive on demand for big data. Data flow is basically think like your networking infrastructure. And for example, one of the things like pops up, this is your Kafka. This is a queue that's equal to say Apache Kafka, right? So you can sort of start mapping right away some of the open source ones and the Google Cloud specific, right? And also mind you, these are all hosted and maintained by Google, right? So very little effort involved in using these guys. And finally, the services, they are very high, sort of high in the stack. So for example, I want to do some translation. I don't want to, go and build a cluster, train my model. I just want to use a Google Translate API, right? So we simply call an API, and they will do the translation for me. They could be using any and all of these services, but we just could simply call a service, right? So here you're on a much higher level. You are worrying about more like a service level. So you're not thinking more like compute or storage or anything. You're just calling a service. And let's say you're running a prediction service, like you want to try to predict the weather or predict the stock market. They have prediction API, this too, right? So kind of, just different tiers. Does that kind of make sense, guys? Any question on this one? And these are some of the popular services. There are a lot more of these than this, because when you go into labs, you'll see there are tons of services, right? These are some of the popular ones I listed. Okay, so let's talk about some of these, right? Compute, storage, databases, networking, and big data, right? So that's a basic overview. So this is something I want you guys to understand very well, because if you understand this, then the Google Cloud will make a lot of sense. So the way Google Cloud is organized, they call what they call the resource hierarchy. So let's start with the top. On the top, we have domain, right? And we have organizations, then projects and resources. So I'm going to walk you guys through the one by one, because this sometimes confuses a lot of people on how to organize data into Google Cloud. All right. So let's look at the top category, domain. So domain is things like your company, right? So let's say elephantscale.com, our company, let's say we are hosted on Google, right? So we are, but even if you're not, you can create like what we call identity account. So let's say you are walmart.com. So you will have a Google identity for the top level domain. So everybody who has a walmart.com email can be part of the domain, right? So again, you can either get the domain hosted by Google, or just simply register for an identity account. So that's your top level domain, right? So everything you're going to use is going to be under your domain account. Then we have what we call organizations and folders, right? So let's say, let's take Walmart, for example, they would have multiple organizations. One could be marketing, one could be R&D, right? One could be engineering. So all of these are organizations. And each of them, they're going to have their own resources and own projects. So again, you're sort of segmenting, right? Under a domain, you might have multiple departments. And basically folders are a way to kind of organize things in a neat fashion. So let's say you're doing a new initiative. Let's say you're doing things like online order pickup. So under that folder, you may have multiple projects running. So, and finally, projects. This is what's important, really important in all of this, because basically you need a project in Google Cloud to basically do, before you can do any work. So projects are sort of the top level container hierarchy, and they contain everything else. For example, let's say you're going to spin up a VM. You're going to spin up a database. Everything is under one project. And this is what you guys will see today, because since you're going to be using individual accounts, right? You don't have sort of the this organization, domain level, right, setup, you're going to just start with the project, right? So all the resources are under one project, and you can have multiple projects, right? And also important to understand billing, right? Billing can be attached to many projects. So for example, let's say my department has a billing account, and my department has, let's say, 10 projects running, and they all tack onto the billing. So in our case, basically, we are going to use our own billing, let's say your credit card, right? That's going to be attached to projects. Is that going to make sense, guys? Sort of the hierarchy, right? Domain, organizations, and then projects, right? And then billing is sort of like a separate hierarchy. Okay. So I'm going to pause here for a second if you have any questions, because once you understand this, then a lot of the mysteries of Google Cloud will make sense. The hierarchy. Okay. Now, one of the questions I was asked is, how's billing going to work for individuals? There are two approaches here. One, if you're using Google Credit, right? I think they give you like a $300 worth of credit. That's good for 1 year. So when you sign up, and every Google account has this, so you can use that. So as you use your resources, they'll be kind of deducting your credit. Otherwise, even if you don't have credits, or if your credit's expired, I would say just enter your credit card, because for this class we are not going to go above at least not even like $10, right? Because what we have the labs and everything we use, we'll keep them small. So you're not running a big bills. So in the past, when we ran these classes, $10, $15 is kind of the typical expense. So yeah, so right. So if you're someone sitting on a fence, it's not going to cost you hundreds of dollars. It's going to be just 10, 20 at most. So yeah, I think that's well worth the effort anyway. I always say you have to invest in your own self, right? So $10 to learn a new skill is a pretty good bargain. So yeah, that's one of the questions people ask me, email me and say, hey, I don't have credits. How much should I, how much do you think I'm going to spend on this class, right? As in like the Google Cloud. Yeah, I can do like 10, 20 bucks at most. All right. All right, guys, so that's the hierarchy. Okay, and here are some use cases. I'm not going to go through all of these, but basically they have a portal called cloud.google.com. So basically everything lives in cloud.google.com. And then /customers, there are some customer success stories, how people use. So, it's a lot of marketing, of course, right? But there are some use cases, these kind of sort of isolated. They can go into how they migrated their in-house setup into cloud. So kind of worth watching, right? So I recommend when you guys get a few minutes, sort of go through some of these videos. They give you a pretty good insight on how people are using cloud. I always, I'm a big fan of learning from others. Yeah, kind of watch these videos when you get a chance. All right, guys. So we are going to, like I said, this is a very hands-on class. We are going to jump into Google Cloud right away. Before we start the lab, any questions, guys? Let me also upload the project files. Give me 1 second. The labs. Let me quickly upload the labs here. So I'm gonna upload the labs into the individual class folder. All right, guys, it's uploading now. So if you are in your class notes section, please come and find the section. I have a link for class folder. All right. So please click on that, and you should see it's still uploading. It should be done in a few seconds. There are two things I like you to download. One is the lab zip file. Go and download that, please, on your laptop. And also, there's an Excel spreadsheet here too for you, for your consideration. So download that as well. And I will walk you through both of them in a second. So the question is, in the access management, is access managed for all using the domain? Yeah, that's a good question. So the way access is managed, right? So the way access is managed, excuse me. So it's basically, right, so you have to be a user under the domain, right? And as a user, you can belong to multiple projects. So that your access is basically controlled at the project level. So let's say, I'm working on, say, 3 projects. So in one project, I may be an admin. In another project, I may be a developer. In another project, I may be just, just a viewer. Viewer is basically, read only, right? Maybe I can read reports and things like that. So yeah, so the access controls are controlled at a user per project level. And when you can set up your project, I will show you guys how it's done. You guys will make yourself as admins, but you can give like different access point. For example, you can say this person cannot create databases, but he can read from existing database, things like that. Yeah, it's very fine grained. I'll show you guys when you do the labs. Good question. Yeah. All right, guys. So I guess I will download these two, right? Zip file and Excel spreadsheet. So let me quickly walk you through the Excel spreadsheet. So this is something we put together for more like a self-evaluation. You can see my screen. So people ask me, I want to do some data science. What sort of skills do we need? And it's not always one skill. There's usually like a bunch of skills together to make a good data scientist, right? So I cannot put like a little, a bunch of. So for example, how good is your data visualization skill? Meaning, can you even a data? Can you visualize data? Could be using Python, could be using Excel, doesn't matter, right? Some visualizing, or could be using Tableau. I heard some of you are using Tableau as well, right? So scale of 1 to 10, right? Let's say my data visualizing, okay, maybe I'm like a 6, right? How's my machine learning? Okay, maybe I'm like an 8, right? So basically, give yourself a little, little score 1 to 10. It's just for you, right? I mean, you're not sharing with me or anybody else. And how's my math? I don't know, maybe my math is 4. It's how's my stats? Okay, I was not a big fan of stats, maybe a 4. Anyway, you guys get the idea, right? Basically, a score of 1 to 10, it's a self-assessment. The reason I do this is so you can sort of say, okay, which of these I'm pretty strong at, which one I need to go, maybe develop some skills. That's it. That's all it is. It's a little self-evaluation for you guys to. So, for example, if you want to, in the other, maybe you want to say something like, say Python, right? And then you can give yourself a score. So, yeah, that's it. Anyway, this is for you guys to kind of play around a little bit, just a little self-assessment, right? That's it. Nothing more, nothing less. So, give it a try. And you can add as many skills as you want, right? Like for example, let's say yeah, I heard a couple of you guys are working in oil and gas, and maybe there's like a certain skill that you need to develop, right? So just put it in there, give yourself a score, right? So because I'm always a big believer, and some of you guys know me from other classes and other interaction. I'm always a big believer in developing your own skills, right? Doesn't matter whether you work for a company or work for yourself. Always you need to keep your skills sharp. So I always kind of do this kind of a self-evaluation, like every few months say, okay, hey, what's the hardest thing? What do I know? Do I need to go learn something, right? So it's always a good thing to do. All right, so that's that. I'll stop this here. All right, now the for the labs, once you guys download it, please go and unzip the lab on your machine. And this is important because if you're on Windows, if you simply click on the zip file, it'll actually take you inside the zip file. We actually need you guys to actually unzip, right? So please go ahead and do that. Okay, so okay, it's just like extract. Okay. And then when you guys go into the directory, you should see a bunch. Right. Bunch of directories. What I want you guys to do is you see a README file here. Please go ahead and open the README file. Right. Simply just double click on it. It should open a browser. That's it again. So just kind of one more time working through this, you guys are downloading the zip file to your laptop and make sure you unzip this. All right. Because if you just simply click on the zip file, it'll just open the zip file. That's not what we want. We actually want you guys to unzip the zip file. once you guys done that, go in there and you see a readme.html file, just a straightforward HTML file. Just double click open in any browser is fine. Okay. And you should see the our lab listing. Okay. All right. So if you guys are at this point, can you guys give me like a little yes, like a green check on your Zoom, so I know you guys are able to do this, please. Yeah. So if you look in your Zoom participation window, you should see like at the bottom, you should see like a bunch of buttons, right? So give me like a little yes, green check, so I know you're able to get this done. And if you're having any trouble, please, let me know either in the chat window, you can speak up, because I want to make sure you guys have access to all the labs. Yeah. All right. Very good. All right, guys. So this is the lab lab files, and this is for for you guys to keep. So let me walk you guys through this real quick. Right. So here we'll talk about how do you get some data. Like for example, if you understand data analytics, first thing you need some data, right? So you can get our data copy. So we manage some data files here. You can click and download this. It's about 200-300 meg download, and I'm guessing most of you are working from home, so you should have pretty good bandwidth. Download that, right? And also here are a couple of other data repositories as well. Kaggle has a pretty good repo. There are a lot of real world data sets, right? So if you're looking for some data to play around with, these are good places to visit. Okay. Okay. So we are going to work through the setup. So here's what, let's do this. Let's look at the time. So let's set up our Google Cloud, and then we'll take our morning break. Okay. So right here, we're going to do setup one, right? So simply go ahead and click on this one, right? And basically follow step 1, 2, 3, right? Walk through this, right? And some of the screenshots may not work for you. Like for example, if you have Google Cloud already signed up, then you don't have to go through the sign up process, right? But if you're going for the first time, then see here's like a $300 credit, right? So anyway, so what we are going to do, guys, is we're going to walk through setup one lab. So simply click on this, and when you click on this, if the link is not working, that means you haven't unzipped your file yet, right? You're kind of looking at into your zip archive. So first thing I want you guys to do is go ahead and unzip the file, right? So, all right, so let's go through this one. So what we're going to do, right? Let me walk through this with you can walk through with me. Basically, we want to go to cloud.google.com, right? You can sort of click on the link, right? Actually, yeah, sorry. I'll open a different tab. Yeah, okay. Cloud.google.com, right? And basically, and if it's the first time you're going through this one, the zip file is, guys, actually, I'm not emailing the zip file to you guys. You're actually downloading it. So from your, right? So in your class notes section, right? Scroll down a bit to the second page. Look at the class shared folder. Let me highlight this real quick here. All right. The one in green highlight, class shared folder. Go ahead and click on that. Okay. And then there you would see the zip file. Okay, go ahead and download that, please. As you can simply right click and download, or just simply double click and download. Either way, it should download to your computer. Right, and once you download it, go ahead and unzip. It's just a zip file. Go ahead and go ahead and unzip the file. Okay, just say extract it. Right, so basically once you unzip this, you should be able to just use this file. I'll just keep the README file open. So just simply open the README file, README.html, just simply double click on it, and yeah, right, and it'll come up on your browser, and then we're going to follow the README file. Yep, that's it. All right, so I was in a README file, all right, and we are going to do setup one. Okay, we're going to set up your Google Cloud account. So I'm going to walk you just through this one. I mean, we provide some screenshots just so you can sort of follow along, basically, right? Basic idea is, you just want to go to, cloud.google.com, right? Just, open a new tab, and then basically you should see go to console, right? So it's the first time, so right there, or right here, go to console, right? That's it, right? So I mean, yours might look a little different than mine because I have some stuff going on already. So yours might look a little blank, and that's fine. As long as you're in the, that looks something like this, you're good, right? So, all right, guys. So I want to make sure, please, don't be shy. If you have any issues, please let me know, right? Because I want these steps to work, because everything else kind of depends on this. Okay, so step one, cloud.google.com, and then go to console. Okay. If the first time you're going through, just go through the motion, kind of, click on the, agreements and everything, right? And they give you a credit, or, you set up your payment, either way, right? Yeah. Basically, if you can look at the, right, if you're looking at something like this is good. And again, like I said, your screenshot might look a little different than mine, but basically it should look like, just should drop into something like Google Cloud Platform, right? All right, so excuse me. Now is let's see. Now is as a good a time as I need to take a quick break. Maybe take a 10-minute break. Let's start back around say 10:30, which is Pacific. So which is you can sort of do the math. So let's start back around say 10:30 PS PST, right? And then we'll break for lunch around say 11:30. Yeah. Okay. All right, guys. So if you have Google Cloud access, you're good. Go ahead and take a break, and I will see you guys back here in 10 minutes. Yeah. If you have any questions, please stick around, and I can help you with the any issues you got. Okay?
Suji, I need a little help here. Are you
sure?
Okay. So I'm in the platform.
Okay. So what we just did, right? So again, I know a couple of you just joined us. I want to quickly run through the setup real quick, right? So if you just joined us, I'm sharing my screen. You are already in the class notes section. So come in to the second page, and you should see a link for the class shared folder. Okay. And please click open that. Okay. And from the shared folder, please download the lab file. It says, data science GCP labs.zip. Please download the zip file. And go and unzip the file on your computer. And then when you have the file open, the package unzipped, go ahead and just simply open the README file. Okay. So README.html, simply click on this one. And this is the lab guide we are going to go through. So the README file should look something like this. So we are just went through the setup one instruction, meaning basically accessing Google Cloud, right? So basically, if you can go to cloud.google.com, let me put the link in the Zoom window as well, right? And go to console, that's it. And if you're able to come to a page that looks like this, we are good. That's it. Okay. All right, guys. So I hope everybody's in the Google Cloud platform. Yeah. So we are going to do the next lab. Again, like I said, we are going to focus heavily on the labs to give you hands-on experience. So we have access to cloud platform. Just follow the guide, right? But as long as you are in a page that looks like this may look a little empty for you guys because you probably haven't started any services, and that's fine. More or less the same, right? All right. So back to README. Then what we are going to do is we are going to do setup 3. Now, don't worry about setup 2. That's optional. That's if we are using Quick Labs, which we are not. So basically, what this Quick Labs is, this is something we use when we teach our enterprise clients. Is basically, Quick Labs is basically a sandbox. Let's say, because some companies, they will not allow access to Google Cloud or any cloud for that matter. So if I just simply say, okay, guys, go to Google Cloud, they won't be able to go to. So what we do usually, we use Quick Labs. What Quick Labs does is it gives you like a little sandbox to do your work. But the thing is, these sandboxes are on a timer. So they will give you like a 1 hour sandbox, right? So the countdown will start as soon as you log in. And then after 1 hour, that environment will just go away. So everything you guys have done, all the projects, all the code, everything you've done, it just goes, right? So we only use Quick Labs in like highly restrictive environments. So in this case, we are not using it, just to be clear, right? Because I want you guys to use your own Google account. So this way you can keep all your code. Anyway, so that's that. So we are not using this, so do not worry about this. But so let's go to setup 3, which is setting up a project. Okay. So go ahead and click on this one, please. Project setup. So again, follow the instructions here, but I'm going to also walk you through this. So if you're in Google Cloud, so see here where my mouse is going. This is the project dropdown. So you can see, I have a bunch of projects set up already. Sometimes when you sign up for this, they might already set up your first project. It will call like something called my first project. And that's fine, right? You can use this. But if you want to do a new one, just simply say new project. I recommend you guys do this just so you guys can go through the motion, right? Say new project, right? And I'm gonna walk you through the wizard. So just give it a project name. So you can say, right? Google Cloud class or whatever, right? And then for the location, it might just, yours might be sort of blanked out because it's going to use your personal account because, you can see mine is under my company, right? Yours might be a little different, but, as long as you have a Google Cloud account, that's fine, right? And just say create, that's it. Okay. All right, so it'll take a take a minute to kind of for them to initialize all the projects, because remember, right, and you'll get like a little notification, right? And yeah, it's done. It's good. The reason we are creating a project, remember, is because remember this diagram, right? To use Google Cloud, we need a project because all the resources we are going to use, like databases, VMs, everything is going to be tied to a project. Yeah, so that's why we need a project. And another thing I would notice is sometimes when you create a new project, they don't switch you to the new project. So you have to manually switch, like this drop-down menu, and then switch to the project you just created. Yeah.
Excuse me, how do you find the project page?
Oh, here, yeah, sure. So project page is right on the drop-down. Yeah, there's not like a separate page. So here, see this drop-down. I'm look at my mouse, right? On the top corner, yeah, that's where the project. So when you click on the drop-down, you'll see a list of your projects. You may see like maybe 1 or 2. And then, just, if you want to create a new project, just do new. And make sure the right project is selected, right? Because sometimes even when you create a new project, they don't automatically select you to the project. So to drop down and select, the right project. Yep. And as you can see, here's like a top level thing, like, so I will say, project ID, project number, all this stuff, right? You can add people to the project. Here's your billing, right? So all this should be in this page right now. How's everyone doing here? How you be? All right. Okay. Any questions, guys? Issues, please let me know, right? Because I want to make sure these 2 steps go flawlessly, because pretty much everything else we do after this depends on, you having a successful project created. Yeah.
So I created the project. How do I go to the project?
Oh yeah, so it's basically, just drop down right here. By the way, I don't know in Zoom, do you guys see my mouse in Zoom? I don't know if you can see that or not.
We can see it.
Yeah, right the drop down, right? So you should see like.
Let me go.
Yeah, and then click on the drop down and then choose the project. Yep. And remember, so to create a project, they will need a billing, some sort of a billing setup, right? Right. So if you look at the setup, right? Remember, projects are attached to a billing because we are going to create resources under project, like a database. So some BigQuery, whatever, right? So they need you to have billing. Does Google ask you to, even when you have free credits, do they ask you for your credit card? I'm not sure what they do now. Even when is anybody using free credits right now? And if you are, do they still ask you to enter like a credit card as a backup?
I don't recall they asking, but they could have tied it to my Google payments.
Yeah, like a your Android payment kind of thing.
Yeah.
The App Store. Yeah, exactly. Yep. Yeah, makes sense. Good, guys. All right. Again, so I'm kind of pausing here for a couple of minutes just because I want to make sure everybody is able to create your own project. Again, so let me walk you through one more time,
I got a
guys.
question when you have a chance. Sorry.
Sure. Let me quickly walk through the project creation one more time, right? So once you're in Google Console, right? See this top drop-down box? Click on this and you want to say create new project. Basically, just have to give the project name, right? Whatever right? So some name you just want, right? You can say Sushi 1 or something. Doesn't matter, whatever name you just want, right? And that should be it. And if you don't have payments tied up, they may ask you to enter your payments stuff here. So don't be alarmed. Like I said, even if they ask you for your personal credit card, like I said, we're not going to go beyond, 10 bucks, right? So yeah, so don't let that deter you guys. All right. And then make sure your project is selected. Like when in the drop down, you select the project, right? Because everything you see here is tied under this project. All right, is any question on this one? John, I know you had one. Go ahead, please.
No, yeah. So I had created. I got a little confused. I created for the preview class. I had created a project. So I guess I have 2 now projects, right? I guess, right?
You can use the one. So yeah. So my preview class project was this one too, right? Yeah, exactly. You can use that one. Yep.
Okay.
So if you have one, all you need is a working project. That's it. Yep.
Oh, okay.
And you can see, I have a bunch of these, based on the, based on what I work on. Yeah. So new one or the preview class one will work just fine. Yep. Good, guys. Very good. And so we are working through the project page. So we create a new project. Okay. And then, all right, if you look at the project homepage, here's where you control access to people, right? So we don't have to do it because you guys are all doing solo. But let's say you're part of a company. So let me kind of walk through the real quick. You say, okay, I'm going to add some people here, right? So let's say so again, this is my company, Elephant Scale, right? So they're going to say, let's say, let me grab Mark, right? So Mark is a so you can see his email, elephantScale.com. But then I can actually give him the access. I can say, what do I want? Do I want him to be like project level? You can say I'm an owner, meaning he has complete access to all the project. Or you can say browser, meaning he can he can only look at just resources like what we have. View basically meaning read-only access. So let's say, I create a report, Mark can read it, but he cannot make any changes, right? So they're like, editor basically means, you can create reports and things like that. Anyway, right? So you get the idea, right? So you can do like project level access, or you can do even resource level access. For example, let me show you guys. Okay, so let's say I want, he's writing some app engine code. App engine is basically your web applications, right? And then you can say, oh yes, this person can access all App Engine resources. So App Engine admin, right? So you can even narrow down on a per resource basis, right? Or you want this person to, just do BigQuery. Let's say, okay, he can only do BigQuery, viewer, meaning he can only, look at queries. So as you can see, the access control is very fine grained. You can either do project level or like, or like service level. And each level basically you have admin, which is, right, full control. Editor basically meaning you can actually, create and, create new projects. Viewer, read only. Worker meaning you can use as in like, you can deploy things, right? But you cannot change any running resources. You cannot like shut down or start new ones, right? Yeah. So, anywho, right? So is that gonna make sense, guys? So that's how you will add new people to the project. Any question on this one, guys? Okay, excellent, right? So I'm going to cancel out of this because I don't need to add anybody else, but this is how you would actually control other people, right? So basically, anybody in your domain, and I think also you can add anybody with the Google account, right? So let's say you're collaborating with somebody, right? You can add them with the right permission. That's it. All right, guys, so good. What else I want to highlight here? That's it, right? So what we have done here, guys, is we basically went through the setup. We did setup 1 to make sure we have access to Google Cloud. Setup 3, right, for project setup. We didn't use setup 2 because remember, we are not using quick labs, so we are skipping over this one. Okay. Now, if you're running a local machine, right, so again, this is basically, not really required, but kind of, if you're doing this, I'm sort of walking you through some of the basic setup, like if you want to install Anaconda for data science, right, all that. Again, we don't need this for this class. This is more of, if you're interested in setting up your own machine, right? So again, we are skipping over this section. Yep. All right, good, good, good. So everyone's with me so far? Okay. And then let's do this right now also, since we have access to this. So let's do start 1 also, please. Right. So very simply click on this Google Shell setup. Right. So one of the one of the nice features of Google Cloud is they actually give you command line access. Very simple. Right. So what you're going to do, make sure you're in your Google Cloud, environment. Okay. And then you will see a little thing that says, activate Cloud Shell. Right, look at the screenshot here, step 2. Again, so just one, sorry, okay, I kind of went from here, right? From your README file, right, which is out there. We are doing start 1, right? Cloud Shell setup. So you guys are already in the Google Cloud platform. Look for a little, shell icon on the top right corner. Okay, see right there. You know how it says activate Cloud Shell? Go ahead and click on that, please. So you'll see like a little thing, coming up at the bottom, the terminal coming up at the bottom. The first time you do this will take some time, a few seconds to up to a minute. Okay. So this is basically command line access to your Google Cloud. Is everyone able to find this? Like, right on the top right corner, there should be an activate Google Cloud Shell, right? So again, it will take some time, first time you use it. Okay. There you go. All right. Is everyone able to get this like this terminal window at the bottom? You can see my screen here. Yeah.
It's still loading for me.
Yeah, it'll take some time. It'll take some time. So what is happening is, let me actually show you guys what's what they're doing. Is let me share a whiteboard real quick. Actually, hold on. Sorry, let me do this. Okay. All right. So what's happening is, so they're providing an edge node, right? So 1 second. Okay. I'm trying to write. All right. Let me draw here. That's easier. So what's happening is, so let's say this is my laptop here, right? And here's sort of a Google Cloud environment, right? So what they're providing is like a little edge node right here for us to log in, right? So this is what we call edge node. So the Cloud Shell is sitting on an edge node. So what you can do is you can actually connect to the Cloud Shell from your laptop, and then from the Cloud Shell you have access to all the Google Cloud resources. They're gonna make sense. So they don't want to open up all the resources to the outside world. So what they do is they give you access to an edge node, also known as jump host, right? Because so different names: jump host, edge node, or access, right? Access node. We call them different ways. Anyway, so the idea is, right? You actually log into this node, and then you can access all the resources. That's it. Right? Honestly, this is one of my favorite features, because if you work with AWS, even sometimes logging into AWS can take a little effort. Like you need the key, right? SSH keys and all that, and you set up the firewall access. It can be a little bit of a pain to even just log in. But here, right, cloud access is right then, right? And this is a regular Linux shell. You can just type a Linux command, say ls right here, what I'm typing, right? And you can see, you can see, I already had some files. Yours probably might be empty, right? So this is pretty neat. I really think they really thought through how people get access to the environment. So what you're getting is, like, remember, so the way it works is they're actually spinning up a machine. Probably not spinning up a machine, but they're doing, they're initializing a session, and also running on a machine that you already have running. Right? I'm sure, because my machine is shared with like a lot of other people. Right?
Do you have to be an admin to access this, or you can be a viewer and still access?
Good question. I'm not sure if you're a viewer and can access this, because this gives you pretty good access to. That's an interesting question. I need to check on this one. My answer is you should be able to, even though you may not be able to do much. Right? You can only list resources, but you cannot change anything. I think you should be able to. I'm guessing, right? Yeah. Even though I haven't tried it personally. Yeah.
Okay. Thanks.
Is anybody getting any error or anything else in this one? It should just work out of the box. Any issues, right? And this shell has, so the Google Cloud command line is called gcloud. So if we just type gcloud, this is the, that's your command line, and you have full access, to all the commands. Right? So, right. So again, and here you're saying, hey, if you want to change the project, right? Here's what you do. So you say gcloud, gcloud config set project and project ID. Where's the project ID? This can see right here. Right? So we go to your project list, see the project ID. So if you want to, let's say I want to change it, say Hadoop, whatever, right? So just copy that, and that's your project ID. And the IDs are unique, remember, because your name, right? And this is something confusing to people. Name is just a, just a user-friendly name, right? The ID is like a unique, like like in your database, you have an ID for each record, same thing, right? So the ID, and sometimes you can see, right? They can generate the ID, like for example, this is the ID they generated, like possible loaders, right? And this is a pretty popular thing now, generating names this way. I think Docker is the first one to popularize this. Like they will do like 2 words, random words, right? To name a Docker ID. But yeah, so now they're doing, Google is doing this too. Anyway, So that's your project ID. If you're wondering where the project ID is, you can just simply copy from here. Yep. So let's say you have a shell, and you say, okay, I want to change this. So you see, this is the current project right now, the one in yellow, right? You want to change this, you simply run this command, set project, and get the project ID. That's it. Yeah. Are we good, guys? So this is a Cloud Shell, and honestly, and I think this is somebody who really, this kind of shows like the level of thought process that went into this. They really thought about, hey, how can you give people quick access to Google Cloud, command line access? Because AWS, this is kind of a pain point. I'm not sure about Azure. Like you got to install their client, and then you got to configure the public and private keys, and it's a bit of a work, right? But here, you just click a button, and bam, you're right there. That's pretty neat, right? So. Okay, so is anybody can you just give me like a little green check if you're able to access the shell? It's called Cloud Shell. Okay, any questions, please? Right, again, these are some of the little handy things in Google Cloud I want you guys to be familiar with. If you're still waiting to be loaded, let's do this. Just do a project refresh, right? Oh, and then I'll also kind of close the editor and then reopen this, because sometimes you kind of get stuck in because remember what they try to do is like they spin up an edge node and then try to pin you access to that. Sometimes things go wrong, right? So I will just do a refresh of the project and also close the terminal and reopen the terminal. And usually that kind of brings it back up. Okay.
Did you want us to run that config command that you ran?
Not right now. Yeah. So this is we will do so later. But for now, I just want to make sure you guys have access to it. And this is a regular Linux terminal too. You can just pretty much run any Linux command here to do this, right? Yeah. For now, that's it. I just want to make sure you guys have access to this. And it should be tied to your project anyway, right? So your project name should see the one in the yellow. So this is tied to my project, right? And I don't know if you guys noticed this, like if you highlight something, they automatically copy this into the clipboard, right? So you can sort of paste it, you know what I mean? Pretty neat, right? So, little things. So one thing I will tell you is like when working with clouds, it's the little things people spend a lot of time, end up wasting a lot of time on. So, so this is one of my favorite features in Google Cloud. Simple, but very effective. Excellent. All right, guys, we are going to move on. If looks like everybody's good here. Excellent. Okay. So that's that. So we have access, we have project, and we know how to get into the shell. And we will use the shell as we go along later, right? But most of the stuff we can do using the UI. The shell is for like scripting and things like that. So I'll show you guys both, right? I'll show you guys the UI option, and also having a shell option is nice because sometimes you just want to script things, and it'll save you a few clicks. Okay. All right, guys. So that's slide. That is good. Let me go here. We're going to look at Google Compute. So this is slide deck 6, I believe. Yeah, slide deck 6 for you guys. Okay. All right, guys. So let's start with the basic Google basic construct of Google Cloud, which is the compute engine, right? Because this kind of powers everything else. So, and this is called Google Compute Engine. What is the Google Compute? Is basically on-demand virtual machines. That's it, right? So you're spinning up machines for you to do your work on. And you can spin up, machines like, things like, more memory, more CPU, right? And I'll show you some of the configurations later. And also, they even have GPU access. For example, let's say you're going to run some machine learning workload, AI workload, and you need GPU, right? You can spin up machines with GPU. They will cost you a little bit, but yeah, you can run them. Right now, Linux and Windows are the OS supported, and this is pretty cool. Like they bill per second. AWS, I believe they do either per hour, I believe, or per minute, I think, right? But these guys do per second billing, right? So, And again, they are very friendly on the whole Docker Kubernetes ecosystem, right? So the whole compute engine is basically runs on Docker Kubernetes, basically. So let me talk a little bit about some of these options. So one thing we have to we have to understand from the get-go is there are different ways of using Google Cloud. So one of the what this kind of this shows is like you basically meaning who's managing the machines. So you are managing, and on the other spectrum, Google is managing. So let me show you guys this, and this kind of sometimes confuses people. I want to make sure we understand this. So if you want to manage everything, just simply spin up a bunch of machines on the using the Google Compute Engine, and then manage them, right? So let's say I want to install a database. So I spin up a machine, install MySQL or whatever, then I'm managing it. So all you're doing at this point is you're renting a virtual machine by per hour or per minute basis, and you're responsible for doing everything like backups and everything else. And this is fine. And then if you sort of move down this line, right, on the all the way to the other spectrum, especially Google will manage this for you. So let's say you want a database, right? We don't want to spin up a machine and install our own database. We actually ask the Google, say, I need a database, and Google has a SQL database, like hosted version, and they will give you access. And this is running on some machine somewhere, right? But Google will manage it for us. They will do the backups, and if a machine goes down, they will spin up a new machine, the whole thing. So first thing we have to decide is like which level of access do we want? Do we want to kind of manage our own infrastructure, or do we just want to use a managed service from Google? And there are use cases for both options. Like for example, sometimes you actually have like some custom software, right? Maybe you could have a custom app you guys written, or maybe using some very specific code that Google is not hosting, right? So then what you would do is you will spin up a machine and manage it for yourself. If it's like a standard stuff, like let's say you want a queue, you want a SQL database, right? Then you simply go to Google. These things cost a little bit more because, as you can imagine, right? They take care of all the management as well. It's hardware plus service, right? So the services cost a little bit more per hour compared to these guys. But a lot of the time I prefer this too, because this way you're kind of letting Google manage it for you, right? And right? I mean, this is what these guys do 24/7, right? I mean, they know how to manage data centers. So, right. So again, like I said, there's no one right or wrong approach depending on your need. If you're using standard stuff, just use the service. But if you're using some very customized version, then you want to spin up your VM and run it. So they're gonna make sense, guys, right? So yeah, so some of the example would be like, for example, one of the projects we did was we had a service. They had a custom C++ application that processed audio files, like like a voice, like when you talk to, right, when you go to like when you do the phone tree, you say, they will say, okay, what are you calling about? Say 1, 2, or 3 kind of thing, right? That kind of audio file. So they had a custom C++ code that was processing the audio files. So okay, of course, Google doesn't have something like this. So we actually, at least back when we used it, so we actually wrote a bunch of machines and we ran our codes to decode audio file, right? Things like that. Yeah. So here are the machine types you can access, right? So again, like remember, Google Cloud has different machines. So for example, you would typically, they give them like, N1, N2, these are sort of the normal machines. So, again, if you look at this, typical, web applications, right? If you deploy databases, things like this, N1, N2 class machines can do pretty well. And all these machines you can actually have like different memory types. Let me see if I have a slide on this one. There we go, right? So like an N1 machine, right? You can choose an N1 machine that has either 1 to 96 CPU cores, right? And the reason they are called vCPUs, these are virtualized CPUs, because you don't have access to the actual physical CPUs, so they're virtualized just like everybody else. But still, right? You can have tons of cores if you really want. Let's say you want like something with 64 cores, sure, you can have access to it. And memory size, starts from 1 gig to like I think right, 6 gig. So I think there should be 64 gig, right? And then they are memory optimized machines, right? So you can get more memory intense applications. So let's say, I don't have a lot of CPUs, but I want more memory. Then I would choose the memory optimized. These are called M1, M2. People ask me, why are these version, like these are like version numbers, right? M1, M2. So what they will do is, let's say, they're building the data center, like, say 3 years ago, and they had some machines. And when they buy new machines, of course, the new machines are going to have, better hardware, right? So these numbers usually indicate versions, M1, M2, M3, right? Same thing in Amazon. Like in Amazon, I say, they have the same class of machines, but the newer machines have a latest version, so latest version number. So you should know they're slightly faster and cheaper, right? Just like with every hardware, right? So we have N1 and 2 machines, M-class machines, and the C-class machines are these are compute optimized, meaning I want lots and lots of CPUs. So remember the audio processing application I talked about now? We went for C-class, right? Because it's very highly intensive on CPU, right? So yeah, so things like gaming, things like doing some signal processing, stuff like that, C-class machine. So anyway, and also there's the E-class machine. It's kind of like a low end basically, and also lower cost. So you're like, hey, I just need a machine, the cheapest machine possible, right? I don't really, I don't have any specific requirements. Just in a E-class is fine. And this is sample application you guys can think of, right? Makes sense, guys? Any question on this one, right? So basically, we are spinning up machines, virtual machines, and they have different types for different use cases. Yeah. Okay. So we talked about this right now, some of the machine types and some of the sample configuration. Again, these are just samples, right? So look at the doc to get the full list. Okay. So you're spinning a virtual machine. You need to figure out, where to store the data. So they give you 2 kinds of disks, right? Because each computer needs, these disks to kind of boot up. So there are 2 kinds of disks. One is called persistent, other one is local. Okay. So you want to use persistent disk if you want your data to survive even beyond the virtual machine, right? So for example, let's say you spin up a machine. I took a database backup, and I want the backup to survive even after the shutdown of the machine, right? So we use persistent disks. So things like, if you're storing databases, backups, this is what you will go for, right? And also, let's say you have a database backup on a disk, multiple people can read this at the same time, because that's what it's designed for. So, and also another cool thing is like the way you're thinking about persistent disk is like this. Let me draw here. So let's say this is my disk. So it was attached to a VM, right? And then let's say this VM is a crasher, so it shut down, right? This VM goes away, another VM comes up, then I simply attach this to the new VM. My data is still safe on the persistent disk, right? So persistent disk will give you this feature. You can reattach to different VMs, so your data is safe, all the thing, right? And also you can do cool stuff like you can snapshot them, right? So let's say let's say use a database, you want to take snapshots, right? So let's say it's the snap 1, right? That's basically a backup, and snap 2. And let's say something bad happened, and you say, okay, yeah, I need to go back and revert to the snapshot 1. You can always revert back to snapshot 1. All this cool stuff is available. Yeah, so these are called persistent disks, right? Persistent disk. Now, local drives, right? They are basically, basically just as soon as your VM goes away, these drives also go away. Your data is not persisted beyond the VM lifecycle. So why would you need this? So for things like, let's say I'm just, I'm doing some local stuff, right? So let's say I'm doing some local caching, or I'm doing some, I'm keeping to sort of upload temporary files, and then I'm pushing into these files to someplace else. So I have storage that, I need. One thing these guys are very good at local disks, they are very high speed. So compared to persistent disks, right? Performance on these guys are very high. They actually in the local machine, right? But at the same time, they go away when you terminate a machine. So if your data is temporary and you don't care about losing data, these guys are good and they're cheap. So 2 disk types. Make sense, guys, right? Persistent drives and local drives. Any question on this one? And different use cases, right? So persistent drives, basically, if you want your data to, live even after the VM is gone, persistent drive, right? They're a little slower because they have a different architecture, but you can back them up, snapshot them, do all the cool, all the usual stuff. If you just want some local drive, local storage, then use local drive. They're cheaper, and like I said, they're much faster as well. Okay. So another type of virtual machine is called preemptible virtual machines. So if you are familiar with Amazon, these are similar to Spot instances in Amazon, right? So the way they work is pretty neat. These are Spot instances on AWS, right? So how do they work? So basically, remember when you rent a VM, the cost is fixed. They will say, okay, this VM is going to cost you 20 cents an hour, right? That's what you pay. However, these preemptive VMs are something like, let's say sometime Google doesn't have enough demand, so they have all these VMs sort of sitting around. And from Google perspective, they are paying for them, right? They're consuming electricity. They are sitting in a data center, so Google is still paying them even when customers are not using it. So what they will do is they will kind of they will actually give you a huge discount if you say, hey, I want this preemptive VMs. But the catch is they can be taken away with 30-second notice. So let's say Google has a bunch of machines sitting around, and they say, hey, you can and I got access to those, and I'm running some stuff on that machines. And now Google sees demand is spiking up, and they want to reclaim these preemptible VMs, and they will take it away from you, right? They will send a signal to the VM, right? And they'll say, okay, hey, in 30 seconds, this VM is going to go down. So you need to have some way of either recovering your workload or resuming your workload with a notice. But like I said, right, the advantage is like if you can live up to this, you get pretty good discount. And a lot of startups, and we did this for not on Google. I did this for on AWS. AWS has same idea. They have something called spot machines. Spot machines are basically on-demand machines. When there's no demand, you can buy them, not buy them, you can rent them pretty cheap. But when the demand spikes, Amazon can take it away from you guys, with a few seconds notice. So what we will do is like we will run server farms, let's say I want to do some a large amount of processing. So rather than spinning up a lot of machines, a lot of regular machines, we spin up preemptive VMs, right? And we know they can go away anytime, and that's fine because if they go away some other time, we'll spin them more, right? Yeah. So the workloads you want to run on them is basically you need to tolerate failures, right? You don't want to run on a workload that doesn't survive the machine being taken away, right? You got to be very, very careful with this, right? So, but if you can sort of structure your program in a way it can run, it can fail, but you can sort of switch to another machine. This is very, very good. Okay. So here's a question for you guys. I want you to think about kind of a little design exercise, right? So my use case, and this is the use case I worked on, but this is on Amazon. But you can map this to Google. So let's say we are processing some videos, right? So let's say YouTube, people are uploading videos, but when they upload videos, we don't actually show them videos right away, right? We actually keep them, process them. So maybe I will create different versions to be viewed in say iPhone, right? Another version for iPad, things like that, right? So and this is very intensive processing, and so I need you guys to build a server farm, like a cluster of machines that can sort of do this in a cost-effective manner. So think about this for a second, right? So how do you design a system like this? So I need a lot of compute power because video processing is very CPU intensive, and I want to save as much money as we want. And these were my requirements when I did this project. So you got to come up with a structure or architecture that'll do this for you. So let's take a minute. I'm going to give you guys a minute to kind of sketch it out, and then we'll talk about this in a minute. Right? So think about how you would do, preemptible VM to design a system that has a lot of compute power needs. All right, guys. So what are you guys thinking? How can we design a system with you know, a little compute power, but also want to save some money? You can feel free to actually, let me see if I can do a little share screen and we can annotate. Yeah. All right, you can actually go ahead and so here's what I'm thinking, right? Can you see my whiteboard? Yeah. So what if I always scenario A, right? I'm always getting preemptible VMs. Is that a good design, guys? If I build the server farm all on preemptible VMs, would that be a good design? Let me ask you guys this. What do you guys think?
As long as you have redundancy.
Right. So the thing here is, right, they can disappear anytime. I mean, they will give you a warning, right, the 30-second warning, but they can be taken away from you anytime. So I could envision a scenario where let's say I have like 100 of these, right? I lose all 100 more or less at the same time. That's possible, right? I mean, if the demand spikes, Google can take this away from you because that's a contract, right? They give you a hefty discount, but they can take it away from you anytime. So if I lose all 100, now my processing has come to a halt. Yeah. So so this is not a good design either. So then the other option is I say, okay, you know what, I need to make sure, I have some, machines up and running and to process the video. So let's say I go and, rent 100 machines, regular VMs. Let's say regular VMs. What do you guys think about this architecture? Right, I just spin up 100 machines.
It's gonna be expensive.
That's right. So I'm guaranteed to have these machines, right? Unless there's a hardware failure or something, right? But these machines will keep up and running. But then I'm paying basically retail like full price, right? So I mean, yeah, this will work. I mean, right? I mean, this will work, but not exactly very efficient. Like you're not going to save a lot of money. You're going to be spending a lot of money on this one. So what does the approach see? And this is where you guys are kind of tell me maybe something in between. What do you guys think?
And this needs to be only with preemptible VMs.
I know you can do a mixture, right? You can do a combo.
Probably two sets: one, the preemptibles, and the non-preemptibles.
Right, that's what I'm thinking. So what you would do is like you sort of divide your cluster. Some machines, like let's say let's say I have 20 machines. These are regular VMs, right? And I have 80 of these preemptible machines. Okay, so let's talk through this. What will happen? So if everything is fine, then I will have 100 machines, crunching through my videos, and I'm paying full price for the regular ones, right? And then kind of very hefty discount for these preemptible ones. But I like machine checking along, right? But let's say Google start taking away some machines. So now I'm sort of instead of running 80, I'm down to say 30, right? Google taking away has 50 machines, but my servers are still running, right? I still have 30 machines, that I'm kind of paying pretty low price that are still running along, right? But let's say the extreme scenario that happens, I lost all the machines. So demand was so high, Google took away all the machines. So I had nothing in the preemptible pool. So, but I still have my regular machines running because these don't go away, right? So I still have some basic capacity, right, to crunch videos. So maybe I can sort of prioritize video. Maybe paid users get their videos processed first, right? And this is very true in YouTube, right? When you upload video for YouTube, you know how they say, hey, we are processing your video, and they will basically prioritize based on paying users will get their videos in the queue first, things like that, right? So I still have a processing farm running, right? So I don't ever go to zero, but if I have the need and there's a discount going on, I can scale this processing very quickly. Is that going to make sense, guys? Right? So these are some of the things you have to think about when you're building, because as always you can go and rent the machines and run this, but you can see, right, if you want to, these costs can add up. So if you want to be a little smart about this, you can do like a hybrid setup. Some is regular VM, some is preemptible, and kind of manage this on your own. But to do all this, right, I mean, to pull this off, your processing has to survive failures, right? So the way your system has to work, let's say you are kind of processing a video on this machine, right? Let's say you're doing some number crunching. Let's say you are like 60% through, but the machine is taken away from you. Okay, so your system should recognize and say, hey, I lost the machine and this video hasn't been done, and maybe you want to assign this video project to maybe another machine, right? Another live machine, and maybe it'll start from where the other one left off, or maybe it'll start from 0%, whatever, right? But your system should be able to handle it. If you can do this, then you can really utilize these things.
Yeah, to enable that, you can split the videos into, let's say, 1-minute chunks, so that.
Exactly, right? So you don't, exactly. So let's say a video, like, and that's kind of what we did. Like we'll basically short the video and process, things, and then we'll merge them together because let's say somebody uploaded a huge video, and in the middle of processing, my VMs keep going away, then you're going to start all over again, right? Yeah. So your framework has to be a little smart about how to resume work, right? Yeah. And if anybody familiar with Spark or Hadoop framework, they will do this, right? So Spark framework is basically built to handle machine failure. So Spark will automatically monitor the cluster, and if any machines go, disappear, Spark knows what they were working on, and those tasks will be assigned to a different machine, maybe like a live machine, like a regular machine, or another premium machine, whatever, right? So good, guys. Is that gonna make sense? Any question on this one? Right. So in Amazon, when they did this project, the cost for the preamble VMs always fluctuates. So it's like kind of like an eBay, right? So let's say regular machine costs like 100 cents an hour. Let's say $1 an hour, right? Sometimes they will, so now what Amazon will say is, okay, now they will say, okay, we have excess capacity, we'll give a heavy discount. How much are you going to pay? So it's kind of like an eBay, right? We all bid. So I'll say, okay, I'll pay 10 cents an hour, right? Another guy might say, okay, I'm paying 15. Another guy might say, I'm paying 30, right? So it's a bit of a bidding going on, and whoever wins the bid, right? They get full, not full, I mean, first access, right? So they get the first pick, and then the second guy, and so on. So we're gonna write experimenting with, like, for example, we had a program that does the bidding. So we also knew from a historical usage, like, how the price fluctuates. Like, for example, like, let's say this is like, we don't know, like at 8 o'clock, the price, 8 a.m. the price is high, and then, we sort of know it's gonna come down, and then maybe spikes back in the afternoon or something. So what we will do is we sort of schedule our compute along this time, because I know I could get pretty cheap machines, during this time. Right? Anyway, so we kind of, again, like I said, we were a startup and we were trying to save every penny, right? So we kind of wrote this scripts that'll kind of bid, and we also knew like when to bid, right? So when the demand is low and things like this. Anyway, so you can get some, build some serious infrastructure around this, but the basic idea is you need to have, if your processing can withstand failures and can resume, you can save some serious money, right? That's the takeaway here. All right, guys. Any other question on this one? Okay, good. So let me stop sharing this. Okay, moving on. Let me stop the share, guys. All right. All right, so we are showing the slide again. All right, so this is a solution, right? So for example, something like this. So kind of like a mixed pool. So here's my permanent pool, right? These guys always run. And then I have like a bunch of preemptible VMs. And even some VMs are taken away, that's fine. My pool gets smaller, but I still keep running. By some extreme case, if all the preemptibles are taken from me, which is possible, we have seen this happen, right? When there's a really high demand. Of course, Amazon wants to get, they want to get paid as much as possible, right? So they will, if somebody's willing to pay more, they will take this away from you. One of the tricks we use is like, it's like eBay, right? It's like, you can bid the highest price you will pay. You say, I'm willing to pay 10 cents, but I can go up to 50 cents. So you start at 10, and as the demand increases, they will kind of keep charging you more and more and more. And then when you exceed 50 cents, then that's when you start losing your VMs. So it's just a thing like eBay, right? You can say, hey, this is what I'm willing to pay, but I can go up to this much. Anyway, all these things. But very flexible architecture to define to run your high intensity computes. So the question is, how do we cost? So in this case, the cost is basically per machine, right? So each machine, right? If you're buying a more powerful machine, it's going to cost you more. So they don't bill you based on utilization. What I mean is, like, let's say you got a machine and it's just sitting idle, you're still going to pay for it because that machine is allocated to you, right? So and this is we see all the time in the cloud. People using cloud is they will rent a bunch of machines, even when they're underutilized. Even each machine, maybe they're using like 30% of the machine of the CPU, but you're still paying full price for the machine, right? Because because the machine is yours. Yeah. So that's why it's important to have kind of many machines with high utilization. Like, for example, I would rather have these machines like 80-90% utilization. So this way, if I need more, I can spin up more, right? And then even if I lose few, that's fine. But if you have virtual VMs, that let's say these VMs are running, but they're running only like 20% capacity, right? You're kind of wasting money, right? Because Google is charging you not for 20%, or they're charging for the whole machine. So yeah, you have to be so mindful, right? So that's why monitoring is very important. So you want to understand, and Google will do this for you when you spin up machines. Google monitor this for you guys, and I will show you guys how to enable monitoring as well. Yeah. All right, guys. So we are going to jump into a lab. I'm going to show you guys how to spin up a machine. Okay. So let's see. Okay. So let's try this real quick. So in your Google Cloud, you can see my screen, right? Go to your Google Cloud, right? And if you click on the left bar right here, these are all the services, right? And as you can see, there are just way too many. So these are the services that they provide in the compute engine, right? So, and some of them, for example, the compute engine is right here. See the compute engine, okay? And the reason you see the pin here is because since I use compute engine all the time, I sort of pin this on the top of my menu. Like, see how it says, right? It shows up here. So you can sort of remove this if you like, right? It sort of shows up, goes away. But since I use it all the time, I pin it. When I do pin, it actually shows up right here on my menu. All right, guys. So click on this menu. We are going to go to compute engine, right? Either way. So under the compute, find compute engine, and simply click on it. Okay. So again, on your Google Cloud menu, scroll down under the compute title. Compute engine is what we are going for, right? So simply just click on this. So this is where all your computation is going to be, and you can sort of see, a few things here now. I'll explain some of these as we go along, right? So, and the first time you do, they are basically connecting you to the compute engine service, right? Because you need to have a machine backing your computations, right? And this takes a while. All right, guys, how's everyone doing here? Are you guys still kind of, the spinning, are you guys getting the spinning thing? They're kind of spinning up to connect to your, yep.
So I have a question.
Sure,
So we
please.
haven't created a VM yet. So why is it creating something now?
Right. So what they're doing, so they're not creating anything. They're actually sort of, they're establishing the service. So the way they do this, right? Because in the Google data center, there are like, I don't know, like hundreds of thousands or millions of machines running, right? So what they're identifying right now is like which machine, if you want to spin up, which machine they can put your computers on. That's it, right? They're kind of, right? Because, you can imagine, right? So yeah, you're right. Even though we haven't spun up anything yet, they're kind of getting it ready. Yep. So they're kind of identifying which machines, which that are potentially you can place your computation on. Because the way you have to think about this is like this, right? So imagine, let's say this is a physical machine in Google, right? You can see my screen, right? The physical machine in Google, it is actually shared by many, many people, right? So a lot of VMs are being run. Some of them are bigger, some of them are smaller. You guys get the idea, right? So what they're going to do is they're sort of assessing the capacity and say, okay, hey, which machines can take on more load, right? Yeah. So that's kind of what's going on. So there we go, right? So now it took a minute, and it'll say, hey, it's ready. So I guess getting this little dialog box, right? VM instances, right? So it took a minute for me, probably the same time for you guys. But this is what's going on, right? They're ready to now place your VMs in these settings.
So Fuji, one question.
Sure.
Let's say we spun up these VMs and we are consuming the resources. Do we have to do explicitly shutdown at the end just to make sure that we don't get billed continuously?
Oh yeah. Actually, that's a great question. So the question was, how do we shut down when we are not using it, right? Kind of paraphrase what you're asking. Yeah. Actually, I'm going to show you guys. All right. So I'm going to wait. I'm just waiting everybody so everyone can have this menu. So let me kind of walk you guys through this, right? Let me see where we are on this one. Let me make sure, right? So what we're going to do, we're going to go to the VM instant page, and I'm going to have you guys spin up a very small instance. Okay. Here's how we do it. So you can sort of watch my screen, and I will give you guys time to do this on your own. And so if you look at the slide number 13, we'll see the screenshot. Okay. So here's the deal. So my VM service is ready. So I'm going to create a VM. So click on the create, right? All right, so here is where you're going to actually, I'm going to kind of minimize this shell guy just so I have some screen space, right? And I can always bring it back up, okay? So, but for now, I just minimized it, okay? All right, so I basically sort of, again, I went back, I said create VM. And here's the dialog box, where you have your choice. So you can give it a name. So you can say, Suji 1, doesn't matter, right? You can give it a name. Oh, actually, yeah, no spaces, right? And then you can add as many labels as you want. Labels are like tags, right? So you can say, okay, this is my video processing, or this is my web server, right? Whatever tag you guys want to add is fine. And then region. So if you're using Amazon, this is your zone, right? Which data center you want to place your VM in. And you can see, right, Americas, they kind of give you central first because, and also, again, this is kind of the calculation they just did, right? When they remember that it was kind of spinning up for a while when you went to the cloud page, because they were trying to assess the capacity of which data centers they can recommend. So the default one, I got central. Maybe you got something different. The reason is they look at the old data center and say which data centers are overloaded, which data centers have spare capacity, they can take more VM, right? So central, is that what you guys get to? Central, your central one, right? Okay, that's central. And then zone. So within central, right? So think of these as the data centers. So this is like a region. And within a region, they will have multiple data centers. So you're saying central 1A, 1B, 1C, right? So this is the availability. So when you choose one, it's permanent. It's almost like, kind of the way you are thinking about this, like imagine a data center. You are assigning a data center to the machine. It's not easy to move from one data center to another machine, right? So that's why it says zone is permanent. Right? So you sort of move your mouse over, right? Zone is basically a location, meaning you're basically maps to a physical data center, right? And once you choose a zone, it's not something you can easily change. Region and zone you cannot change easily, right? So, all right. So you can sort of leave this as default. Whatever they recommend is fine, right? Because because the reason that they are recommending use, like that's where the most capacity is, right? All right. And here is where the machine type. So we talked about different machines, right? So first gen, second gen, right? So as you can see, right? So the first gen, basically, you can sort of see the the CPUs like Skylake. Second gen is whatever Cascade Lake, whatever. Right? This is like from Intel names the CPUs by the lakes and rivers, right? In Pacific Northwest. So yeah, so second gen is basically cheaper, faster kind of a thing, right? So you can choose either one is fine, right? Let's say I want to choose E2, right? Okay, so you cannot go wrong with any of these, and I mean, there are some of them basically, like for example, AMD chips can be a little cheaper. So you have your choices here, right? So I just chose E2. You can just choose N1, doesn't matter.
Which
right?
is the cheapest?
I would say E2. It'll be typed in E2 and N2D. So the only way to kind of find this out is basically because these prices fluctuate daily, right? So basically, I'll go to Google Cloud. So how do you say? Actually, you can sort of see from here. One second. See, when you select this, right? This is N1. See the monthly estimate they're saying. They're saying if you run this, right, it will cost you this much per month, right? So, but what is it, like 3 cents an hour? Yeah, 3 cents an hour, right? So I choose, let's say E2. This should change. See, it's about 6 cents an hour. And N2 should be a little higher, right? There we go, right? So N1 is probably cheaper, I think, right? What is N2? I'm kind of curious too. There we go. N2 is a little cheaper. So N1 is going to be the cheapest one. So I'll just choose that, right? It's basically they're saying, okay, you're paying, whatever, 3 cents an hour kind of thing. And if you keep running for a month, right, you'll get, right, you get this much. So they're pretty good about this. And this is, again, if you're using Amazon, if you used Amazon, this is something you will appreciate because in Amazon, this pricing is kind of very hard to guess because they have instances in, like they don't have like a combined page. They kind of tell you, okay, hey, this is how much it's going to cost you. You're going to have to sort of go to different pages and figure out, okay, I'm choosing this instance, how much it's going to cost me. But here it's kind of, this is nice too. Again, small things, right? I always appreciate these small things. All right, guys. So let's choose N1. That's the cheapest, right? Again, this is just a trial. We're not going to do any, any big operation. So N1 is fine. And here you choose, okay, what do you want, right? So N1 standard one. And if you look at this, they have different specs. See, this is like the base version, one CPU with 3.7 gig memory, and that's fine for us. But if you want 2 CPU, right, 4 CPU, you can get that. As you sort of keep going down, okay, I'm kind of curious. Like I say, this is 96 CPU, 360 gig memory. I'm going to select this and see how much it's going to cost me. Just curious, right? So they're saying, okay, right, it's going to cost you, about $3 an hour if you run it for a month, right? It'll cost you like 2,000, 2,300. So definitely do not do this, right? I was just curious. Choose the smallest one you can find. But you can sort of see, see how they splitting this. They have like a standard ones, right? And then the high memory ones. You can see the memories are pretty high on these guys, right? And high CPU if you want more CPU than memory, right? And there's like mega memory. Like anyway, so they are like all these different configuration you can choose from.
So in the beginning, there were some shared ones. They may be cheaper.
Yep. So micros, this is the smallest one you can get, right? So these are like very, very, you can see like, right? Look at the memory size, right? F1 micro, 1 CPU and, like under 1 gig of memory, exactly. Yep. Mm-hmm. So yeah, you can choose from this.
Okay. Can we use this for our exercise?
Absolutely. Yeah. Yep. That's fine. Yeah. Let's kind of, yeah. Especially, if you have your own credits, let's not waste the credit. Yeah. Let's choose this guy. Yep. But you just get the idea, right? You can, based on your need, you can choose any of these guys you prefer, right? So, and remember, we're all on like N1 now, right? Because remember, why N1? I'm on the N1 series, right? If you choose N2 series, then you get, you get different, different choices too, right? Kind of like that. Because remember, the way they track the versions is like, N1 is like the, first generation, N2 is second generation, so on and so forth. So we just choose the cheapest one, N1, micro is fine, right? And you see the pricing, right? So, right, I mean, yeah, this kind of costs like, just $5 a month. Not bad at all, right?
A question, is it
Sure.
possible to change the machine type after creating it?
Good question. Usually not.
Okay.
Because, yeah. So there are some exceptions to this, but usually once you choose a machine, it's very hard to kind of change the spec because when they do this, they kind of pin your machine to a VM, right? So it's very hard to change. Yeah. So that's why you need to be a little careful when choosing the machine. You want to kind of you don't want to overdo it, but at the same time you don't want to underdo it either. Yeah.
But
Good question.
Excuse me, Amazon, they allow you to change. Amazon allows you to change.
You cannot change the number of CPUs and number of memory. I don't believe so, right? So that's the question was like, can you for example, I chose like this much memory. Can you add extra CPU?
And
No, that's a migration, right?
Amazon, you can change.
Oh, okay.
Yeah, but it only needs a start and stop. When you stop the machine, it frees it. You have to do a start and stop.
Oh yeah, okay. So what you're doing is you're gonna stopping the machine and starting as a different instance with different machines. So you cannot change this on a running machine. Yeah.
Not when it's running. You have
exactly.
to stop it.
Yeah, exactly. You stop it and restart it as a different instance. Exactly. Yeah, I got that. Yeah. Good guys. Okay, let's zip through this one. Okay, so we chose the machine. All right, then boot disk is what kind of machine do you need, right? That's kind of so we had in this page right now. So click on the change button, and here you will get a different OS choices, right? So let's say here you see the CentOS, mostly as you can see it's very Linux, right? Heavily Linux based. So let's say I like Ubuntu, right? So I choose Ubuntu, and then Ubuntu, you can sort of choose which version you guys want. So let's say I want like the so in Ubuntu, if you look at this, LTS stands for long-term support, I believe, meaning they will maintain these machines for up to 10 years, I believe, or 10 years or 5 years, something like that, right? Because in a server-grade machines in Linux, right, people discover vulnerabilities and they need to patch those, or they need to release patches, right? So typically, if you're running a server-class machine, we recommend running an LTS machine. So if you look at the version, they're a little behind. The latest Ubuntu is like 1910, right? So, but the LTS machines are at least one revision behind because remember they're kind of trying to be a little more conservative. They don't just update them with the new software because what if there's a vulnerability, right? There's some exploit that people can hack into. So I would recommend LTS. I mean, this is 1604. I mean, this is like 4 years old, right? I mean, that as you can see, that is still supported because some people want absolutely proven Ubuntu, like hardened Ubuntu. But 1804 is pretty good. So I choose 1804. That's the latest, right? And then you can say, okay, how much disk do you want, right? So here we go, right? See, so here you can choose standard disk or SSDs. So SSDs, will give you much higher throughput, right? But of course, you're paying more, right? So in our case, standard disk is fine, and you can choose how much disk you want to choose, what size you want, right? So anyway, like all of these, like the question marks, it'll give you more, more help. Okay. All right, guys, is this good? Right, we are choosing a standard Ubuntu machine. Also, if we sort of solve right here, right? Let's say you have your own custom image, like for example, let me see if I have anything, right? So I don't believe I have any custom images. Let's say you have some custom image with your own code. You can choose that too, right?
So how did you get to this screen from the last screen? I missed it accidentally.
Sure. So you want to actually come to the boot disk, right? See this section, and click on the change, right? Yeah.
I got it.
Yeah. And that's where you choose your basically you're choosing your operating system. So I chose Ubuntu and Ubuntu 18.
And
right.
This is I have a question.
Yeah.
Right now I'm using the Windows system. So what we have to select the version.
Oh, you mean here the Windows API? Honestly, I haven't tried much Windows here, but yeah. So I think it's like this is completely alien to me. Can somebody shed some light here? Windows Server. Again, I don't follow Windows all that much. Yeah, so
Okay.
if you're familiar with Windows, these are like, I can see there are different editions, right?
Mhm.
I think Windows is going to cost money.
Oh, okay.
Oh yeah, you need to put licensing too, right? That's true. Yeah. On top of the hardware, you had to also pay license for Windows, right? Yeah,
So
that's true.
here the selecting the operating system is not based on the what system we are using here, right?
Sorry, I don't understand. I'm sorry.
No.
No.
Here the boot disk,
Uh-huh.
selecting the operating system is not depends on the system what we are using right now.
Oh, you mean the capacity? Like, oh no, yeah, no, you're not. Okay, yeah. So yeah, you're right. Oh, yeah, sorry. Yes. Okay, I see what you're saying. So, question. I mean, this you can choose anything you guys want, guys, right? Because remember, this is running on Google Cloud, so it's not
Okay.
tied to your laptop or anything. Like, so your laptop could be running, say, Windows, right? That's perfect, right?
Okay,
But
got it.
you can choose anything you guys want.
Mhm.
Absolutely. Yep.
Right.
So yeah. Oh yeah, I should make that clear. Yeah, that's right. Good question. So it's completely choice is completely yours. Also, again, just something while I'm here, I might as well point these out to you guys. So let's say you got some snapshot, right? So you can sort of you can receive from a snapshot as well. Like because right now I don't have any, right? You can snapshot, and also remember, you can bind existing disks, right? So you can right. We talked about persistent disks. You can actually detach and attach. All these things you can do. But right now we're going to stick with public images. We're going to choose Ubuntu, standard Ubuntu. That's it. All right, guys. Any other question on this one? Right? Choosing an operating system, right? Yeah, we'll talk about some planning stages as well. Like so I first want you guys to show you guys what's available. Then we'll talk about some of the best practices. Yeah. So let's go ahead and select this again. You're free to select anything. I just say because I'm an Ubuntu user, so I'm pretty comfortable here. So I just choose Ubuntu. Right. That's it. Right. That's all. I select that. That's my Ubuntu. And basically, you can sort of say, right, here's your, what do you want the firewall to be, right? So here, you can say, okay, maybe you can say, if you want to run some web service, you can say, allow HTTP. But you can do much more here, right? If you want. So just for allow HTTP for now, just allow HTTP for now, right? And we'll play with this a little later, right? You can configure, in very detail. Like we're not going to go too much into this one, but you can sort of say, hey, what kind of things you wanna allow, right? SSH keys. Can we again all these things I will show you guys in a little later, right? What kind of networking you want to do, all this, right? But for now, let's accept all the default one. Only thing I want to change here is simply allow HTTP traffic, right? That's it. All right, and then we are ready to create. Is everybody here with me at this point? So basically what we have done, one more time, give it a name, right? Doesn't matter. You can leave this alone. Just choose an instance. So I chose N1, right? Because it's an older one. And I just chose the cheapest one, right? Basically. So F1 micro, right? Either one is fine. Okay. And then we changed the operating system here. I'm choosing Ubuntu. And then I allowed HTTP traffic. Okay. And simply say create. That's it. All right, guys, go ahead and hit create. And this will take a few seconds to spin up, and you sort of see here, right? This is gonna spinning up. All right, while it's doing it, any questions so far? We can go through them very quickly.
So this is not a spot instance or anything, right? We are creating a permanent instance.
We are creating a regular instance, exactly. Yep.
And where would we select whether spot or regular?
Here, so in the compute engine, see the left-hand menu. You want to do preemptable VMs. What's this? One second. It used to be showing up here. Oh, 1 second. Let me see here. Create instance. Oh, there you go. Right. So here is 1 second. They kind of change this menu around on me. Preemptable. So we actually have a template that we used to use. Okay, let me find where the preemptable ones are, because it used to be in the menu right here, but it's kind of, now I either changed it or something else, right? Let me find out, yeah. Sorry, what was the other question? Let me see the chat window.
What's the marketplace?
Oh, marketplace, like people have actually created machines. Like for example, let's say you want a machine for doing data science, right? Or let's say you want a machine for say running some TIBCO. So TIBCO probably what you've done, they actually have a machine image already done with all the software installed. So you can just just spin them up, right?
Got it. Okay.
Right. So because otherwise, what you have to do is like you have to you have to start from scratch and you have to install everything on your own. You can do that, or you can sort of do this predefined images. Like for example, right. So if you go to images, right. So this is some of the images, like for example, right. So take a look at this one. So this is like a GPU image, right? You're using right there's like a CentOS image. I don't know if like there's something like you can sort of search by TIBCO or something. I remember seeing something like this, right? Maybe like Jupyter. Okay, so now they're not showing them the project, but yeah, right. So these are people actually who are it's like a marketplace. People who actually develop machines, and of course they are going to charge you a little bit more because the way these work is. So let's say I have a machine instance type defined. So let's say a typical machine will cost you, let's say, 10 cents an hour. My machine image, I may charge 12 cents an hour, right? The extra 2 cents goes to the actual developers, like think like an app store, right? Yeah.
Okay.
So, but the way is like they kind of already customize things for you, so you're not spending a lot of time setting up and installing package and all that. It's all set up. So you're kind of paying for this little service. You're running an instance, you're paying a little higher price, and the developers get that the delta. Yep. Yep. All right, guys. So we actually have an instance ready, so it should be ready by now, right? So so you have an instance. So I'm guessing you guys should have this too. So right here, right? The IP address, everything, right? All good. So let's go and access the machine. Let me show you guys. Make sure. Okay, Ubuntu, that's good. Okay. So we're going to actually access the machine, and then we'll break for lunch after this. And this is another cool thing again. I mean, I know some of you are familiar with the AWS, so kind of a little compare and contrast, right? Here's a little thing. You see that like a little drop-down menu? Click on the down arrow, drop down, and you sort of see here how to log into the machine. So they give you a lot of choices. So to log into the machine, you can either use the browser window, right? Or you can actually use the custom SSH client, the whole thing, right? But the simplest thing you can do is simply open a connection window in the browser. And that's the default action when you click on, if you simply click on the SSH, that's a default action, but it's kind of, a drop down. Because would you guys click on the first window for me, right? First menu item, yeah. So you can see like a little pop-up window comes up and it's going to try to connect.
Oh, sweet.
Pretty neat, right?
Yeah.
So anybody who suffered through, setting up private key, public key, all the stuff on Amazon or any other cloud, yeah, you will appreciate how easy this is. And there you go, right? You can sort of see my Windows logged in. I can, right? So let me kind of make this a little larger, right? You can see, right? That's it. One click and I'm connected. No messing with public keys, private keys, firewalls, and any of that. And this is a Linux machine. You can just type, any command. Right now there's nothing going on, right? Because it's an empty machine, right? So
Suji, earlier we connected through a terminal, right?
Right.
And how is that
Yes.
different from this one? Yeah.
Very good question, right? So I'm glad you asked this question, right? So this, actually, let me draw here, guys. So this terminal is sort of like an edge node. It's shared node with everybody, right? As in like, I mean, you still have your own terminal, but it's kind of shared. This connection is to your own instance. So this window I have right here is for your own instance. So the edge terminal, what we use, so the edge terminal, I don't recommend doing a lot of processing because it doesn't have a lot of horsepower. It's just like a jump host, right? So we log into the edge host to sort of basically access other Google services, but it's not really very powerful. Remember, it's free, right? I mean, because when you spin this up, it just spins up automatically. But this one we just did, we actually connect to our own instance. Is that going to make sense?
Yeah.
Two different machines.
Yeah. So how is this rectangular box at the bottom different from the circle that you have drawn there?
Oh, this rectangular box. So this is actually a physical machine, right? So this is actually a physical machine. physical server that probably is hosting hundreds of virtual machines.
I see.
So, and the reason I drew these orange circles are the virtual machines I drew. The reason I draw them in different shapes is like, some of them are smaller, some of them are bigger, right? Exactly.
No, so why is the rectangular box outside the circle that contains?
Oh, no, sorry, it should be. I'm sorry. Yeah, it should be. Yeah, it should be inside the circle. Kind of, so kind of, envision my Google Cloud is kind of, like all this. Yep.
Right.
Yep.
And so ideally, it is connecting to any of the compute engines that edge server connects to. So you're having direct connection to the compute.
Exactly. So exactly. So the way you're thinking about edge servers, it's like, you are kind of, because here's the thing, right? Because imagine between you and Google, there's a firewall, right? It could be your firewall or Google firewall, right? So some commands, for example, some resources you cannot access from your laptop. Like this is my laptop, right? So this is my laptop. So let's say I spin up a database in Google Cloud. I cannot log into database because either my firewall or Google firewall is preventing it. So what you have to do first is you have to first go to the edge server, and then after that you can access your database. Is that gonna make sense? That's what the edge servers are used for. So to connect to a database, I don't need to spin up a VM, right? Because remember, these VMs are actually costing me money, right? So I don't need to just spin up a jump host just so I can access Google Cloud. This access is already free. Is that gonna make sense? Yeah. So that's what you're thinking about, because edge host is not designed for any intense computation. It's just an access point. That's it.
In the case where you say you have the database in the red circle, right?
Yep.
Wouldn't that be on the virtual machine we just spun up?
Not necessarily. So you could spin up, you can spin up a database, as a separate machine as well, right? So you could, I could have done either like this too. Actually, yeah. Sorry, let me do this. So, okay, not to confuse too much, right? So this is the one I just spun up right now, right? And let's say I also spun up a separate database. So this could be my web service. This could be my database, right? Two separate machines, exactly. But you're right. I could have spun up this one and then install database. Because this machine is yours, right? You can do whatever we want here. Yep. But typically, what we do is we set up database on a different class machines because database need more memory, right? Things like that. So that's why we don't mix databases and application servers together, because databases have their own. It's best practice to have their own instance.
Sure.
So when you say own instance, it is a physical machine versus a virtual machine, right?
So at this point, you're always dealing in virtual machines, right? So because remember, so let's say the database machine, kind of just to kind of give you guys a sense, right? Let's say Google has another server, right? Let me just draw here. So hopefully you guys don't mind all the scrolls, hopefully, right? Let's say if Google has another server, but this machine they're reserving for databases. So this way they will only maybe put like maybe three database virtual machines, because they want to maintain the performance, right? So this machine is not over allocated. But on the other hand, if people are just spinning up just instances, this orange thing, right? They could just spin up, they could allocate as many VMs as they want here. So Google will control that.
Underneath, they are all virtual machines, except basically, that they are different configuration.
Yeah. At this point, with any cloud service, you are dealing with virtual machines. So the reason they do that is because because they need to have that to administer, right? You can imagine that they are maintaining like millions of machines. If it's just physical machine, they need to have somebody physically there to reboot and do all that. That's just not tenable, right? So these days, pretty much every machine is virtualized. But you can choose the capacity, like how much CPU, how much memory you want, and they will match that. Yeah.
So I have a question. How can you activate super user?
Oh, actually, yeah, that's a good question, right? So on your own machine, you are a super user, right? So let me try this here. I think this should work. So by the way, I guess all kind of connect to your machines by SSH, right? Like basically what I did was I simply clicked on the button, right, for the first choice. So it kind of opens a separate window and then connects to your machine, right? So right now I'm logged in as username Suji, right? So let's see if this works. Sudo ls. There you go, right? So in Linux, if you prefix the command with sudo, right, as in, act as super user, it'll basically run the command as super user. And you can see it just ran it, right? So I just did like sudo, right, ls, right? And that's my super user. So so I'm already an admin. So the standard Linux practice is basically just to kind of, there's like a little Linux background. The super user is called root, right? But typically they don't log you in as root user because of security reasons. So what they do is they log you in as a regular user. So in this case, my username is Suji, right? Because they just use your own username. And I'm sure you guys all have your different username, right? If you look at your terminal, right, it'll have your name as username. But you have access to admin function. So any admin command you want to do, you simply say sudo and the command, whatever the command is. And this command will run as an admin. That's it.
So you can do anything like apt-get, install Anaconda or paper, anything.
Exactly, right? Actually, let's do that right now, right? So let's say, sudo apt-get update, right? There you go, right?
I have a question about the kind of storage.
Sure.
So we spun up the VM, and the only options we had were to have SSD or standard persistent storage.
Yep.
So by definition, if we close the VM, the storage will still be available?
Good question. Okay, yeah. So that's a very good question. Let me show you guys. Let me do another one just to kind of illustrate the point. Say create VM, right? The storage here, right? So I think it's under here. These are both local drives, right?
Okay.
So right. So actually, sorry, persistent drive. I'm sorry, right? Remember, we talked about what kind of a machine we have, right? No, this one, the other one. Persistent drive was local drive. Yes, you're right. So yeah, right. Remember, there are two kinds of disks. Persistent was a local, right? The one we are spinning up here, it says persistent drive, right? Right, they're both persistent. So you're right. So what you can do is, even if the machine is down, you can actually save the disk. Exactly, right? And let me see if I can show you guys here. In the compute instance, if you guys go to like disks, right? See this machine, like my machine Suji one actually has a standard persistent disk, right? And take a look at this one. So you can do like things like snapshot, do the whole thing. See? Yeah. Mm-hmm.
Okay, so if I want to change the VM, I can still attach this disk
Yes.
to a new VM.
Exactly.
So then how
right?
do I create a local disk if I just want to work on a local disk?
So,
because it didn't give us an option.
So that actually determined by the type of machine you are creating. So when you create a VM instance, yeah, that's a good question. Let me just show you right here, right? In some of the instances, if you look at the instance types, they will tell you, I'm only doing local drives. Right. So again, maybe not listed here. It should be in the documentation. So they will say something like, okay, this instance has, this much local drive, right? So see how it's displaying vCPU and memory. It'll also actually show you how much local drive it has. That kind of makes sense, guys, right? Yeah. So it's based on the machine type you guys choose. So like maybe N2 might have it. So sometime when you select these machines, they will list how much local drive the machine comes with. But what I'm seeing right now is all persistent drive, right?
Maybe it has to be like a C2 machine or something.
Yeah, exactly. Yeah. So depending on the machine type, and if you look at the Google Doc, Google, the machine listing. If you want local drive, they will tell you which machines have local access. Yep. Mm-hmm. So yeah. So like see how say right now you're doing general optimize, you can do memory optimize, compute optimize, all that stuff. Yep. Mm-hmm. Yeah.
Okay. One more question about the storage.
Oh, yeah. Sure.
So
Yeah.
We have spun up a persistent disk, and we can store files. Say for example, if you have large Parquet files or something for training a machine learning model, you can keep it there. So what is the difference between doing that on a disk and a Google storage bucket? I don't know if I'm getting ahead of the course.
No, that's a great question. Yeah. So the disks are readily available for compute instances. Buckets are not. And because buckets are a separate storage class, we'll talk about this afternoon, right? When you talk about storage.
Okay.
Yeah, I'll talk about this. Okay. So one more thing I want to quickly point out, guys, right? So we are running a machine here, right? So let's say here, I have admin access. So let's say here, sudo apt-get install Anaconda or something. You know what I mean? I install some packages, whatever, right? X and Y and Z, right? So I'm customizing the machine. then what you can do is you can actually, right, snapshot the image. So they will actually command the machine images. Right now I don't have any, right? So what you can do is you can run on the instances and you can say, hey, you know what, you install a bunch of software, you can say save this machine, right? So one of the things you can do, actually, you got to go in here and take a snapshot, right? Create a machine image, right? So then it actually is going to capture whatever you've done into an image. And then from next time onward, you can just spin up the image, right? When you say machine image, you can, it'll show up here. You can just spin up an image. So this is very handy. Imagine, in your company, let's say, you're doing some very custom, you're installing some custom software, configuring them and all this. You don't want to start from a blank Ubuntu and do the whole thing over again, right? What you want to do is like you want to set up an image. So start from Ubuntu, set up all your software. Basically, you're taking a snapshot, right? You're taking a machine image, you're taking a machine image and say, okay, from this point on, everybody uses our customized image.
So I see there's machine image and snapshot, as if those two are different.
Oh, snapshots, these are for disks, right? Yeah. So,
okay.
Right. So right now the disks are showing up here. So remember, we are using persistent disk. So if you take a snapshot right now, right? Let's say this is a database disk, right? You take a snapshot, it'll show up on the snapshots. Yep.
Okay.
Yeah. Yeah. And TPUs, these are again, these are like Google specific, special chips for AI workload. So again, these are kind of expensive too. So that's why they're not enabled by default. But if you're using like some high-end machine learning, you can actually get machines with TPU support installed. Right. So click on the link to read a little bit about the TPUs. All right, guys. I know we are running slightly over lunchtime, so I want to kind of stop here. Let me see what else we need to do. Let's see working project. Let me quickly run through this real quick.
Excuse me, I have a question.
Sure. Yep.
In Amazon, you can stop the machine without killing it. That way, it stops charging. So
right. Yes. Oh, okay. Yeah. So okay, that's something I want to show you guys real quick. When you're spinning up a machine, there's an option they give you to say shut down a machine if there's no activity. So there was somewhere here. Okay, maybe it's only on the command line option. So one of the things they could do, they will tell you, let's see. Let me look at it because I done this using command line. So maybe they only expose this in the command line feature. So what you can do is they will say if the machine is underutilized for less than 5% for say 30 minutes, you can ask it to shut down the instance, right? So again, I'm not seeing it right here in the UI. Maybe it's in the command line option. But yeah, there's an option. You can say, hey, if there's nothing going on, just shut down the machine. Basically, you can put it on pause. Yep, that's it. So because some of the options, because they start adding all this in the UI, right? It'll kind of start getting pretty confusing. So some of the options are only available as a command line client. I'll show you guys in the afternoon. By the way, right? So once your VM is running, go to the Google Cloud home. So see here, they should see like a nice graph kind of showing how much you're utilizing, right? So. And then also, they're kind of, billing charges, right now, I mean, we've been running only for like a few minutes, so there's nothing going on. But yeah, right, this is kind of a running total of, they will say, hey, you've been using these resources, this is what you need to expect. Right? You sort of see that here, right? So, see the computer engine now, kind of they're tracking how much we are using. And you can see, right, I mean, we are like very hardly using anything at all. Yeah. All right, guys, so the lab we're going to do, again, so, yes, we did the lab already. So let's see, spin up a virtual machine, right? So spin up a virtual machine. Okay, so we went through all this. Okay, access and shell, as you can see, it's very easy. So what I'm going to do very simply is, right? So just very simply, let's install Apache. Now I'm going to show you guys how easy it is, right? So in your machine, go to Compute Engine, right? Put your IP address, right? You can click on the IP address, or you can see. If you look, this icon, you can sort of the one with the arrow is like it'll open a new tab, right? Or you can just copy the IP address, right? there's nothing going on, right? So what we are going to do is like I'm asking you to actually, spin up Apache, set up Apache web server. So that's the step 4. Very simple. You can just simply copy this command, right? This is the command to set up Apache. Do it in your, in your window. That's it, right? Let it go. So it's actually doing a, it's doing a Ubuntu update and installing Apache web browser. Sorry, web server. So right now what I'm doing is I'm basically customizing the machine I just spun up. So here, I'm just installing Apache just so we can quickly test it, right? And remember, this is a smaller machine, so it's kind of, these things will take a while. So you guys can sort of follow along with me. We had step, so you guys already have SSH enabled, SSH window. So just do step 4 real quick. Yep. Okay, so I'm installing Apache, so let's see. And this is the command, right? All right, still waiting. Because these things install like a lot of libraries, so they kind of install and set up all the libraries. So yeah, that's why it takes a while. First time you install them. There you go, right? So there we go, it's done. So Apache should be running. So if I simply go back to the same, my IP address, again, how did I get the IP address from here, right? Just copy the IP address using the right. And if I simply reload, I should hopefully see, there you go. Right, and they will tell you in a second, they say, replace this file with anything you want. So, and that's the next instruction I'm showing you guys. I'm sort of saying, hey, here's the, here's the, instruction to replace the file, right? So if you just, run this command, I'm just, putting like a hello world. Okay, reload Apache, you should just see, instead of this page, you should just see hello world. It's anyway, just so something simple, just to kind of showing us, yeah, you can customize, whatever we can install, whatever we want in this machine, right? So, all right, final thing, all right, is remember, and this is a mistake a lot of people do, is you spin it up, you're gonna play around, and then you sort of leave it running, right? And then remember, these machines, they are not free, right? They'll kind of keep accumulating, right? So I always recommend if you're done with your machine, what you can do is you can actually stop the machine. And you're seeing a few choices: stop, reset, and delete. I know we haven't talked about this, but can you guys kind of guess what they do? What's the difference between stop and delete? Can you guys maybe tell me what you guys think is stop and delete?
Maybe
Stop is like
reset.
powering it off.
Yeah, stop is like, just like in your laptop. Let's say, imagine your laptop, you're kind of closing your laptop, right? So all your files are saved, but the machine is kind of not consuming, consuming your credits, right? Delete is basically, meaning like, yeah, you're like just basically throwing away the machine, right? Yeah, so stop is a pretty good one to do because it basically keeps all your files intact. But remember, you're still paying for some storage, right? Remember, even though they shut down your machine, right? They're gonna put it on sleep, but they're still charging you a tiny fraction to keeping the data alive. See what I'm saying, right? So yeah, but it's a tiny fraction. It's not that much at all. So usually what we do is like, let's say I spin up a machine, I'm doing some work, and let's say I'm not gonna come back to this for 2 days, I just put it on stop, right? So this way I don't lose any work, but at the same time, I'm not paying for the machine that I'm not using, right? So that's what I'm going to do right now. I'm just going to put the machine for stop, right? Because I'm done with this one, right? Stop the machine. Yep. Okay. So you guys can do the same, right? So if you're done with done with the work, so you can right see my so my shell disconnected because the machine is going down. That's it, right? And you can always go back and start this up, right? So it'll take a few seconds to stop and start. So I always kind of recommend you guys stop the machine just just in case, right? Because the thing is happens like, let's say you come to the class and you sort of forget about the instance and it keeps running for like 2 months, right? And then you can keep paying for it. So yeah, kind of make it a habit to stop this, right? That's all. All right, guys. Sorry, we're a little over lunchtime, so let's break for lunch, 1 hour. Come back, say 12:15. Say come back at 1:15 Pacific, and we're going to continue. Right? So make sure to stop if you're done with the machine, you can stop the machine right now, and then you can restart it back later. All the labs, guys. So again, just to kind of make sure from the README file, the labs we just did cloud compute, just did the compute one lab. Okay. So it shows you how to spin up a machine and setting up Apache. That's it. All right, guys. Let me break for lunch. We will see you guys in an hour. Okay. Thank you. All right. So let's talk about Google Cloud Storage. So this is a kind of a cool thing, like, everybody's using cloud storage now. I mean, if you guys have a Dropbox, right? Same thing, right? Just dump the files and pretty much you can store as much as you want, basically, right? So, I mean, we kind of say unlimited within quotes. I mean, there is a limit, but, I mean, for practical purposes, it's unlimited, right? You can dump as much data into the storage. And also, they basically guarantee data, meaning they internally take their backups, right, all the stuff. So we don't have to worry about taking a backup of Google Cloud Storage, which is pretty nice, right? Because anybody who's like, if you're an admin, if you manage like a database or like a, internal file servers, like backups and everything, that's a lot of work. But here, you can just upload the files and everything is basically guaranteed, right? And of course, just pay as you use, that's as always. But also we have multiple classes. So let me talk about multiple storage classes per workload. Okay.
Excuse me.
Now,
so
yeah, sure. Question.
Similar to S3 on AWS.
S3, yeah, exactly. S3, yeah, exactly. So it's exactly like S3. They call it cloud storage. Yep, yep. And you will see, like as you go through, you will see a lot of similarities along with S3. Mm-hmm. Yep. Okay. So one of the things we are doing, so one of the architecture, kind of, if you think about architecture, how we do this is basically we store our data into cloud storage, right? And then we do our computation in the computation nodes. Like, so you can just spin up a compute node, right? So same thing. So what we'll do is like we can spin up as many compute nodes as you guys want. And when you want to process data, we actually stream the data from the cloud storage. So this actually has kind of, you might think, wait a second, I mean, isn't it expensive? I'm, streaming data from, some storage into my compute node. Not in Google, right? And that's what I want to make sure you guys understand. So this is called scale out processing, meaning I can spin up as many compute nodes as I want, and they read from Google storage, right? Now, if you're familiar with Hadoop, you're familiar with a concept called data locality. What does it mean is when you're installing Hadoop, so here's a Hadoop node. You can see here, right? These are like 4 nodes. And what will happen is, excuse me 1 second. So what will happen in Hadoop is that each node stores a little bit of the data. You guys can see here, right? See the blue, right? This is the data. As you can, the data is kind of stored across many, many machines. And also when you run your query, it could be like a machine learning query or simple SQL query, what doesn't matter. So the query also runs on each machine distributed. And when the query runs, they actually try to process the data locally. You see the like little lightning bolt, right? So they try to process data locally. So this way you can see, right? I mean, you can stack as many machines as you want, as long as they're kind of processing local data most of the time, you can scale pretty well. And this is exactly what Hadoop popularized. So, right, Hadoop basically said, okay, we are going to distribute the data across machines, also distribute the computing across many machines, right? And then, on each node, the computer is going to process the data that's stored locally, most of the time, not always, most of the time, right? So this way you get pretty good throughput in Hadoop, and Hadoop scales out pretty well, right? So if you use Hadoop, we have seen Hadoop clusters up to like 5,000 machines, right? So that was the architecture in big data, and that is still pretty prevalent. If you have a Hadoop Spark cluster internally, like in-house, this is what you have. Data distributed, processing distributed. So, and this works really well, right? And this is what most of us use on-premise. But this actually has a problem. This architecture, as good as it is, It's not very flexible. What I mean by that is like, let's say I have a 10 node Hadoop cluster. I want to expand to 20 nodes quickly, right? Quickly as in like, a few seconds or few minutes. It's not possible because now in a Hadoop cluster, as you guys know, right? Bringing on new machines is not very easy because even if you bring on machines very quickly, then you need to copy the data across the new machines. And that takes a lot of time because, when you say data, we are talking terabytes and terabytes of data, right? So that can take a lot of time. So scaling very quickly in Hadoop and Spark, when I say scaling, I mean like, increasing the cluster size, like going from 10 nodes to say 20 nodes is not very easy because the cluster size is fixed. So what Google did is, they were trying to tackle this problem, and they sort of basically built their network, and they use completely custom hardware, software network switches, right? And the result is their network can basically do petabit per second. So it's called bisection bandwidth, and this is like an incredible amount of bandwidth. I mean, if you think about this, I mean, how much data this can transport, that's really amazing, right? So just to give you a sense, right? With this bandwidth, you can say, right, 100,000 machines can exchange information at 10 gigabytes per each. I mean, that's incredibly fast network. And so you can sort of see, entire, Library of Congress in like 1/10 of a second, right? But to me, this is the most important metric. So imagine you are running a 100,000 server, cluster. I mean, most of us will never, but if you were, they can exchange data at 10 gigabits per second with the using the network. That's pretty incredible, right? And so the network is becomes so powerful. Now this is possible. This architecture is possible, right? Because as you can see, for this architecture to be viable, right? So that when you're separating storage and compute nodes, right, the bandwidth has to be very, very high for you to scale very quickly. But once you solve the bandwidth problem, then you get a lot of flexibility, because then you can see here, right? So here in Hadoop, my cluster size is pretty much fixed, right? If your company has a 50 node Hadoop cluster, that's it, it's 50, right? It's not very easy to go from 50 to 100 for your queries, right? Because you have to buy the machines, process them, install the machines, distribute the data. It's a lot of work. But in Google, what you can do, since the bandwidth is so high, you can spin up as many machines as you want. Let's say you're running a query and you say, I want 10 machines. That's fine, spin it up, run the query, 10 machines you get to write. Next query you are running, you say, what, for this machine, I want 50 machines because the query is more complex. That's fine, you spin up 50 nodes, run your query. And the storage will support, right? As you can see, storage and support, right? This many machines. So that's the beauty of the Google network, because they made the network so fast, you don't have to store the data locally anymore because the high speed bandwidth. Is that going to make sense, guys? This is a kind of a departure from a traditional. Actually, it's kind of when Hadoop was invented, this is based on version 1 of Google architecture. There's a file system called GFS, because we can read about this, Google file system. This is how they did it, version 1. Right, but this is, I don't know what version this is, but no, this is their latest version, right? Meaning they can completely separate storage and compute and give them a lot of flexibility in sizing up clusters dynamically. Does that make
I have a
sense, guys? Because,
question.
I know it's a departure from the traditional sense. Yeah, questions, please go ahead.
Yeah, so I have not worked with Hadoop before. So just so I understand, when you are having clusters and you're distributing data, are you distributing the entire data? Like entire data is locally stored, as in this image here, there is four copies of the entire data, not chunks of data.
Actually, no, yeah, you're right. Actually, chunks of data, right? So,
okay, chunks of data.
let's say I have files A, B, C, D. It's kind of like this.
Yeah. Okay.
Yeah, exactly. So, no one machine. That's a good question. No one machine has all the data because it's impossible, right? Because data sizes can be so big. So you have to distribute the data. The technical term is sharding, right? So data is sharded and distributed across many, many machines. Yep.
And so in the Google Cloud structure, all of it is stored in one location, but all the machines can access it.
Right. So here's the thing, right? So I sort of do this cloud as like a little blob, but remember there could be thousands of machines powering this block. You know what I mean? We don't know this. Think of it like a true cloud. You know what I mean? I don't know. I know I sort of treat it like a black box, but in fact, there are many, many machines, almost thousands or millions of machines that are actually, kind of doing this in Go, inside the storage. See what I'm saying?
Okay.
Right. But for all my practical purposes, I sort of think of it like a black box. I'm like, okay, I'm just dumping my data into Google Cloud. That's it. Right. And I don't really care how it's stored, but I know I can access the data at a very high speed. Right. So I don't really, care internally how they are being distributed. I mean, for all I know, they could be using something like this, but I very much doubt, because this is like version 1, like very first version that I know they moved on from this. So they're storing something differently, right? But functionality where they're guaranteeing you can read the data at a much high speed. Yep.
So does that hold even if, say, for example, if you start a Google Cloud bucket, typically you have to start it at a particular location, right?
Right.
So if my compute node is in the central region, my cloud storage, if it's in like another region, say for example, if I'm taking it to the extreme in
Yep.
Asia or
Mhm.
something,
Yep.
then then the speed, does that still hold or it doesn't?
No, that's a great question. So just so right. Just so that's a great question. So the way you are thinking about this is like right? So when you guys remember when you guys spin up the machine, you guys had to choose a locality, right? It's like you guys choose just central one or something. So same principle applies in Google Cloud as well, a bucket as well. You want to co-locate the bucket in the same data center, right? Because if you put them like you said, if you put them like my data, my computers in like say in Ohio, but my data centers in Singapore, yeah, you're going to suffer through that. Yeah, exactly. So yeah, definitely we want to put them as close as possible. Yep, that's very important. So question is like how's how's Amazon doing? Amazon hasn't, I haven't really found any material like on Amazon networking, but they are also now encouraging this kind of an architecture now. So if you guys use Amazon, if you guys use the Amazon Elastic MapReduce, which is their on-demand Hadoop, this is what they use, right? So if we map this to Amazon, so let me see this here, right? So if we map this to Amazon, this will be S3, this will be EC2, right? And this is the same architecture Amazon is doing. Amazon is saying, put all your data in S3 and spin up as many machines as you want in the compute cloud, and then we will support them. Yeah. So I'm sure they have. I don't know if they have Google scale, network, but Amazon is, they are pretty smart engineers too, right? I'm sure they also solve this problem, the bandwidth problem. I'm sure Microsoft Azure did the same thing, right? Because for the cloud vendors to do this, they have to first solve this problem. Meaning they have to provide high-speed bandwidth between storage and compute. Yep. Sorry, was that a question?
Sorry, Amazon does it the same way.
Yeah, I would imagine. Yeah, I'm sure. Yeah, they may call it a little differently, but yeah, architecture is the same pattern, right? Yep, exactly. And remember, this is what I said, in the early in the class. Like a lot of these clouds, the feature-wise and functionality-wise, they're like 80%, 90% same thing, right? They may implement it differently, but feature-wise, the same thing. Yep. Good, guys. Very good. So we understand. So again, so just a technical term is called, so local data is called data locality, meaning your data is living in the same machine. But what we are moving towards in cloud is network data, meaning your data lives in network, but the network is so fast, right? You don't suffer any performance. Yep. Okay. All right. So with that, let's look at some of the storage classes. So in Google Cloud, there are like 4 levels. The standard one is called standard bucket, right? So basically what we do is like, if you have data that you access frequently, you put in the standard storage. The other one, you say, you have some data, you maybe you don't access pretty regularly. Maybe you access like, I don't know, once a week or once a month kind of a thing, right? Then you put in a nearline access. What this is basically, right, a little cheaper, because they don't have to keep the data readily available right away, because you are accessing frequently, right? So let's say once a month kind of a thing, right? So you pay a little less. And even and the other one is called cold. You can still see that, right? Kind of, right? The price is kind of going up too. And this is like something, you access maybe less, once every few months. You put them in a cold storage. Archival is basically, something, you don't have to kind of access. You're sort of, keeping it for legal or compliance reasons. Maybe you will access it once a year kind of a thing, right? Archive. So kind of like, think like a pyramid, right? So this is sort of the most frequent access data standard, and then from there you sort of on a less frequent access data. And the idea is basically you pay less for these guys. Let me see if we have pricing for these guys. There you go, right? Yeah. So take a look at the pricing, right? So this is pricing for terabyte per month. Right? So how much for you're paying 1 terabyte a month? So standard you're paying about $26 a month. Senior line, $10, $7, $4, right? So same size of data, but the reason these are cheaper is your access time is going to be longer, right? Anyway, so not all the data is same, right? Because some data you just want to just keep it around for archival. You don't access all that much. Sometimes you access the data on multiple times a day, multiple times an hour, right? So depending on this, you can sort of distribute the data in a way you want. Does that make sense, guys? Yep. Storage, even storage, it's not like one storage type. There are 4 storage types. And let me see what else I want to sign. Yep. Okay. Yep. So yeah. So again, standard storage again, they are they guarantee you like 4 nines availability, 4 nines, right? 99.99 nines. This is sometimes also called hot data, meaning data you access pretty frequently. And then beyond that, you sort of move down the line, right? Near line, cold line, archival. Okay, so it makes sense, right? So this is how there's, and pretty much everybody has some way of doing it. Like Amazon, they call them warm, and then the colon they call glacier or something like that, right? Yeah, same thing, but pretty much the same principle. You pay less, and also in a lot of the companies, right? They don't have to keep all the data like as in hot status. So what they will do, like maybe like old data, they'll keep moving it down the pipeline, right? So, like for example, like like cell phone companies, they have to keep call records for like 7 years or 5 years, something like that, right? So, but they may access it all the time. Like it's not showing up on your monthly bill, right? So they may like anything over than 1 year, they may start pushing it down, these right? Because as you can see, you save a lot of money. So. Also, right now, like if you have data within the same region, there's no cost of bandwidth. But if you're shoveling data across region, then they're charging 1 cent per gigabyte. And also these prices keep changing, so you have to check their documentation to the latest price. But this is more or less the same, right? Right now it's 1 cent per gigabyte if we are moving data across the region. But if it's in the same data center or same region, it's free. It's pretty much all the cloud vendors have similar structure. Okay, so let's do encryption. And again, guys, please ask a question anytime. Okay, so when you're writing data, so let's say I'm pushing some data into say Google storage, like Google Bucket. So what they do is they encrypt the data before they save it on the actual disk. Because somewhere there's a disk, right? Even as a cloud storage, they save a data at disk. So what they do, they encrypt the data at rest. But from the client to Google Cloud, it's going in like as plain. Yeah. And this encryption is managed by Google, right? I mean, they will automatically encrypt the data at rest. When you read it back, they will decrypt the data and give it back to you. And this is called as encrypted rest. And they use 256. I mean, this is a fairly common encryption key, right? Which is very secure, right? So now you can also choose, but I mean, in this case, there's one thing, right? From the client to Google Cloud, your data is not encrypted. So what you can do is you can even sort of encrypt it and say, hey, you know what? This is the actual data, hello world. But from the client side, you encrypt the data even before sending it to Google Cloud. So over the wire, your data is encrypted. And also remember, in the Google Cloud, they will still re-encrypt again. Right? Because, I mean, any data packet they get here, they will encrypt before writing disk. So you're kind of doing double encryption. Right? So this is your data is now really secure because even during transit, your data is encrypted. But remember, the encryption here is your responsibility, right? So you have to manage the keys and encryption scheme, everything. Okay?
So here, the client, are we referring to client outside the Google Cloud or the compute
That's right.
inside? Okay.
Yeah, outside exactly. Yeah. Let's say you have some, let's say you are You're pushing data into Google Cloud. You have some client, like some sort of a upload client, right? Exactly, that's the client.
I see. Okay.
So again, you're kind of double encrypting, but so because I mean, either way, right? You're going to get this encryption for free anyway. Right? This Google does it for you automatically.
So
the
what's the
idea is,
purpose? Yeah, that was my question. What was the purpose of the server-side encryption?
okay, so they want to minimize the liability. Imagine, let's say, I don't know, like one of the Google employees, disgruntled employees, he walks out with a disk, right? So imagine, right? I mean, if your data is just sitting plainly, then your data is compromised, right? And it's the same thing. So basically, to kind of minimize physical, how do you say, physical break-ins, right? They encrypt the data at rest. So even if somebody walks out with the disk, your data is still safe.
Okay.
Yep.
Thank you.
Yeah. And also, kind of like doing this is kind of how do you say, kind of was a lot of legal implication for them, right? Because right. So in case of some, let's say they were sort of swapping out old drives to new drives, right? And somebody forgot to destroy the old drives, right? And now all this data sort of sitting there, right? I mean, remember, like, we all have done this, right? Remember, let's say you got a new laptop and you sort of keep the old laptop for a while. You're a minute to do a backup, but you never get around to it. And then, you sort of donate the laptop to somebody else. And now they have access to all your data, right? Same thing. So, the server-side encryption prevents data leakage, like physical theft, even when they're upgrading hardware, any of that. Yep. So anyway, so encryption, pretty standard. Either, you can do server-side encryption, which is basically given to you anyway. And if your data is ultra sensitive, you can also encrypt on the client side, but then you have to manage your own side and then send it to Google, and they will re-encrypt it, so you get double encryption. Right? That's it. Yeah, pretty straightforward. All right, guys.
Keys are managed on the server side. It's all managed. It's all Google's technology.
Right.
The encryption.
Yep. They manage the encryption scheme, and the keys and everything is managed by Google. Yep. Mm-hmm. Yep. All right, guys. So let's talk about something called buckets. And this is what you've been hearing, like when somebody says, if you're storing data, we're storing in buckets. Right? This is a very common term, whether you use Google Cloud or Amazon Cloud, right? They always say them as buckets. So the way the cloud storage is done is a bucket. So think of it like a directory. When you're a computer, you're creating a directory. Think of it like this. It behaves like that, but it's implemented very differently, right? So let me show you some of the options. So right, so buckets are designed to store blobs. They don't really care what kind of data you're throwing in them. You can throw text data, Word document, image file, doesn't matter, right? They are generic storage. They don't really care about the storage type. And bucket names, right, must be unique. So when you create a bucket, right, and also bucket names can be anyone see the bucket name. So let's say you are an Acme company, and if you name your bucket as this, anybody who's reading this can figure out, hey, you just made me deal with company X. Right? So because bucket names are publicly visible, so you have to be careful. So you want to use unique bucket names, but can also cryptic bucket names, right? So you can do something like project 123, right? Something like that. Okay. So again, the naming requirements. I know if you read the doc, they were going to spell out all the naming requirements. But basically, the idea is bucket name must be unique, right? And also, they will say, don't use, sensitive stuff on the bucket, right? So that's basically it.
So, Suji, so you're saying bucket names are visible across orgs, like from the hierarchy level?
Right. So, yeah. So what they're claiming is, since the buckets have global name scope, people can list the buckets. They cannot see what's inside, but they can list the names. Mm-hmm. Yeah. Mm-hmm. Yeah, because buckets are global. Yep.
Does that mean outside the organization?
Yeah, you know what? Let me double check that. I believe yes, but let me double check. Because since bucket lives in their own namespace, they can be at least the names can be visible. But let me double check if you can restrict by within organization or you cannot. Let me double check on that one. Okay. Yeah. Now, so now we understand the bucket. Buckets like just think like a large scale storage, right? And this is how Amazon has done it, Google's done it, I'm sure Microsoft the same thing, right? So how do you get data into buckets? So there are a couple of ways you can do. You can use a UI to upload the data. Oh, there's also like a, the cloud shell. I remember the command line client we used earlier. You can use that too. And these are basically kind of, depends on data size you guys have. So let me show you the diagram real quick. So a lot of the times when people transfer data, let's say you have some data somewhere stored somewhere, let's say Amazon S3. And I want to transfer it to Google Cloud. One approach is, you can sort of download the data to your computer, then re-upload it. And as you can see, this is not very efficient, right? Because Amazon to your download speed, right? It's not going to be that great. And then from your computer to your Google Cloud, it's not going to be that great either. What makes sense is you want to direct data transfer from Amazon to Google, right? Because these guys have very fast connections, so data can be transferred very, very easily and very fast. So you definitely want to choose C as an option when you're migrating from some other service. Right? You don't want to sort of download and then re-upload. Especially with large data sets, it's going to be very, very slow. Right? So, and Google has, when you look at the UI, I'll show you the UI. They have options to, either import data from Amazon, Azure, and they can download it up very, very quickly. Okay. Also, with each, I did the same with the compute cloud as well. I'm doing the same in storage cloud. So the Google storage and the command line is called gsutil. Right? So here are some of the, some of the commands. So for example, gsutil ls meaning list, right? If you say, see all the buckets, and you can so ls, you give like a bucket name. By the way, Google buckets need to be prefixed by gs. Think like your HTTP address on the browser, right? So Google buckets are prefixed for Google storage. So this is what we call scheme. Just like HTTP, right? When you type HTTP : right? Google.com, something like this. GS buckets have a scheme, GS : // right? And here, kind of like bucket creation, right? And then copying files from local copy to buckets, all the command line stuff. All right. Okay. All right, guys. So let's actually do some upload some data into a bucket. So at this point, we are going to come into, let's say it's my lab. So go back to README. So we are going to do storage 1, definitely, right? So let's get storage 1. So one thing I recommend you guys download is like you guys download our data set. So if you sort of click on the, on this one right here, you should download the data set to your, to your computer. Go ahead and download that, and then also go ahead and unzip that for me, right? So here's the link, right? Just download the data set and go ahead and unzip that for me, okay? Okay, so you have some data to play around with. Okay. So I think I just had this. Okay, once you guys download the data, or go ahead and also unzip the data, please. And it'll look like.
Which data set did you use again? Was it storage 1? Or which one did you from the document?
Oh, this one from the main link right here. Here's a link, right? Let me put the link
Data
on
set.
the.
Okay, got it.
Yeah. So let me put the zoom and zoom window as well, so you guys can click and download here. Yep. So about 300 meg, I believe, and it should download pretty quickly. Yeah. All right. So once as it's downloading, let's do storage 1. Okay. So again, from the README file, simply click on storage 1. Okay. All right. So log into your Google console. First thing we are going to do, we are going to create a bucket. Okay. So here's my Google Cloud. So you guys are already here. Click here, scroll down a bit. So we already done the compute. So now we are going to come to storage. So I want you to come and click on the storage. Okay. So this is under the storage tab. And you'll see there are tons of different storage types. But for now, let's just do storage. Okay. So these are all the buckets that you have under your project, right? And right now, you probably don't have any bucket at the moment. So we're going to go ahead and create a bucket. Okay. So again, it's everything clear how we get here, right? From the side menu right here, right? Scroll down, come to storage, and then storage. Okay. And then we are going to create a bucket. So say create bucket, and I'll give it a bucket name. So create a bucket right here, see my mouse, right? Create bucket. Okay. So give it a name, and they're going to give you like, some naming guideline. I just give you some, standard naming guideline, right? And if you really want some more information, you can click on the guidelines and read about this, right? So just say, you can say Suji, right? Google class, right? Okay, simply say continue. Okay, so they're saying, no, you're gonna use Google. All right, fine, okay. All right, so here's the next thing, all right? So I'm gonna wait here for a while so everyone can catch up. So we're creating a bucket. And also look at the screenshots, right? We are kind of walking you through the screenshots as well. So when you create a bucket, there are, you can choose how you want to store them, right? You can create them, right, in a single region, if you like, right? So this is what you would sort of use if you want to, co-locate your bucket in the same region as your compute cloud, right? Because then, right? See how it says lowest latency within a single region, okay? But then you run the risk. What if that data center is Google's data center is like is not responding? Let's say there's an earthquake or a flood or something, and that data center is damaged. So now all your data is in the data center. That's not accessible. So dual region, right? Is where you're doing the same thing. You're keeping one copy in the region and making a backup on another region. Right. So in case something happens, let's say your data center in say I don't know say San Jose, and something happened to San Jose data center, your data center is still available in let's say in a Vermont data center, right? So high availability, and also you're still keeping a local copy, local latency. Yep, makes sense. Because then multi-region basically Google will distribute the data, so you get highest availability, but you're sacrificing a little bit of performance, right? Because I think they make 3 copies of the data. And here, you can just see here, right? You can select, but I don't think they let you choose which regions, right? Because if we do single region, they let you choose where.
Question,
right?
What order of magnitude are we talking about in terms of latency?
Latency within a single region, we are talking like, easily sub-milliseconds. Across region, you're definitely talking like, 2 digits. And multi-region, you're kind of when I say 2 to 3 region, I'm talking like 50 to about 200 millisecond kind of a thing. Yep. Okay. So yeah, it kind of adds up, right? Especially when you're doing a lot of data transfer, latency can add up. Yeah. So it's kind of a right. Again, these are kind of hard to gauge because the reason is it depends on how busy the network is, right? If a lot of people are transferring data at the same time, and if you're unfortunate to kind of get them at the same time, then you're going to be slower. But let's say the network is pretty idle and you are the only one who doing a lot of transferring, then you're okay, right? So yeah, so there are a lot of factors that play into this one too. So you can sort of play around here, like you can say select the region. They'll let you pick the region, right? So if your computation is mostly, let's say you're mostly computing in say Virginia, Oregon, right? Choose that. If you want dual region, they let you sort of right? Kind of pick those 2, right? So And multi-regions, basically you can say, states or EU, or, Asia, they're very kind of, very high level, right? So the only thing they're guaranteeing is within US, we are going to put them in 3 data centers, or you can do EU. Like for example, this is important because especially EU right now, they have GDPR rules. You cannot store EU data outside EU, something like that, right? So we have to be careful, right? Let's say your users are in EU, you need to sort of store them within EU, I believe. Yeah, I think that's one of the restrictions of the GDPR. Right? Anyway, so for our reason, guys, we can just simply do, multi-region info, right? It doesn't matter, right? US or like, like in the dual region. So, right, either way.
So I'm surprised that they have limited availability or access where we can store. Just like GDPR, there could be that some countries may have their own unique rules or whatever. Then
right.
How would you?
Right. If that's the case, if you need to get that super accurate, then I had to you do like either dual region, and they're gonna choose. You know what I mean? And also maybe they may be limiting based on my location right now. You know what I mean? So if you're in EU, maybe you have more choices. Right. So I think you're kind of saying, I'm not getting too many
Saudi
choices,
Arabia
right?
or China.
Right.
They don't let
Right.
any-
Right. Right. I don't believe there are data centers in China or Saudi Arabia. Right. Exactly. Yeah. But I mean, yeah, if you are in the region, yeah, you're right. So you have to choose the one, that's going to work for you. Exactly. Yeah. 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 So for now, guys, we can just do single region if you guys like. Right. Again, we're not going to upload a lot of data. Right. It's just for testing anyway. Right. So, but single region, you have choice. It's more fine. So they actually give you where exactly you want to place the data. Right. So you can do single region, and you can choose if you're using central, use central, just choose central. Right. So, sorry. Yeah. Okay. So continue. Let me see what else I want to see here. Yep. All right. So next thing is encryption. Okay. So remember, also there's a storage class. Remember we talked about the 4 storage classes. So are they asking, do you want the standard one, or kind of maybe you can do get it a little slower, and also kind of you can sort of see, right, the pricing. Okay. So you say, what, let's just do standard for now. Okay. Continue. But we understand what all the choices mean. So access control, we can simply say, fine grained, basically meaning you can specify access per object. Like, let's say you have some. So for example, what I'm saying is like for some files you can give, control access than others. Uniform basically means like, all the objects in the bucket have the same permission, right? So, okay, yeah. So we just do fine grain because this gives you a chance to kind of set some objects as public, some as private, things like that. Doesn't matter, right? So, yeah. All right, next one is encryption. Remember, so Google will encrypt the data and they will manage the key for you, right? So remember the diagram, right? So anytime we send data to the server side, you get server-side encryption anyway, right? So this is a given. So we are saying, okay, you know what? Yeah, we'll kind of let Google manage encryption for us. Okay. That's it. And then also, this is basically like, for example, you can say, after you delete an object, how long you want to keep, because sometimes, people delete things by accident. So this is like, you can say, how long, you can sort of keep the data even if it's deleted. So you can restore, right? Again, so we can sort of leave everything as default. If we don't want to mess with that. Okay, what else I want to see? That's it, okay? So these are the settings, guys, okay? So, we are doing your central, right, standard, fine-grained, and Google Manage Key. Excuse me, that's it. And I think, and also you can sort of see here, right? You can sort of see, okay, you can sort of estimate and say, okay, you know what? I think I'm planning to store, let's say 5,000 terabytes of data. So sorry, 5 terabyte meaning 5,000, right? Let's say 10 terabytes. That's 10,000 gigabytes, okay? And I want to say, okay, right? So we're going to use like, how many, let's say I'm going to do like, whatever, 10,000 operations. So you can sort of, estimate how much your monthly cost is going to be, right? So operations, they kind of put class A and class B. So, so when you move your mouse over, they tell you exactly what is class A. So class A is things like, uploading things, right? I think they cost a little bit more. Class B is more like, downloading, right? So they tend to cost a little less. Look at the pricing. So this is like 005, this is 004, slightly cheaper, right? Anyway, so you can sort of, do some estimation to see, how much you're going to pay per month. Right, so this for 10 terabytes, I expect to pay around, I don't know, like, $200 a month. So if I'm doing 1 terabyte, let's just do one, just to, so we can see. Oops. Okay, so we're selling 1 terabyte, basically 1 terabyte per month, starting at $20 a month, right? And, this is not, not counting any, how much, how frequently you're going to access data and all that, you know what I mean? So, I mean, this is just storage fee. Okay, all right.
So, sorry, I'm new to this space, so just a quick comment. Like that $20,
Sure.
in my mind, that's not cheap, right? I mean, if you compare it to, I'm comparing cloud versus having in-house. I can get 1 terabyte hard drive for how much? Typically, I don't know, $10 to $50. I don't know. So this is.
Yeah, I think for like $100 you can get like a 2 or 3 terabyte hard drive. Yeah. So let's say $50, right? Yeah. Yeah. Just to make simple. Yeah.
So this is monthly multiplied by, let's just do simply like a annual $200 annual, right?
Yeah. For 1 terabyte, exactly.
Is essentially twice the cost of what I can have the physical hardware at my location.
That's a great question. So so let me just do like a on-premise, right? So let's say your disk's cost is, let's say, how much? Let's say 1 terabyte costs like, $50, right? Okay, on the Google Cloud. So 1 terabyte is basically how much? Was it 20 a month, something like that, right?
Yeah.
20 a month. So per year, you're saying, let's say, 240 or whatever, right? Yeah, right. So you're right. So basically in Google Cloud, as you're storing data, you're basically you're renting space, right? But on-premise, basically, once you buy a disk, you have the disk, right?
Yeah.
So what are the other things we should consider? Like, I mean, and this is a good discussion I think we should have. What do you guys think? I mean, like, just when you're comparing on-premise versus cloud.
We need to account for backups.
That's right. So remember, on-premise, we reduce, a lot of other things. Like if you just buy a disk, you're also like, have also, don't forget the compute cost. Like it's, let's say you're to buy the machine, install, maintenance, right? It's somewhere the maintenance, and then backups, don't about like, things like, electricity, data center costs, right? There are a lot of things that you need to have in-house before this is become feasible, right? So you want to add this too. Does that make sense, right?
I mean, then the employee who manages all this. So
right,
I guess
exactly, right? Yeah.
My question then is, initially when cloud came around, the argument was, oh, it is cheap essentially, and we take away your pain, right?
Yep.
Since you have experience across different clouds, do you see like what kind of, let's say, price targets they go for, like 10% of the price of overall what would be your cost on location or something? Like, I'm sure at the back end they are doing some kind of pricing analytics to figure this out.
Yeah, they're true. I mean, because so one thing that's still true is cloud is basically, they take away, they do all the maintenance, right? So that part is still true.
Yeah.
So when you throw thing into Google bucket or whatever, you're like, you can forget about, everything else, that they take care of everything, right? So all these is included in your $20 a month. But at the same time, at large scale, this pricing can really add up, especially if you're storing like hundreds of terabytes or petabytes of data, right? This expense can get pretty expensive, right? So I think for this reason, Dropbox, initially they use Amazon Cloud, I believe, or Azure Cloud. So Dropbox, we all know Dropbox, right? And then they realized they were paying so much money for Amazon, and then then they basically build their own system in-house, right? Because I mean, Dropbox, as you can imagine, they're like paying so much money. But
Yeah,
here's
I mean,
the
that's
thing.
their basic value proposition, right? So,
Exactly. But Dropbox has expertise in building systems, right? I mean, if you're a startup or like a company, like let's say even like some like Walmart, right? I'm like, you know what? I don't want to kind of build my own data warehouse of disks, right? I would rather like pay somebody to manage it. Let me show you guys something. I don't know if I can still find this. NASA, AWS, Bill. See, there you go. Okay, see. So NASA has 247 petabytes of data, right? So now they're uploading everything, right, into AWS, right? And somebody like, I don't know how it's, I remember seeing like some pricing, how much it was. It was like some absurd amount of money they were paying. Let me see if we can do a search. There we go, right? So they are going to spend 30 million a year, right? And then now, they have project to do more like, right? So, and here's another one. So yeah, these things are not cheap. Right. So, but NASA I'm sure they did the cost calculation and say, hey, you know what? Yeah, it's going to cost us more to kind of keep running this, right? But you can see they are like, I mean, they have insane amount of data. You can imagine like all these observatories and satellites are producing all the data, right? So they kind of figured, they must have done the calculation. They say, hey, you know what? Yes, we are going to pay like millions and millions to AWS, but it's still going to be cheaper than storing it on our own. Yeah. So you're right. I mean,
well, but if you look at the title also, it says, but forgot about the eye-watering egress cost, right? So
that's right.
It is not uncommon. I've seen, since I come from the business side, so it is not uncommon that businesses overlook some kind of taxation or some kind of this kind of caveat, and then later find out that, oh my God, we made a mistake.
Exactly, and that's a good point. I will also point out here. This is the same mistake we made here, right? So I just calculate, hey, how much it's going to cost me to store 1 terabyte of data, right? What I forgot is I didn't do anything like the operation, like meaning like how much I'm going to download, how much I'm going to upload. Especially in case of NASA, they have like a public-facing website. People are downloading videos and right. So yeah, if you keep this as 0, you're in for a very rude surprise, right? So they say, oh yeah, they'll say, it's like I was just buying, now that everybody's at home, if you try to buy any gym equipment, everybody's sold out, right? Like if you try to buy like weights or dumbbells or whatever. So I went to Amazon the other day. I'm like, okay, you know what? I don't know when the gym is going to reopen, so let me buy some weights. So this seller, they had like weights like $50, shipping like $75. You know what I mean? So it's more than. So it's like this, right? So it's like, they'll say, oh yeah, the cost of storing is $20, but the cost of egress is like $200. You know what I mean?
So while we are at the point of making fun of ourselves here, right? That we made this mistake right on the screen.
Yeah.
From user experience perspective, if you look at it, you appreciate the little things. They made everything easy for you to see, but here too, they did not put any egress cost.
Yep.
You cannot easily see it. So this is like a shady thing to do, to be honest, if it is going to be significant.
So basically, when you see the ads, they, how they say starting from, right? This is what starting from. This is the minimum. I should put like a star here saying, this is the minimum you are supposed to spend, right? But so you're right. I mean, the argument goes both ways, right? I mean, I had some clients of mine who had, not this scale. They had like about hundreds of terabytes of data. So they went to cloud because they basically said, look, we don't want to deal with infrastructure anymore. Yeah, so we'll pay Amazon, right? And we understand we are paying more than storage, but basically, they're kind of like outsourcing, basically, right? They're basically outsourcing their storage to Amazon, and for them, it's worth it. I just do an example like Dropbox. They brought it back from Amazon in-house because they know how to build this on their own, and they can be very cost efficient. So I've seen movements both ways. So if you ask me what's the right approach, I don't have an answer. It's basically it's going to heavily depend on your how much data do you have, and like you mentioned, the usage pattern, and also most importantly your expertise, right? Because if you don't have expertise managing in-house, You know what I mean? Right? If you're going to spend a lot of money on a labor, right? And all this, you might as well just, send it to Amazon or Google or whatever, whoever, right? Yeah.
It's like Netflix that uses AWS.
That's right.
Yeah.
Yeah.
So this is Omar. So
sure, please, go ahead.
manage cloud transformation project for data warehousing, and we saved like a ton of money, because like for ETL, we used to spin up servers when we needed them and then shut them down.
Yep.
You use the resources when you need it and then shut them down. And especially if you start using the open source software like Linux, you're not paying any licensing costs. You start using databases which are open source. So open source goes with it. So you save a ton of software, like ton of expenses.
That's true. That's true. So sorry, you're saying you're saving a lot as opposed to keeping it in house.
A lot.
Yep. And again, I mean, and also,
sorry, I missed the point. So the point is that you're saving a lot by going on the cloud, or
on the cloud and open source. The two things go together.
Right.
Because we were originally on IBM. IBM is millions of dollars. So, and Microsoft is also expensive as well. Like our servers were 24 core servers. And we went to open source, which is no licensing cost, and just use the servers when you need them. So like it's less than 1/10 or like 1/100th of the cost.
Actually, that's a good point, Amar. I forgot to mention this because because I pretty much revolve with open source world. So one thing I always forget is when you're doing file systems in your on-premise in-house, right? You're not doing it open source. You're buying some from like Hitachi, IBM, one from these guys, and they are very expensive. Right? I mean, because I always forget about the licensing cost because I always worked on open source. But you're right, Omar. Yeah, I mean, right. These things like these large file system you buy from IBM, Hitachi, Microsoft, they're not cheap. Yeah, that's true.
So 10% is a very, very good benchmark you gave. Like that gives me some context. So I do hope that you have thought about the egress cost too.
Yeah. I mean, here's another thing, right? I mean, if they are not doing customer facing, or somebody's not downloading data, if all their bandwidth is restrained between the data center and the compute, right? Then you don't have a lot of egress costs. See what I'm saying, right? Because
but NASA would. NASA does not have customer face.
NASA would, because NASA, right? Because when NASA puts a nice video, a photo of Hubble Space Telescope, we all want to download it and put it on our desktop, right? So NASA is definitely going to have a lot of egress. Exactly. Yep.
So I don't want to beat the dead horse more, but since you do provide consulting, is there a pretty open and clear opportunity here in terms of providing consulting costs to optimize the cloud cost for, and help companies decide among the 3 clouds and all that?
Absolutely, right? Because here's the thing, right? And as you can see from the screen I just showed you, and this is a pretty good example.
Yeah.
Calculating these costs is very tricky. And trust me, we've been using Amazon Cloud for like, like almost 10 years now. And our bill is always higher than we expect. and
you guys are experts. I mean, this is ridiculous.
Right? Yeah. Every time we go back and look, we discover like some hidden thing. I was like, we forgot about that. You know what I mean? Like, so it's like, because one thing, these cloud vendors are really good. I mean, I don't want to single out Amazon or anybody, right? The same thing, everybody. They will bill you for everything. Like they will bill you for, access, you know what I mean? Like, backups, you know what I mean? Like everything is charged in some hidden way, right? So that's why it's very important. And they have a calculator here. You can sort of go and sort of look at the calculator. But thing is, it's like filing a tax return. They're like a bunch of boxes. They say, okay, how much data you're going to upload, how much you're going to egress. How do you calculate the numbers? You know what I mean? Like so, yeah. So I mean, you got to be very good at estimating your usage patterns before you get an accurate price of the bill. Yeah. So anyway, so I'm going to stop here. But I mean, I hope we understand, right? We saw the, I just trying to get a couple of use cases, how NASA is going in and Dropbox, got out. But yeah, this can really add up. Right? So, all right, guys. So
I got one quick question. Is the Google Drive storage space you get with your Gmail account, is that an example of a bucket?
I believe there's a bucket powering it underneath. Actually, you know what? The Google Drive is like kind of a hybrid storage, because some of the latest one, they use their thing called, I forgot the name of the thing. Colossus. So yeah, it could be partly bucket, partly another one called Colossus. So yeah, so yeah. So it's called, just like a giant Colossus, right? So do some research on this one, and you'll find some articles on this one. Yep. Yep. All right, guys. Good discussion. So what we have done is we actually created a bucket. Okay, so everyone's with me so far? Okay, so your bucket names are, right? So you can say, look at the bucket browser, right? As you can sort of see that, right? I get a simple region, one region bucket, central, with standard storage, right? All that. So, alrighty. So click on the bucket. Let's upload some data. So here, you can just upload. Let's say, you can say click on upload, and you can sort of, you can pretty much upload anything you just want. Like for example, here's a, right? Here's my PDF file, right? Whatever from your computer, just upload it. It's done, right? Oh, I think oh, sometimes these things kind of time out. Okay. All right, so you can go ahead and actually try to upload single files, right? You can choose a file, okay, upload it. Huh, oh, why it keeps failing on this one? Okay. Or you can also upload an entire folder. Like for example, go ahead and select a folder, right? So here, right? And if you download the data set, here are the data sets you can look at, right? So for example, you can download, say, flight data, right? You can upload the whole thing if you just like. Okay. So for some reason, my bucket uploads are failing. So let me see what's going on. But anyway, so hopefully you guys have better luck than I am. Okay. All right, guys. So I guess able to upload some files into your bucket. See what else we should do next. Yep. Okay. All right, guys. Anyway, so yeah, so I create a new bucket and say, are we able to upload the files? Fine. So, so again, you can sort of create directories, all the usual stuff, right? So now we understand how they work.
Give us a few minutes so that we can upload.
Sure. Yes, please. Yep. Take your time.
So Suji, I uploaded like 4 different folders, and is that the expectation?
So the data bucket has many folders. Which one should we upload?
You may have stepped away or is on mute.
Sorry, guys. Was it a question?
Yes. So the data bucket has many folders. Which one should we upload?
Oh, actually, yeah. Good question. Yeah. Let me show you guys this. You can pretty much upload anything you guys want, guys. So, for example, you can upload, let's say, house prices, right? So, this has like a bunch of files in there. So just go and upload, say, house prices. You can upload the entire folder, right? So what you do is you say upload folder. Oh, sorry, not yeah, I should be, sorry, I'm the wrong thing. Go back to the bucket. Right. Say upload folder. Let me large upload folder. Data set. So, just say house prices, right? Choose that, right? Upload. And then it'll kind of create the folder and then upload the data internally. Yep. And remember, this is your own bucket, so you can pretty much upload anything you want. But for now, just upload house prices for now. If you get like. All right, guys. Let's see. Okay, uploading data. Gotcha.
Yep. House prices is uploaded.
Yep. Sounds good. I want to try something quick as well as trying out. guys. Let me, so how are you guys doing with this one? Yep. All right. So I hope we are done with storage one, right? So basically what we did was we uploaded using a console. So you just went to the UI, you sort of say upload files. So this works for sort of small data, right? For example, if you look at our, our data sizes, right? They're not that big, right? If you look at the house prices data, what is it? They're like megabytes. So small data you can upload through UI. And I'm also going to show you guys how to upload some medium to large data as well. For this, we had to use command line. And that is what this lab storage 2 is going to show you guys. Okay. So let me walk you through storage 2. And then, and you guys can do that and we'll take a break. Okay, so first thing I want to actually show you guys is, let's kind of explore some of the data we uploaded. So here's my bucket, right? So here's my bucket browser, bucket, and here's my house prices. And if you go and basically click on, just go ahead and click on any of the file, right? So see, and you're gonna get some attributes. When it's created, what's the size, and pay attention to this guy. See how it says GS colon, right? This is, I don't know, let me maximize a little bit so you can see better, right? So this is your storage name for in a Google Cloud. So Google GS stands for Google Storage, right? So almost like a URL, when you go to the website, you have the website HTTP, right? HTTP, same thing. So GS colon underscore, right? So let me copy this. So cloud URLs is this one, right? So I'll just make this simple. Okay, yeah. So if you guys are familiar with the Amazon, can you guys tell me what the prefix is in Amazon?
S3.
Exactly. So it'll look like S3. Yep.
Yeah.
There you go. So now we get it, right? So these, so again, all these file systems are what we call, URL friendly, because cloud, everything is a URL, right? So they're kind of, even the files are named like a internet resource. I haven't worked on Azure, so I don't know what the Azure prefix is. Anyone know Azure prefix? This is a Google Cloud, right? So they are GS, AWS is S3. Not sure what Azure is. So I haven't worked on Azure, so maybe I'm sure whatever the feedback thing is, it'll be the same thing, right? So I'll just say XYZ, right? But anyway, but you can see they follow the same pattern. So the pattern is what? Bucket name, right? And then basically after the bucket name is basically path. And this path is kind of mimicking like a directory structure in a computer, here's my data sets, right? Here's my directories. So path is kind of mimicking folders, right? Because they know, people are used to working with folders. So that's why, right? So they kind of, they give you an illusion like you have directories. But at the end of the day, what you really have is just an object. That's it. So this whole thing is the name of the object, right? But since
So
since
I have a question here.
Sure, go on. Yeah.
Maybe I'm jumping ahead of myself here, but so let's say this same file, the path you just showed. Let's say that I wanted to do something with it and I wanted it in JSON. Is there some automated way to change from CSV to JSON?
No, that not within the file system. That you have to do on your own, right? So the file system is simply storage. That's it. No processing.
Got it. So
Yep.
if I'm sitting in Google environment, how would I do it?
So what you, and that's a great question. So we will show in the next upcoming sections. But basically what you will do is you will spin up a compute node and do your transformation, and then you'll upload it back, right? So what you do is like you spin up a compute node, you sort of, then you sort of download this file, right?
Yeah.
And then you do like a, let's say you do like a CSV to JSON transformation and then upload it back.
So that I'm doing on my own machine?
On your own machine, or you can even use the edge machine as well. See the edge machine in the web shell, right?
Yeah.
You can, for small amount of compute, which is not too much, you can use the edge machine as well. Yep. Okay.
And that edge machine is in Google Cloud?
In Google Cloud as well, exactly. So it's kind of like think like a on-demand virtual machine that's available for you at any time. Mm-hmm.
Got it. Thank you.
Yep. Good. No, these are great questions. Yeah. All right, guys. So what we are going to do now, so we know how to upload through UI. So we also explore the file, so we understand, right? What this file URLs means and all that. Okay.
So Suji, for some reason, the house prices folder upload is not working for me. It says failed several times.
Oh, can you upload individual files then? So what I would recommend.
Individual files is okay. Yeah.
Okay. So in this case, rather than fighting it, what I would recommend is just create a folder and then upload individual files. Yep.
Okay.
So sometimes sometimes I notice like some permission issues, some it doesn't propagate well. I noticed this too. It could be a project setup issue, right?
Mm-hmm.
So let's not spend our time debugging right now. Let's move on, and then we'll come back to the VR time. Yeah. So just manually create a folder, house prices, and then go in there and then upload the file. Yep.
Okay.
Okay. Yep.
So before we move on to the next topic, you were showing the URL for GS. Right below that was a link URL. So what's the difference between the two? One is HTTPS.
Right. Good question. Yeah. Thank you for noticing this. Yeah. So let me go back here. Yep. So this, right, this is an HTTP link. So let's say you want to upload, share a file with somebody public. So to access GS, you need to be within Google system, right? But if you give an HTTPS link to anybody who has, who has internet access can download it, right? But I bet you right now this won't work because this is your private bucket, right? So, no, and if you just give the link to anybody, if I just copy and try to download it here, right? It probably won't work here. Let me see. Yep. It worked here because why? Because I'm logged in, right?
You can put it in Zoom window. Let us click on it. Let's see what happens.
Yeah, actually, yeah. So why don't you guys try this? I very much doubt it, but yeah, you guys can. Yeah, here's my storage. Right. Try to click on this and see if you guys can download it.
Forbidden. Error.
Exactly.
One of your settings said not public.
Exactly, right? Because my bucket, if you look at the bucket setting, my bucket is not public, right? And the object which I have is not public either, right? So you can change it to public if you want. Like for example, let me minimize this a little bit. Okay, right? So you can click on this, let's say house price sample, and then there's a way you can have permissions, right? And objects. That's why I always keep missing around here.
Public access, yeah.
Public access, there we go, right? Yep. So edit permissions and public access, right? So right now, only the project owners can get it.
Got it.
So exactly. So if I made this bucket or if the object public, then you can download it. Mm-hmm. And the cool thing is, right? I mean, this is just a HTTP URL, just like a web URL, right? So you don't need to be logged into the Google system to download it. It's accessible to anybody. Yep. So that's why they display two URLs. One is private, right? So the GS is actually you have to use it within the Google system. The other one is is public, but public as in only if you give them permission. Yep.
So I'm sorry, one more follow-up question here.
Yeah.
So
yeah.
Now that this file is stored there, you as a project owner, when you access it from somewhere else within the Google system, can you manipulate the data from there, or do you have to do something special here so that you have that kind of opportunity to do that manipulation from somewhere else? Can you overwrite the file or make changes to the file?
No changes, right? So Google files are immutable, but you can overwrite them. right? So yeah, overwrite the meaning that you basically what it means is you're sort of deleting the old copy and putting a new one in. But once you copy a file, you cannot go and kind of change the file, right? Exactly. Yeah. So you can always copy over a new version, just like yeah. So that's one thing Google guarantees is like they make sure, right, files are immutable and non-modifiable, because this way your data is data is kind of how do you say safe, right? Meaning like nobody can go in and kind of change something in the middle. But you can always overwrite. But when you overwrite, things change. Like when you overwrite, your timestamp will change, right? So you can easily detect, hey, this file is not the one I had. It's like something else. Yeah.
So let me ask you a stupid question here. Let's say that for this CSV file, I wanted to add a column and it multiply all the house prices by 2. So I have a new column. What would be the optimal way to do it?
So here's a very simple answer. Google storage is just storage only, no computation whatsoever, right? You cannot manipulate data from within storage. If you want to do any manipulation, you have to basically download these files, do your change, and re-upload it back. That's it. Yep. So think of it as like basically dumb storage. That's it. Nothing more, nothing less. Just storage. No processing at all. Yep. So don't think of it like a database. Just think of it like a file. I mean, yeah, it's actually it's even like, I wouldn't even say like, like for example, like, so here I can open my file, right? So my, right, I can, like I said, like I add a new column and save it back, right? So in my computer, that kind of almost seems seamless, right? But in Google storage, it's just storage, nothing else. So if you want to do any change at all, download the data, do your change, somewhere else, and then re-upload it back.
So when you re-upload, I mean, is the old version going to be kept somewhere? Is there any way I can get
back? Good question. Yeah, good question. So what you can do, you can enable versioning.
Okay.
So what it means is, just like, when you guys do Google Docs, right? When you upload Google Docs, like I don't know if we can show it here. I don't know if this, somewhere here, there was a file, version is, there we go, right? So see how they store the version history, right? So every change you make, right, it's kind of, same thing. You can actually enable. So this is not by default, but you can enable it, right? Because remember, when you enable version history, what happens? They have to store, store more data, right? Every time you overwrite, they have to also keep the old version. But yeah, so there's a property here you can enable to keep versions. Yeah, and then when you overwrite when you keep overwriting files, and you can also control how many versions to keep. You want to keep 3 versions, 10 versions, whatever, and they will keep it. Yep. Yep. So that's how, if somebody accidentally overwrote a file, you can always revert back to the old version, just like Google Docs. Yeah, that's a great question. Yep. Very good, guys. Anything else? Oh, so let's actually let's do this real quick. Actually,
I have a question. So
go on.
I see different when I go to the permissions. I see something different. Maybe I set it up wrong.
Oh, here.
Yeah, I didn't see where I could change it to pub to. I see roles, but I don't see where I can change it from private to public, I guess.
Oh, what you want to add is like, so I think, so right now, so there should be a, you can either do bucket level or you can do for object level. So you want to say add members, I think, right? And then you want to say, this is like per members only. But if you want to make the entire bucket public, there's another way of doing this. Hold on 1 second. Permissions. All right. Storage, admin, viewer.
Yeah.
And then you simply say something like bucket. 1 second. There's an easier way of doing this. Right? This is an old legacy method, because the bucket I have is like an old legacy bucket, right? So there we go. So you simply say edit bucket, and there was like
edit
bucket. There was a place I swear there was like you can change it to public. No. Okay. Oh, I see. Because since we create, okay, I see what's going on. See, since we created this as a fine-grained bucket, what does it mean? Fine-grained meaning each object is individual object, right? So if it's a uniform, right? Meaning like, so uniform bucket, meaning everything under the bucket
Right.
can be one setting, right? So if you want to do a public bucket, whatever, you should do like I'll create a uniform bucket and then say public,
Okay.
right? Then basically everything you upload under it is public. As an example, let me show you guys this. Let me cancel out of here.
Fine grain is by role.
Yeah, by object, exactly.
Okay.
Right. So take a look at this one. So if you guys go to, actually guys, can we do this? I know we're kind of running up by time. Can we take a quick break, afternoon break? And when we come back, I want to do the storage to lab, right? So 10 minutes. So come back around say 3 o'clock my time, right? And then we'll continue. I know afternoons are challenging because after lunch everyone's kind of sleepy, a little tired. So let's take a break. 10-minute break, guys. So like almost 14:50 here. So come back at 3 o'clock my time. Yep. All right. And then we'll continue. 10 minutes, back by 3 p.m. PST. Okay. All right, then we'll continue. Thank you. So guys, we are back. All right, so let's start with storage 2. What this is going to demonstrate is how to upload large data into Google Cloud. Let me show you guys this one. Right. So right now what we have done, when you guys downloaded my data and uploaded again, you guys did A and B now. So when you guys uploaded the say house prices, for example, right? You downloaded my data from some public repository onto your computer, and then from your computer you upload to Google Cloud. That's fine for small data. But most likely you will deal with large amounts of data, and I want to show you guys how to do C, meaning doing direct transfer. Okay. So this is there are many ways of doing this. I'm going to show you guys one way. So let's go ahead and if you guys would, okay, close that. Go ahead and go to lab storage 2, please. Okay. And kind of follow the instruction. So what you're going to want to do is like you want to go to Cloud Console and open a Cloud Shell. So now you guys know how to do this. Go to Cloud Console, right? And my Cloud Shell is right here. Right. So I had it minimized, so I can reopen it again. Okay. So I have some data here, right? So let me just, okay. So because these are my old environment. So what I'm going to do, I'm going to actually show you guys how to download data. So what we are going to do is like this. So this is the process. Diagram, right? So what I'm going to do, we are going to basically, here's what's going to happen. So I have data in some public cloud, and I'm going to basically download this. Okay, here's what's going to happen. All right, so this is some, my data is in some, right, somewhere public, large data. And here's my Google Cloud, Google Storage. So how do I get data in? Because remember, Google Storage doesn't have any compute. So I need to do the computation on my own. So what we're going to do, we're going to download this here, right, and upload it here. And what is here? This is my Edge node Cloud Shell. Okay. And this is why Cloud Shell kind of becomes handy because, right, it's free, it's available, and I can download it and upload it because, Cloud Shell, remember, Cloud Shell actually resides into the Google Cloud ecosystem. Is that going to make sense, guys? Right, what we are trying to do? And this is the most common way you will actually end up uploading data. It's with large data. Okay. Does that make sense? What we are trying to do here?
Yeah, I'm sorry, I have a question.
Sure, please go ahead. Yeah.
I joined late. I didn't see that the README file you are clicking on. Like now we are at this step and this step. Where do I get that file?
Oh, sure. So this is a lab file. What you want to do is, are you at this? Are you in the class notes section? Right.
Yeah.
Yep. So this is the class notes, right? So scroll down, and you'll see what I'm highlighted called class folder.
Yep.
Yep. So go there. So click on go here. And then you'll see a zip file called labs.zip. Do you see that?
Yeah.
Yeah. Please download that.
Okay.
And once you download to your laptop and then unzip it. And then there's a README file there. And then you'll see a file called readme.html. Just open that, and then it'll look like this. Right? Yeah. I'll check on you in a few minutes. Yeah. So download the zip file, unzip, and then simply open the README file. Yeah.
Okay.
Sure thing. All right, guys. So storage 2 is what we're going to do. Yep. Okay. Go to cloud. Open Cloud Shell. Okay, good. I got that going. Okay. So what we are going to do, we are going to download some quote unquote large data sets, right? So again, there's a training, so we can have kept it simple, right? So here you are downloading data from my public cloud, right? So look at the URL, storageaps.com, elephant scale public. See, this is our public bucket. And basically all the data we upload here is public, right? I have it set up as a, remember the permissions, right? I set up as a public bucket, right? So what you're going to do, you're going to execute these commands, right? You know what? You can actually copy the whole thing, right? All 3 wget commands, copy, and then paste in your Google Cloud, right? And the last one, you hit enter, right? See how fast it was downloading, right? Because remember, these public clouds has very good bandwidth. Okay. So I'm kind of simulating downloading large data sets. I mean, how large are these? Let me see. Yeah, they're about 66 meg. I mean, not quote unquote large, but imagine these are like gigabytes in size, right? So that's what we are trying to download. So basically, I have, right? I have all the files I have downloaded. Now what I'm going to do is I'm going to upload to my bucket. So remember, we are using command line, right? So the command line we are using is gsutil. Okay. So gsutil is a command line interface for Google Storage. So Google Storage util, right? So go here and type gsutil ls. ls basically means list buckets, right? So it says, oh, I have one bucket called suji2. Okay. So what we are going to do, right? You can also actually look at, create, excuse me, create a new directory into this. So these are just screenshots kind of showing you different LS, right? So let's store this here. So we are going to copy, right, our files into bucket path. All right. So here's a command. Okay. So let me actually open this editor so it's easy for you guys to see. Okay, there we go. Let me also make this a little larger. Okay. All right, so I have the data downloaded in a bunch of CSV files downloaded. So what we're going to do, we're going to basically upload into the bucket. All right, bucket. Okay. I'm going to minimize this. All right. So take a look at what I'm doing here. So I'm saying gsutil, right? Copy all the CSV files, right? gsutil. So my bucket name is Suji2. So I'm going to say gsutil. Again, I'm just following the same command, just basically copy paste in the command, right? Copy in the command. Oops, made a mistake here. Like that, okay. And then what's the bucket name? Copy this bucket name. Okay. But I want to also put a directory name. I want to say flights data. Okay. So. Okay, so what am I doing here? Again, I just simply copy this, right? And all you have to replace here is, guys, you have to replace it with your bucket name, right? So, and here's, let me explain the command. gsutil, right? This is the command line utility. Copy. I'm copying all the CSV files, right? I have 3 CSV files right now. It could be, 30 or 300, whatever, right? I'm copying them into this location. So look at the URL. So this is my bucket, top level bucket, Suji2, and I'm giving it a path and say, copy it into flights data directory. That's it. Okay. See how it's copying, right? Okay. Excuse me. It says operation completed 3 objects. Total size is 194 megabyte, right? So you can go to the bucket URL, refresh. See flights data right here. Should have 3 CSV files. Pretty cool, right? So again, big picture. What's the big picture? We are downloading some large data set from our edge node. And from there, I'm pushing it into Google storage. Right? Because why does this work? Because the reason this works very well is, let's say this public data set is like hosted in, some NASA website, right? They have pretty good bandwidth here. So you can download files very quickly. And once the data is in the edge node, this is supremely fast, right? Pushing into Google bucket, you guys know like Google has a pretty amazing network internally, right? So once you're in the Google Cloud ecosystem, uploading is very, very quick. That's why this works really well. So that kind of makes sense, guys. So if you want to understand the big picture, the rest is just just details, right? What the commands are and all the stuff. So that's it. All right, guys. So if you guys can do this, that completes.
Sorry, I have a question here.
Sure, please.
Where do you get on that path? There is the bucket path here. So where do you get the bucket path?
Oh, so okay, good question. So what you want to do is you want to say gsutil.ls, right?
Okay.
So if you do this, it's going to give you the bucket path.
Okay, got it.
Okay. So let me run this again, right? This is your bucket path, right? And of course, yours going to be with your name, right? That's that.
Yeah.
Yep, exactly.
Okay.
So just replay. So start your path with just that. And then, honestly, you can give it any name you guys want. Doesn't matter. After the bucket path, it's completely, whatever you specify.
I have a question.
Sure.
So the edge location server that we have, it must be having some limits on the how large a file we can download to it.
That's right. So let me show you. That's a very good question. Let me show you guys this. So let's see. Let's actually find out. Right. So right now they have, see the file. So the root file system, they have about 46 gig capacity. Yep.
But they use 35 GB.
Oh yeah, exactly. Yeah, because now I have a bunch of other files like that. So exactly. So Overall capacity they give is like 46, and I already used it in 35, so I only have 11 gig available, right? Because I have bunch of other stuff in the right. So if right, let me see, right? I have a bunch of other stuff in my other directories. That's why. So I can have like 10 gig available. That's a good question. So
if it's something bigger than this, how would you handle that?
Good question. Can I throw it out to the class? So let's say this Cloud Shell has limited storage. I mean it's decent, but not huge. How will you guys? Let's say I need to download like a huge file that's bigger than this, and push them to Google Cloud. What can we do?
So compute node.
That's right. So what you want to do is then spin up a compute node, right? So you already know how to do this, right? Remember when you create a VM instance, right? Remember you can specify the disk size, anything you guys want, right? Whatever, say 2000. Yep, that's what you would want to do. So this way, that's why I showed you guys this one first, right? Because sometimes even if you're not going to be using compute, you need the compute node just to kind of do some some of these this basic data processing stuff. Make sense? Yeah. So spin up a compute node with as much memory, disk as you guys want, and then download and upload. Yep. Great question.
I ran the df command, and I also have 35 GB used up. I also have 11 GB left.
Oh, actually, you know what? So actually, it's even like home directory, right? They, see that. So that's what I am under, because I only have, this much. So you may not be able to write to the entire root directory. Yeah. Because remember, these are kind of, how do you say, throwaway machines, right?
Right.
So for example, if you don't do much here, they will disconnect you from the machine. And the next time you go back in, they reconnect you, right? Yeah. So uses as kind of a scratch, the term I use is scratch space, as in like, just kind of temporary stuff, right? No, I wouldn't do like, like,
so for
you need to save something.
For small, medium, like 1 GB, up to 1 GB or 2 GB,
yeah.
you can use it.
Yeah.
But anything bigger than that, we should spin up our own server with a bigger disk, and then we can run the commands there.
Exactly. Yep. Yep. So, and that's why we started with the compute node because like I said, sometimes you need to kind of have your own instance that you want to control. Yep. Exactly. Very good.
So in my organization, like when I was doing the AWS, we used to do the same thing. We used to spin up the servers, do the processing, and then shut down the servers.
Then shut down. Exactly. Right. Yeah, exactly. So yeah, kind of like so this way you don't have to keep it running, or you don't have to maintain it. Just use it. So I kind of call them throwaway servers, kind of a harsh name, but it's what it is, right? You just spin up, do your work, and kind of shut it down. That's it, right? Yeah.
And what is your automation technology? Because everything has to be scripted, like starting the server, shutting it down. It has to be scripted. So what do you use for Google?
So for Google, honestly, I just use shell script with the G Cloud. So Google has a, let me show you guys this. Their API is called G Cloud, right?
Okay.
So you can actually install. Let me show you guys this. Install G Cloud SDK, right? And then if you go to the page, they have the native API for pretty much all the system. Like if you're on Windows, right, Linux and Mac, right? So what I have is I have a G Cloud SDK installed, and you can just put it in a shell script. So I'm pretty comfortable in shell scripting, and that's what I use. Yeah. So, and the beauty is, and here's a beauty, right? So, for everything, they will give you a remember, so let's say I want to create a VM, right? Let's say you sort of set up all your stuff in the UI, and then you go to the end, and then you click on the command line. They will be the exact command line that will create the exact instance. See what I'm saying?
Oh, very nice. Okay.
That's exactly. So, and this is one thing I hear in AWS, like, you have to kind of guess what this command is like, what I mean? Like here, what I do is I just go and like, set everything in the UI, say, okay, now I want this my name, blah, 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 right? I set up all this stuff here, and then finally go and say, all right, give me the command line. Copy, put it in my script, done.
So in AWS for scripting, they call cloud formation.
That's right. Yep.
But here you don't need that.
I use Bash. Because that's what I'm comfortable in. My partner, he uses Terraform. Are you familiar with Terraform? So
I've heard of
Terraform is like this DevOps, like a cloud neutral DevOps thing, right? So you can use Terraform to spin up instance on Amazon, Google, whatever. It's cloud neutral. It's very capable. Terraform. Let me put the link here. Yeah, this guy. Yeah, I'll put a link here for you guys. Yeah, take a look, right? So basically, this is like, you can script anything you want in this here. And you just specify the cloud. So you say Google Cloud and Amazon Cloud. And then you say, I want 10 instances with this spec, and they will go spin it up. Yep, Terraform. And this is like the latest DevOps thing. I don't know if you have any DevOps here. And I like to hear if you guys use anything else. Any other tools for DevOps? And I used to use Puppet and Chef way back when, but I know now this is the darling. I hear Terraform. Yep. Cool. Very good, guys. So let's go ahead and complete the lab, right? So basically, again, big picture, right? Kind of what we are doing is we are doing C, transferring large data sets into Google Cloud. Kind of, we are downloading into Edge node, and this could be, this could be your, this could be a compute node as well, right? Some, your compute node, right? Download here, upload here, right? That's it. Excellent. Guys, what else? Okay, that's storage.
Could I ask a quick question?
Please, yeah.
So I'm trying the online console uploading the data, CSV files. It's erroring out, whereas this one using the terminal, it copies and I'm able to see the files.
Oh, so just so I understand, like from the terminal is working, but from the UI is not?
Correct.
Yeah, I had the same problem, I don't know if you guys noticed this, like, when I was trying to do this earlier, I had the same problem too. It's like, the best I can guess is like some permission migration is not complete or something. That's why, it's, it's erroring on the UI. Usually, after an hour or so, it kind of, it starts working. So
okay.
the permissions are not in sync. And again, I've seen this like very rarely, once in a while. Not enough time, so I can spend time to debugging it because it usually starts working after a few minutes. So I can have, I can have, choke up to cloud. Yeah.
One of the reasons could be there was an option upload file or upload folder. So if you want to upload folder, you should take the option upload folder.
Yeah, also I see the documentation, only Chrome is upload folder is supported. Only
probably,
via
yeah.
Chrome. So
I'm sure they use like a browser-side JavaScript to do this. Yeah.
Okay.
Honestly, now I've seen this, sometimes the upload's gonna fail, but usually after a few minutes they work. My guess is like some of the permissions don't sync up or something, right? And then after a while they all can start working. Yeah. So
I hit refresh.
Yeah. So maybe can do like a hard refresh to reset the permissions. Yeah, exactly. Yeah. So we'll say hard refresh, shift and reload, right? So good, guys. Anything else? So we're gonna wrap up storage. So we covered two basic terms, right? One is compute, right? Which is the first part this morning. And then right now we did storage. So now we know how to upload data into Google storage. And next step, so if you look at the sort of the lab hierarchy, right? This is how it's going, right? So right now we're going to focus on infrastructure, right? So we covered cloud compute and also storage. So these are two taken care of. Next thing, we are going to go into data analytics. Now that we have data in the cloud, how do we analyze data? Right? So hopefully the cloud flow makes sense. Yep. Good, guys. So let's see what I'm going to do next is data analytics in Google Cloud. So this is slide deck number 8. Let me see if you have this. Yeah. All right. So this is slide deck number 8 for you guys. We want to do data analytics in the cloud. Before we go to the next section, any questions on the previous compute or cloud? That's going to take a minute. Do you have any questions? So to log into the console, okay, so here's the question. Just asked me, how do I log into my VM using SSH key? Here's the thing, right? Sorry, I deleted my instance, but basically what you can do is, remember, let me see if I have something running on a different project. Yeah, right? So simplest thing to do is, I wouldn't bother with SSH keys. I would, right? So if you, so a couple of things you can do. So in SSH, so sorry, how did I get here? I'm sorry, let me show you guys this real quick. Right. So here's my running instance. There we go, right? The simplest option is simply click on this, right? It'll actually SSH you right in. No, don't have to deal with any keys or anything, right? And this is really works really well. So that's one option. If you really want to use SSH keys, there's an option here. We're right? See, use another SSH client, okay? And they will kind of give you the key, right? So they can kind of follow this, right? You kind of follow the steps to log in through using, for example, using like PuTTY or something. But honestly, I don't even bother with PuTTY and things anymore, right? Because like here, like the browser-based SSH works really well. Just single click and I'm logged in 2 seconds. Okay, but if you want to script it, let's say you want to put in a script, then what I would recommend is don't use SSH, use gcloud command. And this is, remember, Google gives you the gcloud command for all the operation, right? This is very nice of them. So this is how you log in using gcloud, right? So if you want to script it, I wouldn't bother with plain SSH. I would just use gcloud. Yep. All right, so there are a few options. Again, so simplest option is just web-based SSH, right? No must, just one click and you are in. If you need to script it, use the gcloud version. Okay, that's what I say, guys. Yeah, very good. So let me switch back to my current project. Does that make sense, guys? Yeah, hopefully I made sense, right? And if you're coming from Amazon, you will appreciate how easy this is. In Amazon, you got to get the private key, public key, firewall stuff, and there like so much thing you got to get right before you can log in. Right? But here, just single click and done. All right, guys, any other questions? Storage, compute. Okay. So now let's go analyze some data. So this is data analytics in Google Cloud, slide number 8 for you guys. Right. So now that we have data into Google ecosystem, I'm going to show you guys a few tools that they have to analyze data. We're going to look at Data Studio. This is a lot of fun. BigQuery and Google Colab. Right. So, and Data Lab is the same thing as well. I'll show you guys. It's pretty simple. So, but these are the three main things I want to highlight. Okay. So let's go and cover Data Studio. That's slide deck 9 for you guys. Google Data Studio. Okay, so here's Google Data Studio. Let's see what this is. So Data Studio is really created so we can actually analyze data on a very, basically cloud-based, like Tableau. Like if you're familiar with Tableau, think about a Tableau. Right? Very easy to use, right? And so I'm a big fan of data visualization. Sometimes, so for example, if you're on Reddit, if you're a Reddit user, there's a subreddit called Data is Beautiful, right? So there are people post some really awesome stuff. Let me show you guys some of the some of the things they post and Reddit, right? So okay, obviously they were like so how do you say because right now there's like a lot of COVID-19 related right related right. So I'm trying to find a nice URL. Huh. Oh, there we go. Right. So here's kind of the sort of COVID-19 cases. So you can sort of you can sort of rotate the globe and kind of see these spikes are like the how much of the infections are, right? Let me see if I can find something else I liked. Anyway, so I'm not going to
What's
spend too much
those
time for you
charts?
guys.
Can you pause here? Go a little bit up.
This one here.
A little bit up. One more.
Oh, this is interesting. Okay.
Oh,
you mean this?
One low. No, one lower. This one. These bars. I see some animation, or maybe if you press the play button, like these bar.
Right. This is some. Yeah. This is some of the. Exactly. They're like the progress of right.
Yeah.
You can sort of see here.
What do you call this chart? Like the chart which varies and the bars change and all. Do you know the name?
I know this one. I heard it's like animated bar chart, right? It's like, so what they do, like they do bar chart over a period of different time series, right?
Yep.
And then kind of put them in animation, and this is pretty cool. Like you can sort of see like what is it?
Absolutely love this way of presenting.
Yeah, pretty amazing. Right? You sort of see like over the time, right?
Yeah.
And you sort of see like I think US should be coming up anytime soon. I think, right? Anyway, pretty cool, right? Anyway, so
yeah.
The links are in your see US is kind of coming up, right?
Yep.
The links are in your, and here's a nice thing. This is air pollution in China. You can sort of see here, right? It's like, how the air is clear because there's no factories are working, right?
Yeah.
So yeah. So anyway, so this is one of my favorite pages. Kind of go and sort of see what people are doing. It's called Data is Beautiful, right? So, you can have the link. Take it out.
So what technology do they use to produce these charts?
Yeah. So I'm going to show you guys one. Which is the Google Data Studio, right? Which is kind of pretty cool stuff. Some of these animations, I think they are doing either some Python library. So the static charts are fine. For like animation, they use like some sophisticated library in Python to especially do animations, right? So things like that, for example, right? So, and sometimes even Tableau has some pretty neat visualizations, right? These are called time series or elapsed series, right? So anyway, now you see like a lot of coronavirus specific stuff kind of coming up. Yeah. So yeah. So these are like just like a time lapse, right? So cool. Anyway, so yeah. Anyway, so you guys can I mean there's a lot of cool stuff here. So I'm not going to spend too much time on this one, guys. But yeah, you can explore this one. So, and you guys are asking, what do we use, right? How do we create this nice looking, right? Neat looking graphs. So I'm going to show you one tool, which is Google specific. So first, let's look at some of the graphs, right? Just so this is, you guys probably have seen this. Is a very, very common. It's called heat map, right? Or color map. So this is very common. So here it's like population density per state. So kind of color wise. So imagine, rather than just just if just giving you like an Excel spreadsheet with a bunch of numbers, if I turn into like a like a heat map diagram, it's much easier, right? People say, oh yeah, I get it, right? I can understand like what are the highly populated states and what are the like least populated states, things like that. Okay, so these are called color maps. Okay. Next one, this is one of my favorites. So this is US debt. So if I told you something like, oh we are like whatever 20 trillion or something, it's very hard to visualize. Right? What does it mean, right? But if you put this like this, you can see, right? It really puts things in perspective. Right? So how much revenue and how much debt we are in. So a good visualization, right? It's just not showing numbers, but also kind of superimposing data with some other cool, other thing people can correlate. Is that gonna make sense, guys? Right? So this is one. And this is another one I picked up from the Reddit. Is basically, Australia had this huge fire last year, right? And they kind of said, hey, this is how much area that is burned. And they just kind of, right? Yeah, just gonna give you perspective. So, right, burned areas like little one, and the smoke areas like this much, right? And just to give you an idea of how much damage that was done. This is pretty cool, right? So take a look at this one. So digital cameras, and then cell phones. So would you make an decision like you will say, now the smartphones are very capable cameras, digital cameras are kind of falling, sales are falling? Is it a reasonable assumption to make from this graph? Yeah. And look at the time too, like, kind of digital cameras kind of, right, 95, like 2000s kind of when they're really kind of spiking. Maybe like 2009 has been the top. And then the sort of the, digital smartphones are kind of really picking up. 2000, iPhone came in when? 2008, I think, 2007, 2008. And you can see the steady rise, right? And then the people are not buying cameras. People are like, yeah, hey, I can just take great photos with my phone. So that's pretty neat graph, right? Again, shows you time, right, with two different axes. Okay. How about this? I always love this one. I mean, as serious as it is, I thought this was a pretty clever graph. Can you just take a minute, see what it's saying?
Wow, that is just
right. Yeah. So anyway, I don't know. It's kind of laughing, but it's not a laughing matter. But you guys get the idea, right? It's like,
I wonder if
I mean,
life insurance companies use this.
They definitely do. They definitely
will,
do.
yeah, maybe one of the questions they will ask is how many times do you go to Waffle House, right? Yeah. So anyway,
no, they use zip code as a surrogate for geography here in this case.
Yep. And then they can kind of correlate exactly kind of behavior from the zip code, right? Yeah.
But it's correlation here, not causation. Well, maybe both.
Yeah, exactly. So that's why I always put this in kind of like, just because they kind of look like, they're correlated doesn't mean like, doesn't mean like Waffle House causes, heart attacks. You know what I mean? Right. so anyway, so some of the graphs are pretty interesting.
Now we are in, when we talk about data visualization and data analysis, now we are in statistics territory. So there is a phrase in statistics which says correlation does not guarantee causation.
Causation, exactly. I think I had it somewhere here. Anyway, yeah, exactly. Correlation or causation, right? Exactly.
Yes, exactly.
Just because two things look like, they are the same, like, like the
camera one is causing
right?
the other, or they are co-occurring. So I think there is a very interesting chart similar to this Waffle House thing I've seen where there is, if you plot, I think deaths because of drowning and ice cream production, ice cream sales, they are correlated. So you can say that ice cream causes drowning, but it really is that, okay, in summer months people consume more ice cream and also they swim, so they drown more. So.
Exactly. Actually, yeah, I've seen this too. So just so everyone's benefit, like, so basically there was somebody did the graph saying, they kind of did a plot like this, just to kind of show you, right? Like one is like number of ice creams sold or something, and then like some of drowning death or something. It was like this, right? And then you can say, oh my goodness, right? Eating ice cream causes you to drown, right? No, it's not. It's basically, in summer people are consuming more ice cream, and also they are going to vacations, swimming pools and swimming in the ocean, and so exactly, right? So that's why you got to be very careful. Correlation. This is a correlation, right? Just because correlation of summer, right? Summer people are eating more ice cream and venturing into the water, but not causation. That's a great example. Yeah, thanks for bringing it up. Yep. All right, guys. So we're showing you guys some pretty interesting graphs, right? So let's see how we can produce our own. So meet Google Data Studio, right? Data Studio is pretty interesting way to kind of visualize data, right? So like I mean, the best example I think of things like Tableau, right? And then also they are like pretty nice templates. And honestly, if you go to their web page, this is the kind of graph they show, and it's people think, oh, okay, that's boring, just like some, whatever, right? It doesn't look very appealing, right? So let me show you guys some of the cool things you can do with the Google Data Studio. Okay. So the way we have to think about it, like, first you have to define where your data is coming from. Okay, so you define the data source. Sorry, I know, I got the Tableau spelling wrong. I'm sorry. Yeah. So where the data is coming from, and then I create a report, and then you visualize it. So like 3-step process, right? So data source, report, chart.
Excuse me, what are the charges for using this product?
This one, the basic tier is free, I believe. And also they start charging you based on how much data you process, right? Okay. Because when you, right? So you can start with this, excuse me. And then, if you're like, because they had to crunch the data somehow, right? And for that, they use the compute resources underneath. And you are like a basic free tier, and you can look at their page and see which is a free tier. And if you go beyond that, they will start charging you. Yep. Yep. All right. So let's look at data source. Where's my data coming from? So data source can come from data cloud storage, and this is why we uploaded our data to cloud storage, right? So, but not just cloud storage. You can pull data from, say, BigQuery, right? Or you can pull data from, you can even upload a file, even Google Docs, Google Sheets, or even MySQL. So your data can come from any of these. I mean, there are tons of data sources supported. This is like, you can see that, like, I'm just showing you just a few, right? So data can come from any of the data sources, okay? And when you do the lab, I'll show you guys some of the other data sources available. And also, not only that, these are Google built-in data sources, but also there are a lot of third-party vendors already added data sources. For example, let's say, especially like a lot of the ad thing, right? Like AdRoll, right? AdRoll is the one used from ad campaigns. They have a connector. They can feed data into Google Data Studio. And what else? Like, oh yeah, here we go, Amazon ads, right? So if you're displaying on Amazon, like displaying on Amazon website, right? You can also feed the ad data into this one. So you see like a lot of ad-based people, they have connectors, right? So you can feed data into Google Studio, even QuickBooks, right? So anyway, so there are a lot of connectors available.
So these are essentially APIs. Is that what it is?
So let's say you want to connect your QuickBooks, right? So you go to Google Studio and say, hey, I want to pull data from QuickBooks, and they will basically have you authorize your QuickBooks account. You know how you like, these apps, they say, sign in with Google kind of a thing,
Yeah.
right? Yeah, they say, oh, okay, now, and Google say, okay, do you want to allow this app to read your data, yada, 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 same thing, right? Same process, you go to Google data source and you say, I want to pull data from QuickBooks, then you'll authorize by logging in, so logging in basically usually to pull data from QuickBooks or Facebook ads or any of these guys. Yep, that's how it works.
So this is kind of like Power BI within the Google environment.
Basically, yeah, just like a thing like a little Tableau, Power BI, click view kind of a thing. Okay. Yeah, exactly. Yep. Yep.
And you set up streaming data and refreshing
not
charts.
Here.
No?
Actually, yeah, streaming data is not here. There's a special display for streaming, right? Yeah. I don't think we are covered in this class, but I'll give you some links. You can check it out. Yep.
Okay.
Okay. All right. So, a lot of the time when you go to the Google data page, they kind of show you this page. And you're like, okay, yeah, this is interesting. It looks like an Excel spreadsheet, right? But let me show you guys some interesting stuff. And here's the link I want you to check out. All right. So here, one second. Okay, here's a link for you guys. Okay. I'm putting this into, it's on your slide, but also I'm putting in the Zoom window as well, chat window as well. Can you guys go to this page? All right. So this is a kind of a, this is a guy who created, Night and Shyamalan, like the guy who did Sixth Sense and, all these cool movies, right? So he basically said, what happened to Night Shyamalan, right? And then he basically started sort of plotting, his movies and how much money they made, right? So, and he has kind of the right, and he started building a what do you call like a storyboard. And he did this using, like, if you click on this, you sort of see, right? See, you can sort of move your mouse over and all that, right? It's all like, kind of dynamic, right? And if you're on the Google Cloud page, you can actually edit this page as well, right? I don't know if you give it permission, but okay, yeah, probably you can. Some of them you can actually start editing this page. Let's see, no, actually, yeah. Not this one, but you'll see some of the other report, they will allow you to edit that report. So he said, okay, 6 cents, 99, right? It's crossed like, almost like what? Almost 500 million, right? And that's a huge hit. And then Unbreakable happened, right? That got close even higher, right? But also here it just shows you what the budget is. So 6 cents was, budget was like, 40 million. Unbreakable, the budget is 75 million, right? So go to next. You sort of see the next button right here, right? It's kind of hard to see. There we go. Next button, right? then can I just analyze, okay, how much money we spent and how much money they made, right? So you can sort of, look at the, look at the time series, look at time series, like, so you can, for example, like, for example, okay, so 6 cents budget was 40 million, but it really made like, 500 million. But look at the next one, Unbreakable. Since the first movie was a big success, you can see, right? People throw a lot of money at this, like 75 million, but it didn't really make it that much money. It's only made 150 million, right? Compared to, compared to sort of the, like the, 500 million 6 cents made, right? So when you put these things in, this puts things in perspective, right? And look at over here, right? So what is this movie? Like The Last Airbender, they spent 150 million
Suji,
budget.
how did you get to this page?
Oh, next page. So look in your Zoom window. You have the link, right? So that's on your first page.
Yeah.
And
Okay.
then at the look at my mouse, lower right corner, you see a next window. Yeah.
Hey.
All right. All right. So again, I mean, if you guys move up, I mean, this is all dynamically generated graph, right? So he pulled the data from like a spreadsheet or something, and then he's kind of doing like a storyboard. Pretty cool, right? And you can sort of move your mouse over. You can sort of say, how much money they made, what's the revenue, what's the percentage, right? All that, right? And this is the return, right? So the return is like 6 cents, was like 700% return. Like, so if you're an investor invested money in 6 cents, right? We look at the, right? You only spent 40 million, but the movie got like whatever, right? 500 million. So your return is like that much, right? And then so on and so forth. So you can calculate all the returns. See here, right? Anyway, so you can create some pretty cool stuff with the data studio, not just boring pie charts and bar charts. That's all I'm saying, guys. All right, go to next. Right. And here, what is it? Right. So kind of again saying, okay, so this is like superimposing IMDb rating, right? So like 6 cents got 8.1, and then 7.2, and then the movie's kind of getting like right? They're not getting all that all that great. Yeah. And he's gonna say, hey, 2/3 of the films are really below average. Yeah. So pretty cool, right? I mean, so the way this person kind of really built the just data, but the reason I'm showing it this to you guys is like how you present the data, right? If you just do like a little Excel spreadsheet, people kind of eyes gloss over and say, oh, okay, yeah, I see some numbers, but I don't really kind of connect it. But right, but if you kind of put in a nice form like this, it's very appealing, right? So the reason I'm showing you guys is like I want you guys to create some of these storyboards like this as well, right? Doing Google Studio. All right. Okay. Anyway, what else? So okay, so this is basically Night and Shyamalan's, right? Excuse me. Right. Movies kind of. So anyway, so you can sort of you can sort of keep clicking, and there's like a lot of ways it's kind of spacing, right? So anyway, he shows you like where they hit the data and everything. Okay. Pretty good. All right, that's one. So this is Night and Shyamalan. This this is a fun one. Here, let me put the link to you guys here. Here's a link, and you guys in your Zoom window. All right, here we go. Take a look at this one, guys. So this is UFO sightings, all right? Anyway, so I thought this is kind of a funny one, right? And you can and see there like it's a lot of things like here he's doing like a state map, right? A heat map, So apparently anyway, like we tend to get more sightings in the sort of the northern states. Looks like, yeah. And then right, what are people seeing? Are they seeing light? Are they seeing circles? Like fireball? and then what months, right? Like January, February, like all the stuff. So anyway, I thought it was a pretty cool, just, and again, don't worry about the data, but think about the visualization, right? I thought it was pretty well done.
The aliens like Saturdays in July pretty good, it looks like, right?
Obviously, yeah, obviously they, so yeah, obviously they don't, they like the warm months. Yeah, exactly. Yeah. That's right. There you go. Yeah, June, July. Yeah. So this could be, another thing people say is like, hey, summer months, people are like lighting fireworks, you know what I mean? Things are going on. So other people are misinterpreting them as, UFOs, right? You could make an argument like that too. Right? Anyway, but but when you kind of plot the data, you sort of see some patterns, right? Yeah, that's kind of the takeaway from here, I think. Yeah. Guys, so that's great. Let me see. Okay, so now that we have seen what other people have done, so let's start doing something on our own. Okay, so here's that report. Okay, it's a little less exciting than looking at UFOs, but at least this one you can actually modify on your own, right? So here's a link. Look at the Zoom window. Modify this. Okay.
So, Suji, is there a difference doing these visualizations on Data Studio versus Tableau?
So Data Studio is basically web-based, right? And you can do, all your data can be in the Google Cloud. Tableau, I know Tableau, they have a cloud offering, right? But also, so it's kind of like, I think it's like Google's, they're trying to compete with Tableau, I would say, at least at least in the lower end of the market, right? Because I know Tableau can do some pretty nice visualizations, but for a lot of people, the basic data visualization is pretty good.
So if Tableau has to do a visualization in Google Cloud, so does Tableau needs to be installed in Google Cloud, or?
I believe Tableau has integration with the Google Cloud, so they should be able to read directly from Google the bucket. So if you have Tableau running, right? Mm-hmm. So you should simply connect Tableau to the Google Cloud, because it's one of the data sources, right?
I see.
And then you authorize Google Cloud, Google bucket with Tableau, and they can pull data from there. Yep. Yep.
Okay. Thanks.
So I would kind of put this Data Studio between Excel and Tableau, right? Which is plenty for most people. Yeah. Mm-hmm. All right, guys. So this is the graph. I mean, so this is the.
So I have a question here. So
sure.
Since you mentioned between Excel and Tableau, then is it whatever is Google's version of Sheets, what is equivalent of Excel? Does that not have good visualization, as good of a visualization as this?
No. I mean, with the Google the Excel spreadsheet, you can do some basic stuff, like your basic pie charts, bar charts kind of a thing, right? Just like Excel, but not as interactive and sort of nice looking as these, like sort of the ones I shown you guys. You know what I mean? Yeah.
So I see.
So okay, so here's the traffic report, and I put the URL in the Zoom window, guys. So if you just go there, what you want to do is you want to say explore. Where's that?
Does AWS has an equivalent visualization tool?
I believe so.
Yes, it's called
Studio.
Yes, Slice or Spice, something Slice.
Something like that. Yeah. I remember. Yeah. I haven't used it personally, but I'm sure they do. Yep.
But it's not that good.
I know, actually.
So is Tableau is the highest level of visualization according to your experience?
Tableau is good. I mean, because they've been at this for a long time than anybody else, right? So I mean, their graphs are pretty sophisticated, and also a lot of people know how to work Tableau, right? Because there's like a good user base, and like a lot of the graphs, they've like, for example, I remember like some of the density graphs and things like that. They first published it, right? And then everybody kind of copied. So Tableau has a pretty good history on visualization. The thing is, I mean, right? It's a kind of a proprietary product, and it's not cheap. So people are always looking for something like, hey, I don't need like Tableau quality, but something better than Excel. I will see. No, I know it's good enough for me. I think that's where these guys fill in, and I think this is Google's way of kind of competing with Tableau, right? To an extent. Yeah.
So
And
Tableau
it's
is
all
like,
cloud-based.
sorry, Tableau is
Yeah,
like
go on. Yeah.
$50 a month license
That's
cost.
subscription. Okay.
Yeah, $50 a month. So, and if you
That's
want
for the
server, that's separate. Server
exactly.
is like thousands of dollars. So that's why
Right.
I asked you the pricing on this one. So the pricing model is different of Google.
Yeah. So the pricing model, you have to kind of look at this and say, they have like a tiered model here. Let me see if I can find the link for you guys. Right. Yeah. All right, guys. So
Also, yeah, sorry. I was going to say that I've used Google Data Studio for digital marketing, and you can do, like you showed, you can do amazing things that, really easily, versus where Tableau, there's a bit of a ramp time.
Right. And also, one thing I always liked is, let's say you build a dashboard, you can very easily share with people, right? With Tableau, I understand you need a server edition to do that. That's my understanding. Maybe somebody can correct me.
That is correct. Yes.
All right.
Yeah, that's correct. At an enterprise level, you have to have the server so people can publish and share.
Yeah.
And then they have the desktop version. Yeah, so it's not cheap at all. I just worked in an organization that with a huge Tableau community, and yeah. But that's the thing, is once they settle on Tableau, then they built a lot of competency around it, and then
exactly.
it's
very hard to move away from it. Yeah, it's very hard to move away from it. Right?
Very hard.
Yeah, exactly.
Yeah.
So one thing you're kind of finding is like especially from Google perspective, they're kind of building everything to fill these like little like a needs. Right? Okay, people say, hey, they said, okay, people said, okay, you build compute, you build storage. Now give me something I can do some nice charts, right? So they may not need to do 100% Tableau. Even if they do come like 60% close to it, a lot of us will take it, right? So yeah. So that's what it is. All right, guys. So sorry. Before I get too much into this, can you guys do this for me? So you saw in this page, right? So click on a graph, right? So I think right here, see like a little like a 3 dots drop down, and please do explore, right? So it's kind of hard to find. Like you got to sort of like you can pretty much click on any of the 3 dots, any of the graphs. So move your mouse over, you see like a 3 dots on the top. Click on explore. So what you can do here, and this is pretty neat, is you can sort of start from this data, and then you can do your own visualization, right? So we're just getting started. So maybe say, what, I don't like this line chart. I want to do like a little little bar chart. There you go, right?
So
Pretty
Fuji,
cool.
how do you navigate to this from the console? From
here. Are you here already?
Yeah, I mean, I'm clicking on the link that you paste in the chat, but I'm trying to figure out how do you go from.
So yeah, move your mouse over in any graph, right?
No, I went.
Explore.
Is there a way from the console you can get to this datastudio.google.com? Like.
Oh yeah, sure. I mean, yeah. So in your console, it's actually, let me see. They keep rearranging the links on me all the time. So you got to go like visualization somewhere here. I can now find this thing here. So tools, Data Studio.
Yeah, we just crossed that.
I think so. Yeah. Visualization somewhere here, right?
Visualization, yeah, artificial intelligence, right? Under that.
There we go. Oh, okay. Yeah. Data labeling, visualization. No, that's video. I'm sorry. Yeah. Anyway, so there are so much here. I wish they put like a little search here so I can quickly find this. But yeah, it's one of those. So I just type Data Studio and go here. Yeah, I know what you're saying. You're kind of trying to look for it here. Yeah, I don't know why you keep hiding it. Anyway, but just Data Studio, right? Basically, that's it. Yeah. All right, guys. So here's what we are going to do here. So we already have a report created, and he already has everything set up. So what we are going to do, we are going to just click on one of these, right? Just say explore on our own, right? So kind of just play around with it. Just spend like a couple of minutes, kind of looking at different. I mean, there are a lot of things, but at least I kind of want you guys just look at some of the graphs, right? Maybe do like a line chart, maybe like a smooth line chart, area charts, whatever, right? So, and this is like analyzing web traffic, right? Not all exciting, but it kind of illustrates the point of, right? So here's like, date and page views and everything, right? Illustrates how quickly you can sort of, you can move data around very easily. Yep. And it's pretty fast, right? I mean, that's impressive for a web-based application. So. Yeah, just a couple of minutes to kind of play around for you guys, and then we'll actually go into another lab. Okay, I'll give you some time to play around with this one. And then yeah, we'll jump into, there are 2 labs, actually 3 labs, but yeah, we'll actually try to do 2.
So it says explore no access.
Oh, like are you not seeing the explore this icon?
It's grayed out for me.
Huh. Is that the same thing for? I mean, is
Try the
anybody else having
beta.
the same issue?
Try the beta link underneath.
Okay.
The ad blocker blocks the just Explorer. You Explorer Sheets. You got to go to beta.
I think so. Okay, yeah. So they should be open to everybody. Yeah. So I was able to kind of click around and sort of explore a little bit here. Yeah. All right, guys. So let me also set up the other 2 labs, and those are the sort of the 2 labs for today. So from your lab setup, from your lab, lab index. So where we are at is here, Google Data Studio. All right. So there are 3 labs. Let's actually try to do first 2 today, if you can. So let's start with the very simple one, Studio 1. Okay. So again, I want to make sure everybody's kind of following me along here, right? From our README file, right? We are at the data analytics section. So we're going to use Google Data Studio, right? So Studio Lab is Studio 1. Okay. All right. So I'm going to go through this one, guys. Then I'm going to let you guys do this. It's 4 o'clock right now. So I'm sort of hoping to end the class by around 4:30. So that'll give us plenty of time to kind of demo the lab.
Yeah,
and
quite
if you guys
tiring
need
today.
to, sort of, you can do it as like a little homework as well. I'm sorry, question?
It's quite tiring because in New Jersey it's 7 p.m. right now.
I know, yeah. I don't want to keep you guys too long, too long. So yeah, so this is the last lab. Kind of bear with me, and then and then we'll wrap it up. Yep. So, all right, guys. So I want you guys to go to datastudio.google.com, right? Simply, open this link, right? Okay. So here's my Data Studio, and again, I'm simply following the following the instruction. So right, and what we are going to do is we are going to say create. Okay. Okay. So click on the create. And they're saying, okay, where's your data coming from, right? Remember, because you need to actually connect to a data source, right? So where's the data coming from? And you can see, right, all these data sources, there are tons of these. So we're going to choose Google Storage. Okay, right? Because we know we already have uploaded files. So I'm going to choose, right? I want to say Google Storage. Okay, create data connection, and choose Google Cloud Storage. Again, can I look at the screenshots, guys? I'm going to guiding you through here, right? Okay, so I'm saying, okay, so let's say Google Storage. Where's that? Sometimes I have to search to where this is. Oh, there we go, Google Storage. Okay, good. Okay. For the path, here's the thing you guys can do, right? I know you guys have uploaded some files into your own files, right? So go to Google Bucket. Where was that? Storage. Okay. So from a flights data, okay. So we actually want to, 1 second. There we go, right? So we're going to say GS, bucket name is Suji2, flights data. And I'm going to say use all files in the path. Okay. Sure. Bucket name. Okay. So at this, did I make it? I think I'm in a typo here. Okay. Let me see here. Flights data. Flights data. When I click this, 1 second, guys. Sorry. If we don't do this, you can actually use, right? You can actually use our, so if you own, here are 2 options, right? You can actually choose your own bucket, or if that's not working, you can actually choose our own data, right? So kind of, so, oh, I see. So the mistake I made was, they don't want the GS extension, okay? So if you don't have files available on your own directory, just use our own public directory, okay? Let me do one more thing, because, that's what I was trying to figure out. I think this should do it. There we go. Oh, they're saying, okay, so here's a free tier restriction, right? So I don't know if you can see this. They're saying, hey, you are over, 100 meg. So that's it. That's a data cap. So they can only pull in 100 meg worth of data. So if you need more than this, there's like a pay tier. You need to kind of, enable that. Okay. So by free tier, they're restricting to 100 meg. Okay. So let me just do one file then. Okay. So let me gonna go here. Let's only do, say, 2000 March CSV file. To flights data. Okay. Let me see that. Is this working? There you go. Yep, seems to be working. All right, guys, again, if you don't have your data, do not worry, please. Just use our public data, right? So you can just copy this data right here, okay? And pull it in, okay? That's it. And at this point, it should ask you to kind of, say, okay, hey, what do you want to visualize, right? So right now, what we have is, right, carrier name and how many flights they have. Okay, so kind of follow through this one, guys. So I can say, hey, you know what? Yes, I know I want all of these, right? Here's a table. The table is already created, right? When you pull in the data, they already have the table created. Okay, and then let's create some chart. So you're going to say, you know what? Okay, I'm going to do a, for example, let's say, let me bring in this data here. So that's so, this way I can do the same thing as you guys, just so we don't deviate too much. Okay. Okay. There we go, right? So this is some of the metrics they pulled in, right? And so basically the flight is like their destination country, origin country, and how many flights they went, right? So this is one table. There we go, right? And sorted by, so destination country, so you can say US, has a top flight name from here. All right. And what we are going to do, right? Connect the top right corner of the patient fields. Okay, so there we go. Connect Now, guys, I'm going to just move this insert into the next window so I can kind of, keep this side by side. Okay. All right. So here are all the data sets you guys have, right? So here you have destination country. Okay. And let's say you want to change it to origin country, right? So you can sort of, so you can see, what are the fields available. You can, you can do this and say, what, I'm going to add origin country and populate the table again, right? So you can sort of easily see, right? See it says, all the fields available, destination country, origin country, and the flights, right? That's it. And you can say, okay, I'm going to maybe do a count. So your dimension is, metric is basically, I'm doing a count. There you go, right? And you can say order by, right? Sort by, record count descending, or ascending, right? So you can sort of, you can sort of see that I'm sort of creating a simple record just by looking like almost like Excel spreadsheet, right? Looking at the available columns and creating charts. Okay. One second. Okay. And then you go to the style page, right? You can sort of style this up, again, sort of I'm just following step 4, guys, right? Go to the style page. You can sort of follow along, right? And say, okay, hey, you can sort this data, set colors, fonts, the whole deal. Okay. There you go. So that's just, basically, styling your table. So I'll, sort of leave, I'll leave that up to you guys. But let's look at it. Let's do a chart. Okay. So I want to say make a chart. So you say add a chart, right? Bar chart. So here we're going to say add a chart right here, right? So you say I want to do like a little bar chart. Here's your chart, right? And here, again, same thing. You can sort of, you can do the x-axis, y-axis, everything. So think like a little, little Excel spreadsheet, but you're sort of powering this from data from Google Drive, right? I mean, the Google Storage, yeah. So kind of, again, play around with this, guys. I'm sort of showing you a few options. Again, you don't have to sort of exactly follow the template. Once you have a chart, you feel free to sort of play around. Exactly, right? And also here, we're sort of doing like a sum, right? We are doing like a unique, you can do a filter saying, only do a filter if, flight size is higher than 5, right? If I have more than 5 flights or 10 flights, right? So again, I'm not going to sort of go through each one of these guys. So kind of I'm leaving it to you guys as homework, but I'm sort of highlighting how easy it is, right? Once you have data imported, how easy to sort of visualize the data. Okay, so. And then once your report is ready, just like this is like just sharing with anybody in Google, right? You can share with anybody. Cool. Let's see what else I want to show you guys here. Kind of follow the screenshots. Look at the screenshot because sometimes the screenshots might change because they keep changing the UI slightly. So yeah, but you should be able to kind of figure out where the what are the main buttons are.
So this is a single chart. Does it allow us to create dashboard also?
Absolutely. So what you're going to do right here is then you're going to create like a page. See, you're going to create a page, and kind of I'm just making this up, right? Kind of you can say, okay, hey, right, this is where remember the Night Shyamalan thing, right? You guys kind of did. So kind of like this. So you can sort of say, what, hey, here's a chart, and you can add some text, right? Anyway, so imagine you're like designing like a PowerPoint, right? So you see all the controls here, right?
Okay, great.
Exactly. Yeah. So kind of, I'll be the first one to admit, I'm not great at this, visualizing, right? That's why I hired a designer. but I hope you guys have more visualizing skills than I do, right? More sense of style than I do. So yeah, right. But just think like you're creating a PowerPoint page. You have the charts. You have your tables, right? Images. Anyway, you can do the whole thing, right? So you can you can do like a rectangle, whatever. Anyway, you just get the idea, right? So and then you can create page. So remember the night in Shyamalan, it was basically different pages, right? So he kind of created, right? So what it is like, he created separate pages, and he basically sort of added like, nice, I mean, obviously, he's very good at visualizing, so he can add like things like, let me do another page with the graph. There you go, right? He added all these graphs, gave them nice colors and everything, and these are like, just text boxes. You know what I mean? Nothing fancy, and he put like a little background image, which you can do right here. Where was that? Right?
Is it a responsive design? Because depending upon if you are viewing it from cell phone, will it adjust based on cell phone?
Good question. I never tried it though. Yeah, that's a great question. Yeah. So I wonder if they, I know exactly what you're asking. I need to double check my answer. Yeah, not sure. I'm hoping, this is Google, they know a little thing about web, right? So I'm guessing, they're whatever they're generating, is responsive. But yeah, honestly, I never tried it. Yeah, that'll be a good experiment. Yeah.
Well, probably there's 99% chance that they do. So.
Yeah, I'm going to say so. All right, guys. So I don't want to take too much. I know it's kind of getting late for some of you. So let's kind of do this quick. So here's the idea, right? So this is a data studio, very simple to use. Again, just, use your imagination. So we have 3 labs, but can you guys at least do 2? Again, I know it's getting late. So I'm going to wrap up the class at this point. Kind of do like a homework, if you want to stay around for like a few more minutes and kind of play around the studio, feel free to do so. Okay. But you guys get the basic idea of this, right? Basically, basic idea is this, right? You have, workflows like this. You define a data source. You create report. So what's the report? Report is like, you can say things like, hey, I don't want zip code where zip code is null. So you pull data in, right? So this is a workflow: data source, report, and chart. If you remember this, everything will make sense here. And then chart, once you have the data pulled in, then you can sort of you can go nuts, right? You can add any charts you want, slice and dice them any way you guys want, sort them, color them, all the cool stuff. Yeah. All right. So here's a homework. Can I try these two labs? And I love to see some of the visualizations you guys create tomorrow when we start the class, right? So the data is already uploaded. So again, if you don't have your own data, you can use our own data, right? So we already have the data uploaded in our public bucket. So you can use either our data or your own data.